Hey guys, welcome to Intellipaat. In today's video, we're going to talk about a technology that is a backbone of hottest job of 21st century, that is data science. So let's start this video with a quick fact. According to McKinsey, there is a 50% gap between the supply and demand of data scientists. This clearly indicates that this is the right time to seize an opportunity to land yourself in the hottest job of 21st century. So in this spirit of helping you guys to become a data scientist, we have come up with the most comprehensive video on data science. So this video has everything you need, right from the very basic concepts of data science to the most frequently asked technical interview questions. So before we get started, please do subscribe to Intellipaat's YouTube channel to get some instant notification about our upcoming videos.
Quick glance at the agenda. First, we'll understand what is data and then look into the needs of data science. And once that is done, we'll be looking into what exactly is data science and the types of data analytics available. Once we understand the very basics, that is the need and what is data science, we'll look into the life cycle of data science. Once we complete the data science part, we'll move on to machine learning and look into the introduction to machine learning. And then we'll look into introduction to regression, which is a type of an algorithm in machine learning. Once that is done, we'll be looking into Python and NumPy, and then introduction to pandas, which are two major Python libraries which is required in machine learning and also in data science. And then we'll be looking into how to crack a data science interview. And once we know about that, finally we'll give you some interview questions and answers which you can prepare and clear your next interview. So now, without any further delays, let's begin with the session.
Now, when we are saying data products, example, it could be buy or selling strategies for any financial institutions, which could be just a set of actions to improve the product yield or just steps to improve the product marketing as well. Okay. Now, performing data science, it requires us the extraction of timely and actionable information from various data sources to drive our data products. Now, the examples of data products would be like the one which answers the questions such as which of my products should I advertise more heavily, perhaps to increase my profit? Or how can I improve the compliance program while reducing the costs? Or what manufacturing processes change will allow me to build a better product, right? So the key to answer all of these questions is basically to understand the data that we have and what the data inductively tells us, right? Now, when we talked about data product a few minutes back, that we defined it as which provides actionable information, correct? So it could be example like movie recommendations or the song recommendations, let's say the weather forecast, stock market predictions, or flu trend predictions, targeted marketing. So all of these are considered as various data products. Okay. Now, when we talk about analytics, it's just a so if you try to broadly define analytics, it's nothing but a collection of techniques and tools which could be used for creating value from data, right? Now, when we say it again, now techniques over here, there are again certain jargons that we'd like to add over here. The techniques could be artificial intelligence, machine learning, or let's say deep learning algorithms. Okay. Now over here we talked about few jargons like AI, ML, and DL, right? So we'll try to understand the difference between these jargons as well. Okay, because these words are used quite interchangeably in the businesses or even in the uh, certain interviews or the blogs when we look into, right? But we do have a thin distinction between each of these jargons when we discuss about. Okay, now AI, when we say AI is nothing but so if we try to define AI, now any algorithms or systems that try to exhibit any human-like intelligence could be called as AI. Okay, so they deal with the simulation of any intelligent human behavior in the computers, right? So they try to get the ability into a machine to imitate any intelligent human behavior, which could be uh, might be the system which could be able to perform tasks that require human intelligence, be it visual perception or speech recognition, translation between the languages, decision making, right? So these are something examples where you might think which would require our intelligent human intelligence, correct, behavior wise. And AI, when we say, it could be just a pile of if then statements, or it could be a complex statistical model which tries to map any raw sensory data to any symbolic categories. Now, when we try to define machine learning, okay, so machine learning, you can define it as subset of AI. Okay, now if I just consider, let's say, so if I create a circle over here, it's a bigger one, and if I call it as AI, okay, which we just discussed. Now, the subset of this could be called as machine learning. All right, so all machine learning could be counted as AI, but not all AI counts as machine learning. Okay, so for example, symbolic logic, the like the rules engine, expert system, knowledge graphs, they all could be described as AI, but none of them are machine learning. And one aspect that separates this machine learning from the knowledge graphs or the expert system is that their ability to modify itself when they're exposed to more data. So machine learning is more dynamic and it typically does not require any human intervention to make certain changes. Okay. Now, machine learning again is we do have a set of algorithms, right? They do have the capability to learn to perform any task, which could be, let's say, classification or prediction. Okay, so leveraging the historical data. Now, learning is basically done using any historical data or, let's say, the models that we say it is. Okay, and algorithm, we call it as learning algorithm when it improves on a performance metric, okay, while performing a particular task. So for example, accuracy of a classification model, such as, let's say, you're predicting fraud, or let's say the customer will be getting churned or not, right? So we'll try to discuss more in details that when we go for machine learning, or why we need machine learning as well, and certain applications of those. Okay, now next, if you try to subset again machine learning, you could call it as deep learning algorithms. Okay. Now, deep learning is subset of machine learning. So usually whenever people use the term deep learning, they typically refer deep artificial neural networks. Okay. So with a certain differences in the architecture of neural networks itself, you could call it as a deep learning. Okay. Now, deep learning is more of a, like, you could call it as a branded term of neural networks itself. Okay. All right. So this is something you could define it as deep learning. Now, when do we go for deep learning algorithms then? So these deep learning algorithms are good where you do have huge amount of data, right? So a particular problem statement, like just now we have discussed about, let's say, fraud prediction. Okay. Now, whether a particular credit card transaction was a fraudulent or not could be solved using, let's say, particular machine learning algorithms, and could provide a decent result as well, which could be deployed in production environment as also. Now, if your data size is really huge, where it's getting into billions of data, in that case, perhaps your machine learning algorithm might not perform that well. Okay, in those scenarios, your deep learning algorithm could outperform your machine learning algorithms. So if you're working with a particular data set where you have, let's say, just a few millions of data, all right, so even just with 1 million of data set, in those cases, perhaps you would find that your machine learning algorithm could outperform your deep learning as well. So it's a kind of, again, a myth when people say that uh, deep learning always outperforms your machine learning algorithm. Okay, so it's not typically the scenario. If you do have a structured data, that means where you do have a particular set of rows and the columns, and you do have in thousands of data sets, not in something in multi-millions or even in billions. In that case, your machine learning could definitely outperform your deep learning algorithms. Okay, now deep learning are the ones which perform quite well in the scenarios where your data size is really huge. Secondly, in the unstructured data sets. Okay, so unstructured means you can consider the data sets like the image processing or the speech recognition or the text analytics. Perhaps in those scenarios, your deep learning algorithms majorly outperform your machine learning algorithms. All right. So again, over there, be it in machine learning or deep learning, there are different set of algorithms, and each of them has been developed for certain objective wise. Okay. So it's not something that if we have a particular problem statement, we use always the same algorithm across different problems or different industries as well. So it's majorly categorized into the type of problem statements as well. And you can see that deep learning algorithms, they have set new records in accuracy for many important problems like image recognition or the sound recognition, recommender systems as well. Okay, all right. So as we discussed about the different types of analytics over here, now when we talk about now where exactly then data science comes into picture, right? Now data science is again a broader term. Okay, so it's more of a like umbrella term. Now if I try to put it over here in this particular understanding, well, I will keep it over here in that case. Okay, so this machine learning or deep learning is just one part of data science. Okay, so I could mark over here this one as data science. Okay, now data science is really huge. When we talk about predictive analytics, making certain predictions, that is just one small part of your data science. Okay, so just saying that predicting something is data science won't be correct, or just saying doing some visualizing the data itself is data science won't be correct, or just saying that exploring the data won't be correct also to define it as data science. Okay, so when we say data science is a kind of, we could keep it as the science of data. Now when we say science of data, what does it include? It includes everything that you could do with data, all starting from understanding the data, what exactly that you do need out of it, extract the data from various sources, gather exactly what you do need for analyzing the or solving the problem statement, doing certain exploration and doing some visualizing the data to understand the patterns in the data set, and then moving on to making certain predictions leveraging heuristical data and checking what is the how much accuracy that you're getting to evaluate the performance of your algorithm, and then using leveraging it as a kind of data product in the end. All together you are calling it as data science. Okay, so in some time later into a session itself, perhaps after a couple of minutes, we'll next discuss into the steps that we typically follow in any data science project, okay, and across all the industries. All right, so which would give us a clear understanding that what are typical steps that we follow in any data science project. Now at this stage we have just very high level, we try to understand the jargons now. Okay, so which give us a brief overview that what all things that we have or the techniques, how we could define the data science. Okay, but what actual steps that we typically perform, that would be getting cleared at that stage when we'll discuss the typical life cycle of any data science project. All right, so when we talk about why do we need data science, all right, so that the name is as the need of data science. Now over here you could say you could definitely analyze the data from multiple sources. You could use any advanced analytics techniques or statistics to find any hidden patterns in those large data sets. You could definitely disseminate any information to your relevant stakeholders through any interactive dashboards or reports, right? You could monitor the KPIs and definitely react to any changing trends in real time as well, right? So, all right. Now, there are a lot of examples that we'll be going through throughout the course where we'll try to pick up certain examples as well at each different sessions to understand more about different type of problem statements which could be solved using data science itself. All right. Now, so next we would try to look into all different types of analytics tasks that we typically perform. Okay. Now, as we are saying that there are a lot of different type of tasks that we do, or all right, so a few of them, for example, that has been mentioned in this slide as well, like uh, doing some data exploration and manipulation, visualization, all right, so, or machine learning. How we could categorize this task in this analytics domain? Okay, so we broadly categorize all the tasks that we typically do as a data scientist into these four types. Okay, so descriptive, diagnostic, predictive, and prescriptive analytics. Okay, now these are the broad terms which you will now try to understand over here. Okay, now when we talk about descriptive analytics, okay, now descriptive analytics answers the question what happened. Okay, now over here, let's take a consideration that, for example, we consider any e-commerce platform. Let's say we consider Amazon as a platform. You could consider any e-commerce company. And if your objective is just to understand how much sales has happened in the last 3 years, okay, and you'd like to look into the numbers at a monthly level, all right, so that means your objective is to look into monthly level sales for the last. All right, now over here, if you see, the objective is just to look into how much sales has happened, right? So we are not trying to predict anything or or let's say visualize anything. It's just about just looking into the numbers and understanding that, all right, so how much sales has happened. Okay, so definitely you could visualize that as well, right? So at a monthly level, you could just create a scatter plot or the line chart at a monthly wise, and you could see that how the sales is moving across the months in the last 3 years. Right? This is something I could consider it as an example of descriptive analytics, because this just answers the question what has happened, right? And this is more specifically only with the historical data itself. So you do have some historical data and you just want to know what has happened. So if you try to take some other example from different industry, for example, let's consider a ride hailing app. Let's say you consider Uber or Ola or Lyft or any other similar ride hailing apps company. Now, if you wanted to know that, for example, in the last 6 months, how many ride requests that we have got and how many rides we have successfully completed. Okay, so these are the two metrics that you'd like to look into. Now, this is again descriptive analytics, because this is again we are talking about the past, right? So what has happened, how many ride requests that we have got and how many rides we completed, okay, in the last 6 months. So that is again something we could call it as descriptive analytics. Now, if we have a particular problem, now let's say we look into the patterns and we see that in the month of December, across the 3 years, what we see that in the pattern that the sales always shows a spike in the month of December. Okay, now what is the reason that why the sales gets jumped up in the month of December? All right? And we see that across the 3 years. So we might be now interested when we see this particular pattern. We might be interested next to look into why it happens, right? So now, when we have this particular scenario that we wanted to know why it happened, so do you think that can you think about certain factors which might impact the sales of the product? Now, when we're saying sales, so what I'm referring by sales is let's say in dollars or in the currencies that we're referring to in any local currencies, let's say. So how we are defining is the number of products that got sold. So for example, 200 tons of a particular product got sold multiplied by unit price of 10. So let's say you have $2,000 that we're talking about over here. Okay, so this is the sales amount of a particular product, of a particular product category, let's say. Now, similar to that, in a particular month, you have multiple product categories, and just the summation of all together, you are saying that this much total sales has happened. Okay, and this number is something that we are saying that at a monthly level, when we look into, we see that in the month of December, the sales has gone really high. Okay, now what factors do you think would impact this sales? Now, when I'm saying factors, let's consider one example like seasonality. There could be certain products which are having seasonal factors, right? So because of which I could see certain variation in the sales of my products. So similar to that, what other factors do you think would impact the sales of the products? Now you could think just as in the field of e-commerce itself, like Amazon, as you regularly, I believe, you do use any of the e-commerce platforms. You can think that when the sales could jump high in general. Okay, so you can think in that particular way. It would be easier for you to correlate in that perspective as well. So, what other factors do you think would impact the sales of the products? Now, you can think any factors, right? So, considering, let's say you have all the data points that you need is available with you. Okay. So, in that case, what features do you think would impact the sales of the products? So, demand, or let's say the value of product that you mentioned, that is something which could not be used to understand the factors that impact the sales. I mean, the price of individual product. So you could also think in a way that in hit scenarios, you typically purchase a lot quite often, right? Now you could also think about the factors like the product categories. Now, right? So if the sales has gone high, it need not to be the scenario that across all the products you got high sales, right? It could be scenario that for few product categories only, I could see the sales has gone high, right? For other products is as usual as it typically happens in the other months. So that could be another factor which might play an important role, right? So let's say you're operating at a product level. So if you keep another factor like product category wise, now product category, it could be broadly, you can consider, let's say it's mobile phones, or let's say laptops, or if this could be called as product subcategory. Another product category you have, let's say it would be called as electronic gadgets. Okay. And you do have, let's say, pantry products, you do have um, let's say jewelry, so you could have clothes, right? This could be considered as different factors in the product subcategory or the product category wise. Next, you can also think about the geographical location wise. So, right. So let's consider at the broader level, you're looking into one particular country for your analysis purpose. Now, in that country as well, you could have different states which could have different purchase patterns in their customer levels, right? So you could have, let's say, tier one versus tier two versus tier three cities as well, correct? So the location could also be another factor which might be interested to look into. Okay, so let's say state-wise behavior could change, or the city-wise as well, something which could be further deep dive into. Now, this particular analysis that we are talking about, this is something we call it as diagnostic analytics. Okay, now diagnostic analytics answers the question why it has happened. Okay, and the companies, they go for diagnostic analytics as it gives a deep insight into a particular problem. Correct. So when we talked about another problem statement, like in case of Uber, we wanted to know in the descriptive analytics just that in the last 6 months, how many ride requests we have got and how many we completed. So there would be certain differences, right? For example, we got 1,000 requests and we completed 800 ride requests. Okay, so 200 we missed out. So why we missed 200, right? So we might be interested to look into how many cancellations has happened. Now, again, in the cancellations, we might be interested to look into how many rides got canceled by the user and how many rides got canceled by the driver. Is there any particular time period where we got the majority of the cancellation? If it happened, is whether it happened across all the cities or it's majorly for particular few cities only? And if it happened in few cities, is it a particular time period where it got all cancelled? So was it because of the server was down, or was there any issues in our app because of which, whether it could be either the driver app issue where they were not able to accept the rides, or they are not getting the request from the user who have requested for a particular ride. So this is like you try to deep dive to find the solution that why it has happened, right? So that is something required as diagnostic. So descriptive just told us what has happened, and from that we see a particular pattern which lead us to figure out that why it has happened. And that figuring it out, deep diving into that particular trend to understand why it has happened is something we are calling it as diagnostic analytics. All right, great. Now, next we move on to the predictive analytics. Now, this is the stage, something which is pretty interesting for most of us. That's the scenario that tells what is likely to happen. Okay. Now it uses the findings of your descriptive and diagnostic analytics to detect any tendencies or clusters or any exceptions, and thereby it helps us to predict the future trends. Okay. Okay. Now, over here, considering the same case study that we are looking into, now over here, if you'd like to now predict, let's say you had the historical last 3 years, now your objective is to predict the sales for the next 1 year. Okay, so at the monthly level, that means for the next 12 months, you'd like to make the predictions. Okay, so based on the historical 36 months, you would like to make predictions for the next 12 months. Now that is something objective, perhaps, let's say business stakeholder would provide to you. And for that, you need to think of how you'd be approaching the problem statement. Okay, so this is the only single line statement that your business stakeholders might provide to you. Okay, and which would also include you a task for you that you need to think for at first that what factors would impact my sales, right? So over here, the target variable, the one that you're trying to predict, is sales, right? And for that, you need to consider, let's say, some historical data. So for which, let's say, you consider last 3 years information itself. Okay. So you picked up all the historical 3 years sales information. Now you got the sales number, but to understand or to let the algorithm understand the pattern, you need to give the algorithm features which would help the algorithm to understand the patterns, the sales and the factors which are impacting the sales. So for that itself, we discussed few minutes back that what factors might impact the sales. Okay, now that is very important stage in any data science project where you brainstorm and think about what features might impact. And it's like we spent a couple of days in the projects to just to brainstorm and think that, all right, so these are the features perhaps would impact the sales, or something we can start extracting the data for this particular features, or something we could create those features as well for our analysis purpose. Okay, now this stage is again quite important because that would help you to know that, all right, so this is the one that we're trying to predict, and these features we believe might impact our target variable that we're trying to predict. Because when we add those essential features, then only the algorithm would understand the patterns in between the independent variables. So when we are saying independent variables are the ones which we think or we keep as a variables which might impact the target variable. The one that we just discussed now, the factors like seasonality, product category, product subcategory, state, city, or and then we talked about the sales offer relevant information, right? So all these are, you could call it as independent variables. Okay, and we call the target variable as dependent variable because that is dependent on the other features. Okay, now this is just to have a high level overview what exactly we do in this predictive analytics. All right, next we have prescriptive analytics. Okay, now when we talked about predictive analytics, so we talked about one example like predicting the sales. Now when we talk about machine learning algorithms, you can think across different industries we do use. For example, if you consider in digital marketing, let's say, okay, now in a lot of problem statements in digital marketing, these predictive problem statements came into the picture, which is really helping the sales or the marketing team as well, like predictive cost per click campaigns. Okay, so CPC or PPC kind of campaigns. So it helps to get to grips into the metrics that could help the businesses to maximize their conversions. Okay, so they could understand the underlying drivers and the patterns to make more strategic decisions and create certain new campaigns in such a way. Okay, be it in predicting the customer lifetime value, CLV. Okay, so the goal of predictive customer lifetime value is to model the purchasing behavior of customers. Okay, so in such a way that it could help to infer what their future actions would be. Okay, then the lead scoring as well become predictive many times, like machine learning algorithms could be used to predict the number of ad campaign leads and identify their best channels. Okay, so that is again a great problem statement that they're trying to solve, and many businesses, more specifically the marketing companies, that definitely they are using The very first problem statement they're trying to leverage machine learning is over there itself, where they're trying to predict the ad campaign leads as well.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And also the problem statement likes the click patience or the click-through rate prediction. That's again a very uh, cool problem statement that most of the marketing thing they're trying to solve using machine learning is like the accurate CTR prediction would definitely help those advertisers to optimize the advertising performance, right? So these are a few applications that you can think which gets implemented and are actually leveraged across different industries in the digital marketing field. Okay, all right. Now, this the examples that I've mentioned, all of these were examples of predictive analytics itself. Okay. Now, next you have another type of problem statement which now you can think could be part of all the three type of analytics that we have discussed, or could be solved individually using separate algorithm as well. Now, for example, there could be scenarios like from diagnostic analytics itself, you get certain prescription which you're prescribing to the business that, hey, if you do this, you could minimize the kind of losses that you're facing right now, right? Or perhaps that you could face in the future, more specifically. Okay. Now you could use the predictive analytics understanding that, hey, if we have this campaign that you're planning to launch in the upcoming months for this particular products, it's not going to work out. Perhaps you could save that budget and later perhaps, or right now itself, even if you like to launch any campaigns, do it some for other products and not for this product, because as per the predictive results we could not see a good ROI from that particular campaign. Okay, so that is again a kind of prescriptions that you're providing to the stakeholders. Okay, so the purpose of prescriptive analytics is to prescribe what action to take to eliminate any future problem, or perhaps to take the full advantage of any promising trend. Okay, so the prescriptive model basically utilizes the understanding of what has happened, why it has happened, and a variety of what might happen analysis. And that basically would help the user to determine the best course of action to take. So you can just think that Google Maps or any traffic application app, which basically helps you to choose the best route home, which takes into the account of like the distance of each route, the speed at which one could travel on each road, and more crucially, definitely the current traffic constraints, the type of vehicle as well that you're using, correct? So that could be considered as one prescriptive analytics. Then another major example that you can consider over here is the recommendation engines, be it in your Spotify or your Netflix or Amazon Prime, where they try to recommend any particular songs based on your historical data, or they try to recommend any web series or movies based on the patterns that you have shown in their platform earlier. Okay, so the recommendation engines could be another example, which is a set of again algorithms that we have over there in recommendation engine, which could be considered as a kind of prescriptive analytics. Okay, but it does not keep itself limited to only recommendation engines algorithms itself. It could be based on the predictive analytics or the diagnostic analytics output itself, from where we could generate certain prescriptive scenarios, right? From the outputs of the predictive analytics, let's say that we could generate and give certain prescriptions to the businesses as well. All right. So we talked about various scenarios where we leverage the. So you can think that in as a data scientist, we try to do any of this type of tasks based on the requirement wise, and the businesses would never say that, hey, I have a descriptive analytics problem statement, could you solve it for me? Or we do have descriptive and predictive analytics problem statement uh, for you. Okay, so they would just give a particular problem statement, and this is just for our reference point as a data scientist. We just wanted to know how we could categorize the type of task that we typically perform. Okay, it's more about within the internal team itself if we do use these jargons, and not something quite often used as well. But this just helps you to understand what different type of tasks that we typically perform. Okay, and how we could categorize those as well. Okay, there could be certain problem statement where the task was initially just to know what has happened, and thereby when we look into the patterns, we might be interested also to know why it has happened, and something deep diving it is something we call it as diagnostic. And there could be certain problem statement of predictive, like let's say in telecom sector, churn prevention is one of the important aspect for them. Now, how we are defining churn in telecom. So when any subscriber jump from, let's say, one network to another in search of any bargains, that is one of the biggest challenges that is confronting any telecom company, right? And it's far more costly to acquire new customers than to cater to any existing ones, right? So, and the common causes that you can think of churn, it could be like the high prices, or perhaps the poor service, poor connection quality, or new competitors. Let's say that you in India, you could have seen how Jio has impacted the other telecom industries with their new offers as well. And perhaps it could be based on the outdated technology as well. So the churn could happen because of any of such reasons, right? And to prevent churn, the data scientists there uh, using this predictive analytics to combine the variables like which could impact the churn. For example, the number of calls made, number of minutes used, number of texts sent, or perhaps the average bill amount, right? That could help them to predict the likelihood of a change in the customer's mindset, right? So they could know when a customer visits a competitor's website, changes his or her scene, or perhaps swaps devices, right? They could use the sentiment analysis from the social media feedbacks or the reviews that they are providing to detect any changes in the opinion of the customers, right? And thereby, once they do make certain kind of predictions, they could target specific customer segments with personalized promotions based on their historical behavior. They could react to react to retain their customers as soon as any changes observed, right? Okay, so this is one more example from next another domain technique, telecom domain. Okay, all right. So we looked into a lot of different applications where machine learning or data science could be leveraged, and we try to understand the four different types of data analytics also that we could categorize into. Okay, all right. So next, the interesting part would be for us to understand the life cycle of a data science project. Okay, so how do we approach a particular problem statement? Now, this just helped me to understand what tasks we do, but how do we approach any data science problem statement? That is again important aspect how we could call it as. Okay. Well, again, if we have any question like over here, which one I call data science as, well, all of those together again you could define it as data science. Okay, so as we say data science, this is a very broad term, right? So all these tasks together you can define it as data science. So as I was showing in the previous slides somewhere over here, right? So where we say this is data science, and machine learning perhaps is playing just one part in the data science field. Okay, now we'll try to understand what are typical steps that we typically perform in any data science projects and across all these industries. So we talked about a lot of examples. Now, across any type of problem statement that we try to solve, these steps we perform across any projects and across any industries. Okay. Now, at the start of any data science project, we would like to ask few questions to our business stakeholders. Okay, something now over here it's not mentioned although, but I would like to refer those points as well, because in real-time projects in the industries, this factors plays a very crucial role in the success of the project as well. Okay, because many times what happens, all right, that even in a lot of I would say MNCs as well in data science projects is they try to solve a particular problem statement, they solve it, and in the end, it does not get deployed as well. Okay, a lot of problem statements which they try to solve, right? The approach that they use to get it solved, in the end, the solution that they provide back to the stakeholder, they say that, hey, this is not something that I wanted to, or perhaps the output form that you have provided to us, it's not satisfactory, or perhaps not something that I could use for decision making. Could you give me the output in this way? And when they say something like this, you figure out that this is absolutely a different problem statement that we had to solve, and something you solved completely in different way. Okay, so this kind of misconnection typically happens in the end of the project, which absolutely scraps the complete project itself. And I could imagine how many resources that you have spent on, an amount of time that you have spent on a particular project, and something which is not getting deployed as well in the end of such a hard work, right? So a few steps are quite important for us also to know as a data scientist, or more specifically, if you're a data science manager, you must take care of those points, because the success of data science project is also very highly uh, impacted based on these few factors. Okay. Now, at a start, we would like to ask a few questions to our stakeholders when solving any data science problem. The first question that you think, or perhaps you might be willing to ask them, is what exactly is the business objective? Okay. Now, we need to first frame the problem and look into the big picture. Now, at this stage, understanding this is very important, because many times businesses are also not clearly aware of the type of problem that they're solving. They might be clear about the problem, but the way they're framing the problem might not be exactly very useful to you. Okay, to kind of convert that into analytics problem statement. Okay, many times we need to have a couple of discussions with the business teams as well, to clearly frame the problem statement and clearly define what are the metrics they're looking into, or how the output might be useful for them. Okay, because building a machine learning model is probably not the end goal, right? So how does the company expect to use and benefit from this model? That is important for us to understand. And it's important because it will determine how you frame the problem, what algorithms you select, what performance measure you will use to evaluate your model, and how much effort you should spend tweaking it. All of this is dependent on this particular question itself. Okay. Now, because we would discuss, although in the machine learning sessions, that by just understanding the problem statement itself, we could define what kind of algorithms also we could use to solve the problem. Okay, it's not something that all algorithms could be used to solve all type of problem statements. There are certain definitions of those algorithms, also the pros and cons, which could be leveraged to solve a type of problem statement. So clearly understanding the problem statement would help us to also determine that. And based on that itself, again, we use various metrics to look into the performance of the model that we have developed. By the way, so over here in couple of time, you could have seen that I've used the term model. Now, again, is just referring to machine learning algorithm. Okay, so the algorithm and model is something might use interchangeably. Okay, but in the end, to keep it simple, you could just think that whenever I'm referring model, I'm just mentioning it as machine learning algorithm. So over here as well in this slide, you could see it's called as model building, perhaps in this third one. So which is just referring to machine learning algorithm itself. Okay, all right. Then, for example, with the answer for that question, you might get an answer like your model's output would be fed to another machine learning system along with some other features. So that would determine whether it's worth investing in a given area or not. Okay, and getting this right is critical because it would again directly affect the revenue of the company, right? So clearly defining our business problem showcases basically how data science is used to solve any real world problems. Okay, and this high level thinking provides us with the foundation for solving the problem as well. Next, we might be also willing to know that have we solved any similar problems before or not? Okay, so is there, or has someone else documented the solution to similar problems or not? Or even is there a scenario that we could reframe the problem in any way? Okay, then another question we should be asking them is what the current solution looks like, if there is any. Okay, so it could be so that the problem statement is completely new, they wanted to solve but they don't have any solution for that now. Okay, so that means you need to start from scratch itself. So it will often give you a reference performance, right, as well as certain insights on how to solve the problem. So for example, it could be the scenario that right now they have a team of domain expertise who, for example, the sales prediction that we just talked about, right? So for example, we could say that the business stakeholders say that, hey, for our country we have certain domain experts who sets up a meeting in the beginning of the month, and they come up with certain predictions and something along in the another meeting with the all the business stakeholders and the decision makers. We set up another meeting where we finalize the predicted numbers. Okay, now there's a two-step process that we currently follow, but which is absolutely based on our guts feeling and on the domain expertise that we do hold. Okay, now they had you perhaps saying that we are getting good results, but we are spending a lot of resources and a lot amount of time to do all this forecasting task. Okay, but it would be really great if you get similar accuracies or perhaps better than that, which could be automated in the end, right? So that is their objective. Now you get a clear understanding that, all right, so currently they do have a solution, they do have a domain expertise team who leverages, definitely they look into certain patterns before they come up with certain numbers, right? So it's not like abruptly they give a number every time, right? So that is something you could also leverage. You could discuss with them, ask them that, hey, what features that you have considered. Okay, so definitely you should not go to a business team without doing your homework. So it's always a good practice that whenever you get a problem statement, we first do our brainstorming from our end itself. You could Google it out. If you have expertise, domain expertise in that field, definitely it could help you. If not, you could ask your colleagues as well to do certain more brainstorming and gather all the features that you think might impact, right? And there's a reason that why I have asked this question again a couple of minutes back regarding what factors would impact the sales, because that thinking process is really important in data science field. Okay.
Just a quick info, guys. Intellipaat provides online data science master program in partnership with IBM. The course link of which is given in the description below. Now, let's continue the session.
Spending time on brainstorming the features which would impact your target variable. Now, if you have, this is one scenario where you could leverage the domain expertise of the business team. Next, other scenario, let's say they say that, hey, we do already have a machine learning algorithm in our system, but we are not quite satisfied with the accuracy that the model results. So we have hired you to develop another model or perhaps a challenging model which could give a better result than the current one. Okay, now something again that is more challenging because actually you have to now give a better performance than the previous one, right? So that's more challenging actually. But over the again advantage, the advantage that you have over there is that you know what algorithms that you use, what features they have used, what approach they have used, and something that you can think that, all right, so if this thing is not working well, perhaps I should try something else or perhaps better than this, right? So you get a particular reference point to start off your problem statement with. Now that is again a good how you could start a problem, right? So knowing that what the current solution looks like would give you this reference performance scenario. Okay, and thereby it would help you to start off with the problem statement in different way also perhaps. Now the very first step, now once we have done all of these stages, let's say we understood the problem statement, we knew what the constellation looks like, and we have also done the brainstorming that what features might be we are interested to use for our analysis in the project. So the very first step is data acquisition, where you list the data that you need and how much you need. For example, we talked about we'll leverage, let's say, the historical 3 years data, right, to predict the sales. So this is again a kind of metric that you would be interested to look into, like how many years of data or how many months of data that you would like to leverage. Then what are features? So you find a document where you can get all those data. So you convert the data to a format that you could easily manipulate. So it could be said that you have in different sources different data, and you just gather all this together, merge them together, and create a master data set with which you start analyzing the data. Okay, now this is something we call it as data discovery phase, uh, and this is again an iterative process. Okay, now it need not to be now that you thought of 80 features and you have created all these 80 features. All right, so when I'm saying features are again I'm referring to variables, or you can think of it as a columns with respect to your Excel spreadsheet. Okay, features, variables, or columns, anything that I do refer, these are all you can consider it as a kind of used interchangeably. These are nothing but some synonyms you can think of it as. Okay, features, variables, or columns. Okay, all right. So consider, let's say you have 80 features that you have considered. Now it could be also scenario that while you're performing any analysis, you think of, hey, if I do have this feature also, it could have made me a clear picture of this analysis. All right, the complete view of the analysis. So you found that, all right, so this feature is not there in my 80 list. That means I need to extract it again, merge it with my data, and then do the analysis again. So it became an additive, right? So it's not like at the very first stage, if you have done that step, that does not mean that you cannot again do the data extraction in the later stage of the project. Okay, and this data discovery phase also helps us to identify if there is any gap between the ideal data that we needed versus the actual data available. Okay, because it could be scenario that we thought of perhaps 90 features, but out of 90, only 80 were available with us. Okay, so rest 10 are not there itself. It's not getting captured itself in our data set, in our databases. So, which is something that could not be used for analysis on. Okay, all right. So once we have the data, the next part is the most important one, the data pre-processing. Now, over data pre-processing is actually a very huge portion. So I will try to mention all these tasks that in general we use, right? So at a broader level. Now, pre-processing, the very first thing that we talk about is explore the data. Okay, so once we have all the data, it's important for us to explore it at first. Like when we're saying explore, that means perhaps we need to understand all the columns that we have, right? So perhaps we might be also interested to know or rename the column names as well. Okay, so understand, or if needed, rename. All right, look into the data types of them. Okay, so data types we are referring, for example, is it numeric, categorical, or just a character text you have, right? Understanding all of this would help you to do certain activities also with those data set. How many percentage of missing values if you do have? Okay, there could be certain scenarios where in your data set you have missing values. Okay, that is again something you would be interested to look into. Then whether you have any outliers as well in the data set or not, which you would be willing to look into. So how we define the outliers? Well, this is very subjective, although there's no clear distinct formula or definition of outlier. So you can just think outliers as some distant points from majority of your data points. Okay, so for example, let's say you have age as a column. Okay, so age as a variable, and all the customers, their ages lies between 25 to 66. Okay, now you have two customers, right? So all my customers, they have ranging from 25 to 66. Is just two customers, they are having the age of 98 and 104. So you can just understand that these two are outliers. So another example, let's say you consider the distance that has been traveled. Okay, so in a particular day you have 1,000 ubers in a particular city, and you calculated the distances that they have covered in a particular day. Now, considering all the rides, let's say they have completed 100,000 rides. Okay, now for all this 100,000 rides, you just wanted to see that how much, or let's say how many kilometers they have covered. Okay, now over there you see that it ranges from 3 kilometers to 21 kilometers. Okay, all the rides, all the 100,000 rides that you have considered. Now there are few uh, rides which, let's say one ride which was, let's say 55 kilometers, and the ride which was 79 kilometers. Now you can see that this 55 and 79 kilometers, these two are outlier in your data set, correct? So that is something you could define it as outlier. Okay, all right, so this is something that we might be interested to look into once we have all the data set with us. Okay, all right, next, once we look into this, now for all the rides, let's say for, I'm considering, let's say you had a total 100 rides. Out of 100 rides, 98 rides, they took 5 to 45 minutes. Okay, now just two rides you have, they took, one of them took 20 minutes and the took 205 minutes. So these two are outliers in your data set, right? So majority of the data points, they are lying within 5 to 45 minutes. Only two rides who took 280 minutes and 205 minutes to complete the total rides. Okay. Now, these are the initial exploration where we might be interested to understand the data. Now, when we say that we wanted to understand, perhaps we would like to also understand the patterns in the data set, right? So we are saying that understand the correlations, that means how the variables are related to each other. Okay. All right. Next, to understand the patterns, we might also be willing to visualize the data, right? So that could be another factor. All right. Now, this is one other factor where you could say visualizing the data is something which could help you to understand the patterns in the data set. Then you identify any extra data which might be useful, whether you like to extract some more data or not. And if any data transformation is needed, like any mathematical transformation like square transformation or log transformation or square root transformation, if needed in the data, right? Uh, you look into the distributions of the data, you create certain histograms, bar graph to understand how the data is distributed, right? So this is like the very first stage. You're exploring the data, you're trying to understand how the data looks like, what patterns that we have, and what distribution that they hold, and whether we have any missing values or outliers in the data set or not, right? We understand the patterns and the relationships in the data set. Now that is very important state in any data science project. Next comes data preparation. Okay, so let me call this prepare the data. Now, how are you? What are we referring while calling it as prepared the data? Now, in real-time data, data won't be cleaned. Okay, so real data would be always messy. So you need to do certain data cleaning. So as I was saying, messy means there could be certain missing value, there could be certain outliers as well. So you need to deal with them, right? So for example, so you could fix or remove the outliers. Now, remove means you have two rides which took 280 minutes and 205 minutes, right? Something which would really skew the analysis in our project, right? So if I say what is the average time taken to complete all the rides, so if you just consider 5 to 45 minutes, it was something, let's say you got around 33. Okay. But if you now consider 280 minutes and 205 minutes, definitely it would be even more than 45 minutes, right? Which is actually wrong, because all your rides actually took till 45 minutes only. But just because two rides, your mean is skewed, right? So all your analysis would be getting skewed if you don't take care of this outlier, correct? So one way is like you remove two ride information. So I will deal with 98 rides only. That is fine. That is one way. And the ways you impute them. That means, for example, you have 280 minutes, 205 minutes, but you know that all your rides till to max they had 45 minutes, the highest amount of time which has been taken. So what you could do, perhaps I would replace 280 and 205 with 45 minutes. Okay, so this is not correct, but this is an intelligent imputation method still, because you know that 2 max it could take 45 minutes only, as we could see for all my rides. So these two outlet which perhaps might be two case also which actually did some outstation rides or something, or because of really bad traffic, or because of the weather wise it happened. But as I would be using it for prediction for the generic scenario, I could say that all right, so 2 max it could take 45 minutes only, so I'm imputing the two rides also in the 45 minutes. Okay, so this is like I'm fixing this by not removing, rather by imputing those values. Similarly, you could think of about the missing values as well. So you could fill in the missing values or just drop them. Okay, so drop them means if you have any missing values, you can remove the complete row itself, or you can remove the complete column itself. Okay, that is one way of dealing with them. Other way is you impute them with some methods. So fill in those using, let's say, zero or mean or median, something like this, or mode. Okay, so we would look this in while in our when we discuss. Okay, so you could impute the missing values also if you do have. Then the feature engineering. Okay. Now, feature engineering is again very important stage in data science project. So feature engineering, many steps actually comes into the picture. Like I could say the feature selection as one of the factor. Like, all right, so feature selection means that in data science projects, it's also important that we keep only the meaningful features as the input to the algorithm. Okay, so it's just like the garbage in and garbage out. Okay, so the more irrelevant features you provide as input to the model, you then won't get good results in the machine learning model outcome. Okay, so it's always important that we provide only the essential features in the model. Okay, now feature selection means
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
one way is like you drop the feature which do not provide any useful information for the task. Another way is, this is one way definitely, and another way is like selecting the most useful features only. Okay, so to develop the model, like you had 20 features, but you pick up only the top 10 features which would give you the most highest importance for predicting the target paper. But these are like few ways how you could select the important features for your model. Then you can think about feature extraction. Okay, so what are we defining by feature extraction? Or let's say you could say feature extraction or feature creation as well. So you could combine existing columns to create a new useful feature. For example, you have two feature A and B. Okay, and you create a ratio A divided by B as a new feature. So you create a feature C which is A divided by B. Okay, so you remove A and B and you keep the important feature C only, which is the ratio of A to B. Okay, so there could be feature like you have date. Okay, so let's say 2018 10/09. Okay, so the is the format like year, month and day. Now from that you could extract month. Okay, you could extract year, you could extract day, you could extract, let's say the day of the week, let's say it's Monday, Tuesday, Wednesday, like this. You could extract from that weekday or weekend, right? You could extract also the season from it, right? So you could see that you could extract, let's say quarter, right? So for example, you could extract 6 features just from one column itself, right? So this is like you're creating new features from your existing columns. So there are different ways how you could create some new features. Like you have age as a column, let's say. Okay, so all lying from 21 to 66, right? So you create a new column called as age class. Okay, so how you're defining age class? Let's say 22 30, 21 to 30 as one category, 31 to 40 another category. Okay, then 41 to 50 another category, then 51 to 60 another category, and then you create 60 plus as another category. So you created a new column from your existing numeric column to a categorical column, right? So this is like you're creating new features from your existing ones. Okay, so this is something what we are referring as feature engineering, all of this. Okay, all right, so I'm sharing all of this in the chat box. And one more thing that why I'm majorly focused into this is in any data science project, I would say we spend 70 to 80% of our project time in these two steps itself. Okay, doing all of these tasks, and just the remaining 10 to 20% we spend in this particular steps. Okay, now over here what we are doing, so once we have all the data ready with us, all the important features with us, then we move on to the machine learning algorithm. So this model building and these two steps that we are saying. Okay, so this we are referring it as the model development stage. Okay, now machine learning over here we are using to make certain predictions, right? So we had certain historical data and we make the predictions using certain machine learning algorithms. Now over here as well, as I was saying, there are different type of machine learning algorithms, again for different type of problem statements. Okay, and also there are also scenarios that for the same problem statement we could use different type of algorithms as well. Okay, now how do we decide that which algorithm would perform best? So it's never the scenario that, for example, if I say that uh, there is a problem statement where you're trying to predict a fraud, okay, so fraudulent transaction or not, and you could use A, B, and C algorithm for to solve the problem. Okay, now you have solved the problem and you found that B performed the best. So how did you know that B performed the best? So for both or for all three algorithms, A, B, and C, you would need certain evaluation metric, right? Which would help you to evaluate the performance of your model that you have built. So for example, accuracy is one of the metric. Let's say you build model one, you get accuracy of 75%. You build model B and you got accuracy of 91%. You build model C, which gave you accuracy of 66%. So among these three, you found that model B gave you 91%. That means model B performed the best for this problem statement, right? That means model B is something you'd be deploying into the production environment. Okay, so that is something which we are seeing in these two particular scenarios, model building and pattern evaluation. So where you build a model, you see which one is performing best. Okay, so it's not just one model you build and you say, all right, it's done, we got the prediction, I'm done with the project. Okay, it's never the scenario. So it's always a good practice that you try out multiple models and see which one is performing the best. Okay, even with the experience, even I would say someone with years of experience, if someone says that for this just use this is the best model and you're done, never buy that point. Okay, so it's always a good practice that you always try it with multiple models and see that which one is performing best and which one is not. Okay, all right, so next over here one more point is, for example, as I was saying that, for example, you developed a fraud model for credit card transaction. Now let's say you have, again you found another problem statement which has the exact same problem statement. Okay, so data could be different, but let's say you have the same problem statement. So you might think that, hey, I have solved this problem earlier and the model B which I've used over there performed the best. So I believe model B would perform again best for this problem statement because it's the same problem statement that I'm trying to solve, right? But it does not happen like that. Okay, when the data gets changed, anything could change, right? So the model definitely could get also changed, be it the same problem statement, even for the same company as well. Even if you just change the different market, your data sets gets changed and your model could also get changed. Okay, so that is really important for you to understand that. Don't get fall into a trap that, all right, so if I've solved the problem and, for example, you solved 3 4 projects and for all the projects you found that model C always outperformed. So does it mean that when you have the sixth problem statement you would only use model C? No, you should not. Okay, so you should again try out all the models and see that which one is performing best for that particular problem statement and the data that you're using. Okay, and one more thing, that all of these steps are iterative. Okay, so it's a one way directional that you try to solve the problem. Okay, so it's not that you are done with data acquisition, you go to data pre-processing, you're done, your model building done, accuracy, and then presentation. No, it's not like that. Okay, so it's always a bi-directional kind of stuff. So you, from at any stage, you could go back to the previous one and then you try out that. Perhaps, for example, let's take an example that you're developing one algorithm and you found that this three feature is not impacting my model. So you go back to this data preprocessing stage, remove the three feature and develop the model again.
All right. So, guys, this was a brief about the difference between a data scientist and a statistician. Now, let's go ahead and get into the nitty gritties of how data science functions by understanding what is machine learning exactly. All right, guys. So, machine learning is basically training a machine how basically a certain task has to be done, right? In the most simplest explanation, this is what it is. I'll repeat it for you. So it is the science of teaching a machine how a particular task is done, right? Now, in the further slides, I will tell you how this process is actually implemented. But if someone asks you what is machine learning, this is what you tell them. It's the process of making a machine learn how to get a certain task done. Okay, now let's go ahead and understand how machine learning basically works. How is this process basically implemented? So the first thing that you do as data science, the keyword says it's all about data, right? If you want to make a machine learn something, it can only do so by making use of data. So first what you'll have to do is you will have to prepare your data in order for your machine to learn things. Okay, now let's say how you can go ahead and prepare data for a machine to learn. Okay, so let's take a very small example and then you can imagine it on a bigger scale. So let's say you have a data set which has been given to you by any company. Let's not get into the details of what this data set talks about, right? But let's just say there is a data set and there are 100 rows in that data set. Okay, what you do, the very first thing what you do when you have to basically prepare your data is you split this data into 70/30. Okay, so you will basically have 70 records in one file. So you had one file, now you have split it into two files. In the first file you will have 70 records and in the second file you will have 30 records. This is basically me trying to explain you that you have to divide the data set into a 70/30 ratio. Okay, now the data set with more number of records would be the training data set. So this would be the data that you will use to train your machine. And the latter part of the data set, right, the data set which is there in the second file which has less number of records, will be your testing data set. All right, this is clear to everyone? If it is clear, please write a yes in the chat. Okay, moving forward, now let's take an example to understand the same particular concept that I've told you. So let's imagine you have images of fruits. You want to make your machine learn how it can identify fruits. Okay, so what you have is you have 100,000 plus images of fruits. And what you do when you start preparing your data is you divide the images into 70/30 ratio. So you will have 70,000 images which will be your training data set, and then you will have 30,000 images which will be your testing data set. So whatever I told you earlier, I've just put it into perspective that when you use fruits as an example, when you want to make your machine learn how to identify fruits, you first need a lot of images of fruits. So you have 100,000 plus images of fruits. Now before you begin training your system, you will have to prepare your data. In order to do that, you will first have to divide the data for the ratio. This should be clear to everyone now. Next, what you do is you start implementing machine learning. Okay, now that you have your data prepared, you go ahead and now you implement machine learning. So let's go ahead and understand how that is done. All right, so guys, in the process of machine learning is basically divided into three phases. The first phase is the training phase, the second phase is the testing phase, and the third phase is the predicting phase. In the training phase, you feed the machine with the training data set, right? And don't worry, just listen to what I'm saying right now. I will give you an example and things will be more clear in just a second. Okay, so the first stage is training. So you feed the machine with the training data set. Once the machine has been trained, then what you do is you test the machine with the testing data set to see whether the machine learning model is working as expected. The third stage is the predicting phase. So what happens in the predicting phase is that now you give the machine any random image and you ask it whether it is able to identify that image or that data or not. Okay, so first what you do is you train your machine, then you test whether that machine learning model is working as expected, and then you give your machine arbitrary data and it tells you whatever you have taught it. Okay, now let's put it into perspective and let's understand this process using an example. So we will be taking the same example forward. So we had the testing data set of 70,000 fruits. Okay, So we feed these data to the machine learning model, and now the learning model understands, okay, what a fruit is. Now to verify whether your machine learning model is working as expected, what you do is the remaining part of the data set, you feed it to the machine and you ask it what it is. So if it tells you that all of these are fruits, if they basically the machine learning model predicts the correct value, because in this case you already know that the images that you're giving to the machine learning model are fruits, right? So if your machine now is successfully able to predict that yes, these are fruits, you have successfully identified that your machine learning model is working correctly. Okay. Now in the third phase, what you do is the predict phase. What you do is you give your image, or you give your machine learning model any random image, and it tells you whether it's a fruit or not. Okay. Now this is exactly how machine learning model works, but the only difference when you implement it in real life is that you basically take care of a lot of things, and we will be understanding that slowly and gradually as we move along in this course. Okay. Now let's go ahead and understand what are the different types of machine learning algorithms which are out there.
So in general, we have three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Let's see them one by one. So starting with supervised learning. So supervised learning is the one in which we have a training data set, or you can say in which we have a labeled training data set and the machine is trained on that particular label. For example, so there's a teacher or there's a supervisor who supervises the entire process and trains the machine according to the label. For example, you can see up here, here's a teacher on the screen who is teaching the machine by showing different images of the apple. So once the machine is trained, so in future, when we show a different image of an apple, the machine can easily identify that it's an apple with some accuracy. Okay, for example, the image shown up here is an apple with 97% accuracy. So this is supervised learning. So let's see some of the use cases of supervised learning. So first we have a spam classifier. So how do you think your mail is getting classified as whether it's a spam mail or not a spam mail? Well, the spam detection basically works on the basis of filter. These are settings that are constantly updated based on new technologies, new spam identification, and the feedback given by Gmail user about potential spammers. Spam filter uses either text filter or it eliminates the thread based on sender and their history, whether the sender was previously reported or not. Okay. So there are mainly two types of filters: text filters and client filter. Text filter work by using algorithm to detect which word and phrases are most often used in the spam email. Phrases like lottery or you won or free Bitcoin are often an immediate flag for removal by filters. Spammers have gotten wise to this and often use blunt misspellings or even substitute of characters like free dollar character in order to make it pass the filter. Fortunately, the modern spam filter can also make allowances for these type of misspellings, and if a word comes up, even with character substitution, the message will still be blocked. Next is the client filter. In addition to the simple text filter algorithm, the top spam filter uses client identity and history to block malicious or annoying spam email. Now, how does a spam filter work? Well, this is done by looking at all the messages of a certain user which he has sent out. If they send out huge amounts of email constantly, or if several of their messages have already been marked as spam through the text filter, in that case their email will be blocked entirely. So this brings us to the use of blacklist. Spam filters also include a blacklist. Blacklisting is simply the process of adding the known email addresses of a spammer to a list. This list prevents any inbound messages from the email address going forward. If you have marked something as spam, it will directly go in this blacklist. And it also helps Google to make a note of certain keywords found from that particular spam mail. So that's the outline of spam detection. The real-time process are a lot more complex and consume a lot of data. Okay. Next is fingerprint analysis. So for fingerprint analysis, what you do, you save your fingerprint in the machine as a record. So the machine checks the data and verifies whether this particular data belongs to you or not. Okay. So once the data is saved into the machine, so from next time, whenever you put your fingerprint on the machine, what the machine does is scan through all of its data. And if the data is matched, then in that case, your fingerprint is verified. This is another application of supervised learning. Next we have is unsupervised learning. Well, in case of unsupervised learning, there is no teacher and there is no label. What the machine does, the machine identify clusters in it. It finds similar images and group them into a cluster. For example, over here, seeing some pattern in different images, the machine divides the entire image into 3 different clusters. Okay? Cluster 1, cluster 2, cluster 3. But the machine doesn't know that cluster 1 is an apple, or cluster 2 is an orange, or cluster 3 is a banana. All it knows that cluster 1 consists of similar item, cluster 2 consists of other similar item which are not at all related to cluster 1, and similarly cluster 3 consists of different item which are completely different from cluster 1 and cluster 2, and cluster 3 consists of other similar item which are completely different from the item of cluster 1 and cluster 2. Okay, so this is what unsupervised machine learning is. So one of the use case of unsupervised learning is voice-based personal assistant. So the device which you are seeing on your screen is Amazon Echo, and the brain or the voice of Echo is known as Amazon Alexa. The device has many smart built-in to do a number of tasks like playback music, make the light blink. It also recognizes the name Alexa. It's like when you say the word, it recognizes the word and start recording your voice. Amazon calls this word as a wake word. So it's like when you have finished speaking, it sends the recording over to the internet to Amazon. The service that processes this recording is called Alexa Voice Services, or AVS. It's run by Amazon, thus converts the recording into command that it interprets. It's more than a simple voice-to-text service. It is a fully programmable service that can work with other online services to do a large range of things for you. Once authorized by Amazon, anyone can use this service for free to build a homemade Echo. Amazon has also offered sample code for building an Echo using a Raspberry Pi, which is a simple $30 computer. It might sound extremely selfless of Amazon to provide the service for free, but as always, they have their reasons. Amazon want others to build their service into their product so that they can sell you this stuff. So every product that has Alexa built in is a device that can be used to buy stuff from Amazon. These commands that Alexa interprets can be very simple. It's like if you ask for a time, the AVS sends back an audio file to Alexa telling you the time, which the Echo plays back. They can also be more complex. If you ask Alexa to play a Pink Floyd, AVS will search the music service to have you set up for Pink Floyd, and then send a command back to the Echo that sets it playing the requested music. Alexa can also work with other technologies in your home. It's like you can even set up your Philips Hue smart lights to be controlled with Alexa. You can ask Alexa to turn on the living room lights, and the Alexa will send a command to the Echo that sends a command to these light bulbs to turn on. It can also work with various online services. You can link Alexa to Uber, and you can request Uber by simply asking Alexa. You can link it to Domino's, and you can just order a pizza with your voice. So this approach means that Alexa can do a lot of things for you. And the list is just getting longer. Amazon is adding more features and skills to Alexa. And if you are smart enough, you can build up on their own. So it means that you can use Alexa to control things that are not even on the list. Okay, well, however, Alexa needs internet connectivity and AVS to work. If your internet connection is slow or it's not working, then Alexa won't be available and your Echo will be useless. So if Amazon decides to charge for a service or just close it down, then in that case, you'll be just left with a useless device. Well, Amazon is not the only one in town. We have Google, Apple, and Microsoft, which offers similar services that can perform tasks by voice command in the form of OK Google, Siri, and Cortana. They use similar approach, voice commands that are processed in a cloud service. But most of them are not as flexible or as integrated with other services as Alexa is. So whichever of these services end up being the one we all use, hopefully they will be as polite as Alexa. I'll just give you an example. When I asked her how she works, she replied, "Lots of people had worked hard to teach me, and I'm still learning more. Wouldn't it be nice if all of our appliances were that modest and polite?" Right? So let's move ahead. So another use case of unsupervised learning is Netflix recommendation. So more than 80% of the TV shows that you guys watch on Netflix are discovered through the platform's recommendation system. That means the majority of what you decide to watch on Netflix is the result of decisions made by a mysterious black box of an algorithm. Let me just give you a brief of how it works. Well, Netflix uses machine learning algorithm to recommend you the list of movies and find shows that you might not have initially chosen. To do this, what it does, it looks through a thread within the content rather than relying on board genres to make a prediction. So this explains how 1 in 8 people who watch Netflix Marvel shows are completely new to comic book based stuff on Netflix. Let me tell you about a guy named Todd Yellen. He's the Netflix Vice President of Product Innovation. He has explained the working of Netflix as a three-legged stool. The three legs of this stool are Netflix members, the tagger who understands everything about the content, and our machine learning algorithm that takes all of the data and puts them together. So Netflix has more than 100 million worldwide users. If we count the multiple user profile for each subscriber, it comes to around 250 million active profiles. Now Netflix uses different kind of data from these profiles, like it keeps a track of what you guys are watching from your profile, what do you watch after completing your current video, and even what you have watched earlier. It also keeps a track of what you have watched a year ago or what you're currently watching and at what time of the day. Well, this data is the first leg of the metamorphical stool. Now what they do, they combine this information with more data to understand the content of the show that you are watching. The data is generated from dozens of in-house and freelance staff who watch every minute or every show on Netflix and tag it. Now all these tags and the user behavior data are taken and is fed to a very sophisticated machine learning algorithm that figures out what's most important and what should it weigh like. Or how much should it matter if a consumer has watched something yesterday? Should that count twice as much or 10 times as much compared to what they have watched a whole year ago? How about a month ago? Or how about if they watched 10 minutes of the content and abandoned it, or they binged through it in 2 nights? So how do we weigh all that? Well, that's where machine learning comes in. What those three things create for us is taste communities around the world. It's about people who watch same kinds of thing that you watch. Viewers are fit into thousands of multiple taste groups, and it's these that affect what recommendation pop up on the top of your screen. The tags that are used for machine learning algorithm are the same across the globe. However, a small subset of tags are used in more outward facing way, feeding directly into the user interface and differing depending on a country language and cultural context, as the tags have to be localized in a way that make more sense. For example, if you know English and you're watching Hollywood movies or movies in English, then in that case, Netflix won't recommend you German movies or Chinese movies or Japanese movie. Alright, the data that Netflix feed into its algorithm can be broken down into two types, implicit and explicit. Explicit is, for example, you gives a thumbs up to the series The Friends, so the Netflix get it, okay. And implicit data is mostly the behavioral data. It's like you didn't explicitly tell Netflix that you like Black Mirror, but you just binged on it and watched it in 2 nights. So the Netflix understands that behaviorally. So the majority of the data is implicit. So this was about how Netflix is using machine learning to recommend you the movies. Fine. So next we have is the reinforcement learning. Well, in reinforcement learning, what we have is the agent and the environment. The agent selects some action using some policies. So there is no teacher in this case for training the machine. If the machine makes a right decision, the machine gets a positive point. If it makes a wrong decision, it gets a negative point for it. So repeating the process again and again and again, the machine learns it. So this process is of reinforcement learning. So let's take the example of a self-driving car over here. So initially, when the car was trained, so the car didn't know what way to choose. Okay. So what it did, it made an action, but the action it performed was wrong. So it got a penalty of minus 50 points for that. So from the next time, car realized that what it did earlier was wrong, and it updates its policy and then iterates the process. Okay. So this is reinforcement learning. So let me just explain you reinforcement learning with the concept of how Pavlov trained his dog using reinforcement learning. So there's a famous example of how Pavlov trained his dog using reinforcement learning. So it's like initially Pavlov gave food to the dog. So in response to the food, the dog started salivating. Okay, this was before conditioning. Then in the next phase, what he did, he just rang a bell, for which the dog did not respond anything. Okay, then the third phase, what he did, he rang the bell and then gave him the food. So seeing the food, the dog started salivating again. Then after that, he repeated this third step again and again and again until the dog learned it. Then after conditioning, whenever Pavlov used to rang the bell, the dog started salivating. He understood that whenever the bell is going to ring, his master is going to give him the food. So this is how Pavlov trained his dog using reinforcement learning. Okay. One of the application or the use case of reinforcement learning is self-driving car. A recent study has shown that over 90% of road accidents are caused by human error. To err is human, but behind the wheel, mistakes are often more catastrophic. Accidents have led to a massive number of unnecessary deaths, lives that could have been saved otherwise through self-driving. So this is where self-driving cars comes into picture. The autonomous car or the self-driving cars are much safer than human-driven car. They are unaffected by factors like driver fatigue, emotions or illness. This makes them very safe. Self-driving cars are always active and attentive, observing the environments and scanning multiple directions. It would be difficult to make a move that car has not anticipated. So, how does a self-driving car work? Well, self-driving cars mainly rely on three technologies: IoT sensors, IoT connectivity, and software algorithm. There are many types of sensor available for a self-driving car. For example, sensor for blind spot monitoring, forward collision warning, radar, camera, lidar, and ultrasonic. So all of these IoT sensors work together to make navigation of a self-driving car. Next is the IoT connectivity. Self-driving cars uses cloud computing to act upon traffic data, weather, maps, adjacent cars, and surface conditioning among others. This helps them to monitor their surroundings better and make informed decisions. And next is the software algorithm. All the data the car collects need to be analyzed to determine the best course of action. This is the main function of the control algorithm and software, and this is where reinforcement learning comes into picture. This is the most complex part of the self-driving car since it has to make decision flawless. A flaw like in case of Uber's self-driving car can be fatal. Okay? In today's world, the most famous self-driving car are those from Tesla and Google. Tesla cars work by analyzing the environment using a software system known as Autopilot. Autopilot uses high-tech cameras to view and collect data from the world, same as what we do with our eyes. It's called as computer vision or sophisticated image recognition.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
It then interprets this information and makes the best decisions based on it. So this was one of the use case of reinforcement learning.
Linear regression. You all must be remembering the linear equation that we have, right? So what was that linear equation that we used to have in our school days? It was something like this, right? Y equals.
Just a quick info, guys. Intellipaat provides online data science master program in partnership with IBM. The course link of which is given in the description below. Now, let's continue the session.
Mx, sorry. So the form was y equals mx plus c, right? So the form was y equals mx plus c, right? This was the form of the equation that we used to be getting for a linear line, right? So we had this kind of line from that equation, right? It might be, it depends on the value of m and c. I am taking c somewhere is there, so this kind of lines we will be getting. And here, let's say this point is x1 y1, so for this one is x1, so this point up here in the line will be x1 y1, right? This point up here will be x1 y1. So for the value of x1 we have this value of y1. So in here, if you see this variable, this was used to be called dependent variable, right? Dependent variable. Why dependent? Because it always changes with the value of x, but x doesn't have any limit. So this is called independent variable, right? This is called independent variable. So x is independent, y is dependent, right? So that kind of equations we used to have. Okay, and this aim here, right? This aim here, this aim used to be called slope of the line, right? This was used to be called slope of the line. This c was some constant which can be zero also, right? C is some constant which can be zero. So that's what we had in our linear line equations. Now the thing is, how do we use this for our class, like for this linear regression models to be built? Okay, so the entire thing is based on this concept only, y equals mx plus c. It is as simple as that. So we will have some kind of a equation which will be in the form of y equals mx plus c. We will predict the values of the data points that is being sent to our data set when it is deployed, and then we will get the values of y. Okay, so that's what is the whole concept of machine learning, linear regression. So linear regression is a technique to find relationship between two or more variables. Yes, right. So if we have more than two variables, then how the equation will look like? It will be, let's say y depends on more than one, right? So it will be mx plus ny, sorry, nz, something like that. So mx plus na plus let's say pc plus d, kind of this kind of equations, right? So here it will have three variables, three independent variables, x, a, and c, right? Three variables we will be having in that case, right? Three variables we'll be having in that case. So that's where this machine learning comes into picture, and that's how this machine learning thing works. Okay, that's how the machine learning works. Now let's see how we are going to use it for our model. So that's why, so this is called linear because it is based on the equation of a linear line. Okay, it is based on the equation of a straight line actually. Okay, so as I told, change in dependent variable is associated with the change in one or more independent variables, right? So that's the basic concept of the equations. Okay, next is this picture. This is called Rex Thor, the dog bearer. Okay, so if you see the right hand side, guys who are aware with Avengers, they must be recognizing the right hand side guy is some kind of a Thor. It look like Thor. He carries a dog, right? Instead of carrying a hammer, he carries or a stormbreaker. He is carrying a dog, right? So he is named as Rex Thor, the dog bearer. So there is in the, we know, right, there are seven stars in the planet which has some kind of a shape. So it is one of them. Okay, this is a star pattern actually. So why we are taking this here is, this is the data point, right? In the left hand side, this is the data point, and this is how the thing looks like. So if you draw this line, then this is, I mean, you see like there is a lot of difference between lines, right? So that's how it looks, and there is a concept of r square. R square means mean squared error. Okay, that is also known as goodness of fit. Okay, that we will be covering in the next sessions. So you will see when r square gets minimum, that means the model has huge error. So here see the r square value is pretty small, right? It is 0.06. That means this line up here doesn't at all represent this model. Okay, so that's how this linear regression works, and with the help of this goodness of fit r square value, we can somewhat check the model's performance also. So that is a statistical test. At the end of the class, I will be telling you that, like the theory behind it, how those are calculated, and those part. Okay, so that is what is about linear regression. It's that much easy only. Okay, it's nothing more complex. More, not much of a complexity is there in the in this linear regression. So it's far too easy. So next, there are a few examples of linear regressions. Okay, so where, yeah, I told, right, Ravi. So r square I will be coming later. It is a mean squared error. So it is a goodness of fit test. That is a r squared test, you can tell. So I will be coming to that in the last part. Okay, I will tell you the theory and everything also. No need to worry. Okay. So this is the regression is a technique that displays the relationship between y and x, as you already know. So if temperature drops down, the guys will start putting more jackets, more jackets to avoid the cold, right? To keep them warm. So that's a straightforward relation between two variables. This is an example of linear regression. Okay, temperature versus number of cones sold at the ice cream store. If it's gets hot at outside, then the number of ice cream sold will be more, right? Inches of rain versus new cars sold. So that means in the rainy season, guys would like to avoid going out without their car, right? So that's how. Daily snowfall versus number of skiers. So if snowfall is higher, number of visitors at the skiing park will be increased, right? So that's how this works. Now this is the base of it. So if you think there is a relationship between two things, regression would help confirm it. That means if at all there is a relationship between those lines, let's say I will draw you a plot first. Okay, so let's say here is a plot I am drawing. Come on, why it is too large? I want something smaller. So if you see, there is so some data points. Let's say this one, say this one, say this one, this one. So see, here is a perfect relation, right? But again, this is not a linear relation, right? So if you draw it otherwise, if we say there is kind of a this line goes in, so this is the best linear regression line that can be fit in, then also this doesn't seem to be a good relation between them, right? So linear regression will help you to understand if there is any relationship between two variables or not. Okay, so that's how linear regression works. So you will build a model. If the model performs poorly and no ways you can fine tune the model, that means there is not much of a linear relation between them, right? If there is a linear relation, then it will look good, right? So the goodness of it would look good. So here is an classic example. So if you see, the values here are categorical, right? Why categorical? Because y only has two values, y0, y1, right? Only two values. So in this two values, if you see, they are categorical values, and it comes under a lambda shift function, right? I mean, sorry, sigmoid function, this kind of, right? S kind of a function. So this is called sigmoid function, right? So that's how this thing goes in. Okay, so here if you draw the linear regression line, it will fail miserably. Okay, because if you calculate the r square fit for this, it will be too low number, because it is not at all a good fit, right? So this one is example of linear regression, this one is for logistic regression. So to see how this linear regression helps here, if you draw this line, if you build this model using this line, then only it will be cleared that there is no linear relationship between these two data points. Okay, these two data points. Okay, so that's how it goes. Okay, so next we will be going to a few scenarios when we can use linear regression, and when do we go for logistic regression. Okay, these are a few types or a few factors which will help us deciding that. Okay, so see here, first of all, it will be continuous. For linear regression, the variables has to be continuous. That means it shouldn't be categorical or skewed at any 2 points, right? So it will solve regression issues. That means it should be a good fit. Okay, good fit to a point, to some data points. Okay, and it should be somewhat, it should be represented by a straight line curve. Okay, so in this case is match, so then it will be a perfect fit for linear regression. So it has to be continuous variables. That means the spread of the data, it shouldn't be skewed. So it should be somewhere, it should be spread out evenly among this in the xy plane. Actually, it should have a straight line kind of a relation between them, and it should solve regression issues. Regression issues means where we have a lot of data, we churn those data to find out some basic data, basic inference. Actually, when I say this, both of these are supervised learning algorithms, so don't confuse that. So here what we'll have, we will be, for both the cases, for both the cases we will be having this values, right? Like we will be having training values, right? But here we will have some output, that will be spread throughout the I mean that will be somewhat significant, not some classification things like 0 and 1. The gender split, male or female, it is a classification issue. A spam or not, classification issue. Predicting housing price, linear regression. Okay, this kind of things comes under linear regression. So if you see there, if you build a model of I mean housing price predictor, there has to be some kind of a relation between all the variables, right? But for classification, it has to meet some criteria. There won't be any relation between those criteria individually, but there should be I mean there should be a skewed value, and the variables will be categorical. Okay, when I say variables, so can anyone tell what is a variable? When we are telling variable, which one we are telling, like what we are actually trying to tell here when we are telling continuous variables and categorical variables? What are those? So if you get a data set, let's say there are 10 rows with 15 columns, so which one are we are telling about target variables? Okay, those parameters which impact the outcome, like dependent variables. So let's say if we have 10 rows and 15 columns, then 14 columns in that will be independent variables. Those are x values, they can go anywhere. Okay, the variables, the target variables will be the dependent variables, right? When we say continuous and categorical, that is the dependent variables, that is the y values, that is the outcome values, right? because independent variables can be anywhere, right? It can be anywhere in the plane, correct? So that's why when we consider fitting a model, we shouldn't be looking at the feature first. We should look at what kind of output we are expecting. So is the output is somewhat categorical or regression? What is it? The outputs will be in continuous variables. Let's say housing price. If you have 10 lakhs rows of data, so you are most probably will be having all the numbers between 20 lakhs to 1 crore, right? Depending on the scenario. So that's a continuous space, correct? But categorical things, when we are deciding on mail classifier, spam classifier, right? Spam or not, it's two values, 1 0 or 1, right? So categorical things, right? So that's how we decide on this linear regression and logistic regression. Okay, so it's y here, it's Nancy, it's y here. So when I tell the outcome, that is the y, right? That independent variable. For x, those will be independent ones. They can go anywhere. Those will be the features of your data set on which you will build the models. When you say y equals mx plus c, this x will be independent one. It can go anywhere, right? So you really can't judge from that, right? Because for a categorical, I mean, if you think for a spam classifier, what all things can be there? What all things? Okay, let's forget it. Okay, think about Titanic survival dataset. So let's say you have the dataset of surviving from Titanic mishap, and you have all rows in there, right? So the values will be like sex, age, which parts they were in, right? So those things will be there, right? So let's say we have a housing price dataset. Okay, so in the housing price, what kind of columns you will have? Let's say area. So let's say we have a point called area. Okay, we have something called garden space. Okay, we have number of flats, amenities. These all can be realistic features. These all can be realistic features of your housing price predicted data set, right? So with the help of this, we will predict a housing price, correct? Let's say we have a survival data set. Let's say cancer data set. Okay, so for predicting cancers, we have a data set like that. For that, we will have internal or external. Let's say some kind of some things like that. Come on, again it went to scratch mode. Internal or external, right? Then we will have a size, we will have malignant or benign, etc. Okay, so what it will predict, yes or no? So you have a gland growth, is it a cancer or is it not? So yes, no. These variable types are called categorical ones. Okay, this kind of variables. So let's say if you are trying to buy a house somewhere in Mumbai, this value will range from 1 crore to 5 crore, and you are most likely to get this area because of this different size, different types of area values. You will get almost all the values between this range. Let's say 1 crore to 2 crore. Let's not go to 5. Let's go to 2. Okay, so you will get all kind of values. So this is the things. Okay, so that's how you need to predict which one to use, right? So usually fixed number or possible. No, Saran, actually categoricals will be skewed. Okay, so it can be more than one also. Let's say we have, when we are thinking about this kind of categorical problem, it can be yes, no. It can be yes, no, or moderate like that. So it can be anything. It will be fixed. Okay, as you rightly told, it will be fixed. But for continuous, it will vary. It will be in a range. Okay, so that's how we decide if the data set that we are having is categorical or continuous. Okay, so based on that we decide, is it a regression problem or is it a classification problem, and based on that we are going to choose our models. If it's a regression, then we are going to go with this linear regression. Otherwise we are going to go with logistic regression, naive Bayes, or xyz. Okay, that's how. So that's the line equation. These are the some variables. These are called observables. This red points, this line is called line of linear regression. That means this is the outcome of your model. These points will be observations, right? And this will be regression line. And how do we decide if the regression line is a good fit or not? We use least square method. Okay, least square method that we'll discuss. Okay, so how do we do that? It's time to discuss that. I will show you with the graph. So let's say we have this kind of a line. Okay, let's say we have a point here. This is x1 y1. Okay, we have a point here. This is x2, y2. Okay, we have a point here. This is x3, y3. Okay, let's keep it to 3 lines. Okay, and somewhere down here, based on this line outcome, okay, this one is regression line. This will have separate kind of xy value. So for this one it will be somewhere here, for this one it will be here, and for this one it will be here. So these are like, here is the y value, here y value for this will be somewhere here, for this value will be somewhere here. So mean of them will be this one. Okay, let me change the color. Okay, mean of them will be this 3, so somewhere around here. This is the mean. Okay, this is the mean of y. Okay, which will denote as y bar. Okay, we will denote as y bar. Okay, now see the basic concept. How do we calculate? Okay, the basic concept of how do we calculate this? Okay, how do we calculate the r square? So these points, if you see, these blue lines are called error from line. Okay, error from regression line. Okay, if I write the equation, that is, we are going to, so as you know, the point distance, how it looks like, x minus x1, y minus y1, right? So that is basically this. So here x1 will be common in both, so it will be the value outcome of this AC line, that is squared error SE for line SE. I am scrolling it a bit up. So we will, what we have, SE of line will be y1 minus y squared plus y2 minus y squared plus y3 minus y squared up to n. This is the standard line error, because this is, if we consider this as y1 and all these values are x's, right? So when I write x, when I write y, that means y actual. Okay, when this y3 means y predicted. Okay, so sorry, I just reverse it. Okay, this is y actual, this is y predicted. So when I say y1, y2, y3, these are these points, right? So these are the original points that we have. So it will be y actual. Y means y predicted, that is outcome from this line. Okay, so y actual, y predicted, like that. Okay, for x1, for x2, for x3. Okay, this is what is denote squared error from the line of linear regression. Okay, this is what is denoted by this. Now I will change the pen color. So if we see squared error from y bar, that is y mean, that is from this red line. I was using a red, let's go back. So this is the point, this is the red line. So this one is the squared error from line. So here is the point. So this one will be the squared error from the mean of the data set. Okay, this is the squared error from the mean of the data set. So what we will have, we will have y1 minus y bar square plus y2 minus y bar square plus dot dot up to n. Right, now understand one thing, this value over here is how likely, how, what is the error between the linear regression line and the data points, right? This value up here is to find out the central tendency of the errors, right? So if you find out mean of these values, this y predicted values, and if you find out the difference between the actual points and the y predicted mean values, that means this is the variance. Okay, this is the distance and this is the variance. Okay, this part is the variance from all y values, this is the distance from each and individual y values. Now in order to get the r square estimate, that is the good fit line, or if it's a good fit or not, what we do, we calculate this value, that is se line divided by se y bar. Okay, we have this kind of a value. So what this denotes, how unlikely the line matches the actual values. Okay, this is what we denote by this part, right? Now if you want to know how good is the model, what we do, we subtract it from 1. This becomes our goodness of fit. For statisticians named it as R squared, or it is also known as least, this is also known as least squared error method. Okay, so this up here denotes goodness of fit. That means how good our model is. Now see what happens to this. Okay, after this I will pause for questions. So the value that we have, right? So the value that we have is somewhere like 1 minus SC line. So 1 minus SE line divided by SE y bar. So if AC line is pretty smaller, right? What does that mean? The line is a really good fit. So this is small divided by AC y bar. This will also get very small, right? If the difference between the each and individual data point is small, this will also get somewhat small. A small number by some number will yield you a small, even a smaller number, right? So that will approx reach to 1. Okay, but if for this equation, the the SE line gets higher and we have AC y bar which will get even higher, which will get somewhere around this, right? So, but it shouldn't be, as this is the higher but less than AC line, so we will have a high value up here. In the AC line we will have a high value. Okay, so this so how it works, this AC y bar, let's say for this equation, if we go back, if the points are even more down, right? So from, if the point is somewhere here, so somewhere here, all the values will be bigger, right? Based on this AC bar and the AC line, all the values will be bigger. So when we divide two big values, it will almost come to 1 and r square value will approx to 0. Okay, so that's what means when r square is small, bad fit. Okay, when r square is large, good fit. Okay, that's why this value r square is named as goodness of fit. Okay, so that's what is about this goodness of fit equation. Okay, these things I already told, this xy things. Now here is an example for you guys. Okay, so we have a few data points, we have plotted all this in the plot. Okay, we have plotted all these data points in here. Okay, now we will see using linear regression how do we calculate this. Okay, so x bar y bar is there, that is the mean of x and mean of y. Mean of x is 3, mean of y is 3.6. Now this is the line, this is the line, and this is the mean point is described with this red point, and this line, right? This green line is for the I mean the mean line. Okay, this is the mean line that we have, that is the y bar that we have. This is the mx plus c line that we have drawn till now. As we know from maths, this is the equation for m, that is the slope. That's how we calculate. So once we calculate m, you will see the value here. I am just scrolling through. Okay, these are some calculations, so I am not wasting time. So that's how we find out the value of m. Okay, so what does that mean? Let me show a few use cases. So if this is the line, now we need to find out value of m. M is x minus x bar into y minus y bar divided by x minus x square, x minus x bar square. Okay, now if we go in, so x minus x bar, when we calculate, that is the difference of the data points from its x mean. Okay, x mean. So these are the data point differences. We calculate this here, we put into the equation, then we go for difference of y, that is y bar, because we need to calculate y minus y bar here, right? So this will be the differences. So this one will be the difference, this one will be the difference, like that we will calculate. Okay, so that's how we will have y minus y bar. We already have x minus x bar, we will square it out here. Then we will find out m by summarizing all this. We will sum all these things up and we will divide it by sum of this thing and we will get the output. Okay, we will get the output. So here m value goes to 0.1. Okay, now y will be 3.6, m will be 0.1, x will be, let's say for 3 we are calculating. Okay, for 3 x equals 3 we are calculating, because as we see for x equals 3, the mean is 3 and 3.6, right? So for x equals 3, the mean, we are calculating based on the means here. Now we will get the c value here, that is 3.3. Okay, so our straight line equations now becomes y equals 0.1x plus 3.3. Okay, so that's how we do calculate our linear equations, logistic regression session. Okay, so one thing to understand, first thing is regarding machine learning, right?
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So broadly there are two types, like supervised learning and unsupervised learning, right? So for supervised learning, we will always have a definite objective. It can be something, a continuous set of variables, or can be categorical variables. Okay, and for like unsupervised learning algorithms, we will always be having a indefinite output, let's say cluster of points kind of things. Okay, that will be for supervised algorithm, whatever data we use, it will consist of a level. It can be a continuous set of variables or it can be categorical, that doesn't matter. Okay, so it will always be, the data will be definitive. It will give you some kind of a output. Now if so why do we need this kind of a different set of algorithms, right? When we are dealing with linear regression, why don't we have, or why do we have this logistic regression, which is a classification algorithm? So the thing that you need to understand, for linear regression, if the data is continuous and spread across a good amount of range, then only the line can help you in predicting the values, right? But instead, if it's a categorical problem, like where the data is skewed in two ends or three ends, like let's say values of 0 and 1, the best scenarios that we have. So typical examples of logistic regression would include, typical examples would include like uh, tumor prediction, is it a malignant or benign one? Okay, it would be spam classifier, it will be fraudulent transaction detection. All those kind of things will come under logistic regression. So as you can understand from the name itself, here the data will be too skewed, right? It will either have a yes or no value, or you can say it like 0 and 1. So if you have, let's say, 10,000 data points skewed between 0 and 1, there cannot be anything which sits in mid of it, right? It cannot sit between 0 and 1, right? So it should be at the two fag ends. So if you draw a line from two ends, what would do, that would be horrendous for a linear regression model to fit in, right? So why so? Unweighted decision tree is something else and the logistic regression is something else. So it's those two are different things. So don't just confuse the algorithms. Okay, so when I am going with one algorithm, stick to that. If there are any relations between them, I will also cover that, which is sadly there are nothing. Anyways, so to continue with it, for this kind of logistic regression problems, the data will be skewed between 2 points, right? So if we draw a line between point 1 to point 2, if it's a straight line, then also it won't fit the data. When I am telling this, what do I mean? I will shortly show you that. Okay, so what do I mean with that? The data will be skewed and the line can't fit it, right? So let me open this. Okay, when I say that it cannot fit the data, right? We saw for linear regression, how the models worked, right, and how the data points look like. But let's say what we are talking about today is it will be some kind of a graph like this. If you plot the observations, right, then I mean when you plot, sorry, when you plot the outputs in a graph, in yesterday also we did the same thing and we saw there was a continuous set of variables, but here what it will do, yeah, so it will be, let's say these are some data points which will be near 0, right? These will be some data points. So the output of this will always stack to 0 and output of all this will be stacked to ones. Like that, this kind of a set will be there. So if you draw a straight line, it would only fit 1. It can fit max of 2 values. It can fit max of 3 values, like that, right? So in that case, what would happen? The model will fail radically because the error percentage will be huge, right? And it won't be fitting a good model. So that's why we won't be able to use linear set of regression, linear set of models to fit in this kind of a requirement. Instead, we would need this kind of a curve, right? See, now this fits in perfectly, right? This fits in perfectly in the under training example. So this curve is again called, this curve is called sigmoid function, right? This x-shaped curve, S-shaped curve. So what is the features of it? It is an asymptotic curve, right? When do we say asymptotic? That means it will never reach 1, it will never reach 0. Okay, so what it will do at positive infinity, at positive infinity, it will asymptote to 1. At negative infinity, it will asymptote to 0. Okay, so it will never match the lines, but it will be asymptotic. So in this kind of shapes, we can have some kind of a good fit for this kind of classification problem. Yesterday's thing was based on a straight line equation, right? It was a y equals mx plus c. This kind of a straight line equation was yesterday's topic of discussion. But today's topic of discussion will be this kind of a asymptotic curve. Okay. So before going to this, I will be covering one more. Okay, I will come to that later. So this curve equation is this 1 by 1 plus e to the power minus x. So this curve, as you see, it will asymptote at the positive and negative infinities, right? So if you see e to the power minus x, then if you set the value of x as minus infinity, what would happen? A very large number will come at the denominator part, which will force this value to go to 0, but it won't be 0. But as you know, infinity is a big number, so infinity plus everything will be infinity itself, right? So it will be very near equals 0. But if it is positive infinity, then e to the power minus negative infinity will be too small to be considered as 0, right? So this value will asymptote to 1. So that's how the sigmoid function works. And we will establish our logistic regression functions and everything based on this function itself. Okay, this function itself. So now what I will do, I will go to the PPT and will cover the things that are there. Okay, then I will again come back to the curves and all. So this is how the basic concepts of logistic regression stands. So this is how this sigmoid function comes into picture instead of a linear regression line. Okay, so I explained the basics of it. Now let's see with an example. Okay, so someone is asking you to, hey, see, I want to buy a property which will have a bigger garden area for some amount of money. Okay, so what we will do, we will do a simple linear regression, right? So what we will do, we will have the dependent variable as property size. So we will have an independent variable of money. So it's obvious, right? If you want bigger garden area, that means your property size has to be bigger, right? So you need to spend more money than before, right? So again, it has many other many other criteria, but let's have this fixed. Okay, let's say the locality is fixed, the area is fixed, that the village or the town or the city is fixed where they're trying to find the house. So if you consider there are only two external variables, that is money and dependent property size and money, then in that case what we will have is we will have a linear equation between these two, right? So their linear regression will perfectly fit in. Yes, Giri. So that's what I told. So property size. So that's how it is. So next point will be, so bigger garden area means there will be smaller house area. So we are, I mean, what we are doing here, we could have taken a multivariate solution here, but we are going for a small part. So we are breaking it into chunks. Okay. So when we are searching for bigger garden area, what does that mean? That means the house area will be smaller, right? So in a property, if a house is there, let's say we want to buy 1,000 square feet of 2,000 square feet of property. In that garden area, we want of 900 square feet. So the house area will be shrunk to 1,100, right? So that's how. So here also a linear equation exists between them. Why? Because if you make the garden area large, the house area will come down, right? So house area and garden area size will also have a linear kind of equation. This can be solved using linear regression. So this kind of problems can be solved using linear regression, because this is not categorical. The data will be continuous. So the value, the size values or the price values, when you plot it, it will be, so it will be uh, linearly dependent between them, and as it is a continuous value, so linear line will fit it. There might be errors, there might be estimation errors and all, that's fine, but it will fit a linear model, so we can predict those kind of things using linear regression. So what we can say from this, like if the guy who is asking you for buying a house, if he spends X amount of a money, he can buy Y amount of Y area of a house. Okay, Y property area he can buy. So this one you can comment from linear regression. But let's say the guy wants to ask you, so the property will have a good neighborhood, will the location be noiseless suburb or a busy bustling city? So how the properties, what is the location of the property, that kind of preferences someone wants to ask you, then you will be in a soup. So see this problem statement, will the property have a good neighborhood or not? What the values it will have, it will have a categorical value 0 1, right? So again, if you plot here, if you plot those 0 1 things here, like I saw, like I described in the plot before, it will be skewed in 2 points. So if I draw a linear line, it will feel radically, right? You can't predict it. So if I go back to my plot, let's say we are trying to deal categorical problems using a linear regression model. So I will draw it again. Okay, so let's say these are a few values. Okay, these are zeros, these are one. So I have a data set where this neighborhood is also given, and neighborhood is given as like good neighborhood or bad neighborhood. So this is good, this is bad, this is bad. Now let's say I draw this line. Okay, so now let's say some property is bad. So but what it will do, let's say we want to know if the property has this kind of a value, then what is it? So it will predict the values in here, the Y value will predict in here. So will be this one will be your value. So what can you comment on this? So the value coming will be around 0.3 or something. So there will be a lot of error, but it should have been coming as 0. It will get worse till you once you move to the top of the line. So it depends on the line that you draw actually. So come on, why it is not going? Yeah, so let's say some point here for X here, the value will be coming up here, right? So this will again go to a good property, but there it should have been a bad property. So this kind of problems won't be, you won't be able to solve using linear regression models. Okay, this kind of problems you won't be able to solve using linear regression models. So in this case, you need that funky S-shaped curve, that sigmoid function curve that we shown here. Okay, so that's the whole idea. So this kind of a classification problem linear regression won't be able to answer. So you would need to apply logistic regression models to this, and this will help you in answering classification problems. So this is the never ending loop that it will go on. Okay, so will the property have a good neighborhood? Will it rain tomorrow or not? Is the mail spam or not? This kind of small questions, this kind of small classification questions, it can answer. Okay, so let's go ahead with this PPT. Okay, so see, machine learning, supervised, unsupervised. Supervised is again divided into two broader categories: regression, classification. Regression we already covered, linear regression. Today we are going to cover logistic regression. That's another classification problem. There are many others. We will come to those one by one, but these are some major chunks. Okay, so a statistical classification model, as you already know, this machine learning, heart of machine learning is stats. Next is deal with categorical dependent variables. Explain this. could be binary or dichotomous. So that means it should be having two values, not more than two. It could be multinomial. Yes, obviously it can have only one feature of x. It can have multiple features x, right? So yesterday we saw how it does for univariate and multivariate machine learning linear regression models, right? Same thing applies for logistic regression models also. So x can be only one feature or x can be a set of features. So that's where that way it can be either multinomial or it can be univariate. Okay, it can take both continuous and discrete input data. Yes, because this kind of a S-shaped curve can also fit continuous data also, but again in that case it will have a lot of errors, right? So continuous variable, if you plot using a S-shaped curve, it will be giving you some model, but the to explain. Okay, so that's why we don't really specify it. So we only consider of this categorical data. Okay, for continuous variable also you can plot this, but it won't be helpful because it will be having some problems, right? Because it won't be able to take care of continuous variables. Okay, so that's why we have linear regression models. Yes, sure. So for multinomial, it is like, let's say we are trying to
Just a quick info, guys. Intellipaat provides online data science master program in partnership with IBM. The course link of which is given in the description below. Now, let's continue the session.
find what should we find? Spam classifier. Let's go ahead with the example that we have. Okay, so for spam classifier, if we think there is only one feature to be, that is count of spam words, right? If we think this is our only feature, so what do we mean by spam words? It will be misspelled words, right? It should have walk like this. It should have sell, buy, money, transfer, bank details. This kind of words are very commonly noticed in spam classifier, right? So if we want to build a spam classifier using only count of spam words thing, right? Only count of spam words thing, then it will be univariate. Now, if you have noticed spam emails, it has one more feature also. Like for spam emails, the sender address will be fishy. The sender address will be fishy. What do we mean by fishy? The domain name will have some absurd kind of a values. It might not be a permanent domain, right? So if we take that also in account for building a spam classifier, it becomes multinomial. Why multinomial? Because okay, let's so why multinomial? Because we know we denote feature vector by x, right? So if x contains only one value of x1, then this is univariate. Okay, because the number of independent variables in here is only one independent, right? So whatever has to change will change with the value of x1 only. But if x contains more than one, that is x1, x2, xn, so it might happen that among these n features, all n features are useful. It can happen, or it can happen some, let's say 10 features are useful. Okay, others might be junks, but it has 10 features, so 10 independent variables, right? So as we have 10 independent variables, what it does, it will have like 10 layers of x versus, so it will have a 10 independent variables. So the y value that we are going to predict will have multiple features in it, right? Will have multiple features in it. So we need to fit in more than one feature vector in our machine learning equation. So if I go back to this equation, like we see here, this is the equation for linear regression, right? So if we have something like this, 1 plus e to the power minus, I will come to the derivative, I mean machine learning form later. Like this, if we have, then it becomes a multivariate problem. This is a univariate problem. Okay, so that is how it depends, because here it output of the model will depend on more than one independent variables. So that's why this is called multinomial. Okay, so that's what the idea is. That's what is about multinomial and univariate things. So here also we can predict, here also we can have this kind of we can use clustering algorithm to predict the data. Okay, we can use this kind of algorithm to predict the data. Okay, so for clustering, what happens, as a point came in, I will show you. For clustering, divide data in unique sets, right? So that is what is called clustering. So the sets can be 0, 1 also. The set can be cat, dog, fish also, right? So the both type of problems can be solved using clustering, but for classification it won't fit this purpose, right? That is the whole base of our statistics. So for clustering we will have a different set of algorithms. There, if you see, there no kind of a machine learning model will be there. There will be a generic set of steps that we need to follow. Stats will be there, but it will be in the minimalistic part. Okay, so that's how it works. Okay, let's go ahead. So this is a tool for applied statistics for discrete data analysis. You've already discussed. Gives outcome in terms of probability, right? That's what it does, right? So what the model will do, the model will give you a probabilistic output. Like, let's say for this email to be spam, the chances are 70%. We will convert that to 1. We will see this. So this is again based on probabilistic models only. Okay, so this logistic regression will be, the probability will play a big role here, because see, one thing you need to understand, when we are going for logistic regression problems, yes, this the equation that I have shown, this will be the curve equation that we have. That's true, that's not a problem. But the thing is, when you are predicting the output, so what this value will predict, this 1 by 1 plus e to the power minus x, it will never predict 0 or 1. Perfect 0, 1, 1 it would never predict, right? Because it is an asymptotic function. So at and infinite values you won't be giving to the function, then the function will stack, the function will be looped in for forever, right? So it will output some values from 0 to 1. So that will be the probability of that problem. Let's say the email probability of probability of email being spam, right? So this kind of outputs it will give. So when it gives greater than equals 0.5, we can consider it to be 1. Less than 0.5, we can consider it to be 0. That's how the math tells us. So this is again, this kind of things will predict the probability of the event being happening. So probability theory also will play a big role here. Okay, so that's how this works.
What you can do with machine learning. In today's session, you will see what type of question you can ask your machine with classification algorithm, anomaly detection algorithm, clustering algorithm, and regression algorithm. I hope the agenda is clear to you guys. So without delaying any further, let's start with what type of question you can ask your machine. Well, you can get answers of these questions like what types of house lies in this segment, or what is the market value of this house, or is this mail a spam or not spam, or is there any fraud in this transaction. So all of these kind of question comes up under the category of machine learning. So let's move on ahead and see some of the machine learning algorithm and what type of algorithm can deal with these kind of question. So on first we have classification algorithm. So using classification algorithm, you can predict a category using the data. For example, is this person a male or female, or is this mail a spam or non-spam? So these type of question, it comes under classification algorithm. Or is it going to rain tomorrow or not? So all these type of question comes under classification algorithm. Next is anomaly detection algorithm. It is generally used to identify unusual data points. For example, is there any fraud in this transaction, or is someone trying to hack our network? So these kind of question comes under anomaly detection algorithm. Next is the clustering algorithm. Well, clustering algorithm groups the data based on some condition, like which type of house lies in this segment, or what type of customer generally buys this product, recommendation engine, right? So these type of question comes under clustering algorithm. Next is a regression algorithm. Well, this is used to group data based on some condition, like what is the market value of this house, or is it going to rain tomorrow? So these were some of the various machine learning algorithms. Next, we have machine learning for you. You have few links which you can just go out and see some cool machine learning projects you can use. Perform a hands-on on machine learning. We'll be loading a dataset, understand its structure using statistical summary, and finally create 6 different machine learning model and pick the best of it. Okay? Well, there's a little piece of advice for you guys. If you really want to learn machine learning with Python, so I'd suggest you to complete an end-to-end project. At least it'll force you to install and start your Python interpreter, right? It'll even give you a bird's eye view of how to step through a small project. And once you complete one of the project, you will get a confidence, and maybe you can go on and start with your own small projects. Okay, so as a beginner, when you are applying machine learning to your own dataset, you are working on a project. So a machine learning project may not be a linear. It may have a number of steps like define the problem, prepare the data, evaluate the algorithm, improve the result, and present the results. So the best way to really come up to terms with a new platform or tool is to work through a machine learning project end to end and cover the key step, namely loading the data, summarizing it, evaluating algorithm, and making some predictions. So once you complete it, you will have a template of your own that you can use on dataset after dataset. So you can fill in the gaps such as further data preparation and improving results task later once you have more confidence. Okay, so let's move ahead. Things you will learn after this session. So once we are done with this session, you will know how to load the dataset, how you can summarize it, how to visualize your dataset, how to evaluate some algorithm, and finally you will learn how to make some predictions. Okay, so let's move ahead. So we'll be performing the demo on Iris Flower dataset. Well, the project which we are going to perform is generally known as the Hello World of Machine Learning. So it's the best project to start with because it's so well understood. Okay, and why it's so well understood? Because so all the attributes in this dataset is numeric. So all you have to do is figure out how to load and handle the data. So it's a classification problem, thereby allowing you to practice with perhaps an easier type of supervised learning. Okay, it also supports a multi-class classification problem that may require some specialized handling. So this Iris dataset consists of 4 different attributes: sepal length, sepal width, petal length, and petal width. And it consists of 150 rows, meaning it is very small and it can easily fit into the memory. All the numeric attributes are in the same unit and the same scale. Okay, so this dataset doesn't require any special scaling or transformation to get started. Okay, so let's get started to your Hello World machine learning project in Python. So this would be a step-by-step tutorial. So let's get started with your Hello World machine learning project in Python. Okay, so this is my Jupyter notebook. So the very first thing that I'll be doing up here is importing all the required libraries. So I'm importing pandas, and from pandas I'm importing scatter matrix. Next I'll be importing matplotlib as PLT. Then we are importing model selection from sklearn, classification report from sklearn.metrics, confusion matrix from sklearn.matrix, accuracy score again from sklearn. And these are various machine learning models. Okay, KNN classifier, linear discriminant analysis, Gaussian naive Bayes, and support vector machine. Okay, so we are importing all these models from our scikit-learn library. Okay, so let's execute it. Our next step is to load the dataset. So the very first parameter that I'm passing up here is the URL of my dataset. Okay, or the path of my dataset basically. So there's my dataset just to show you. So this link consists of my dataset. Okay. Next, I'm defining an array as names. This consists of the name of the attribute, sepal length, sepal width, petal width, and class. Okay. And next, I'll be defining a variable as dataset. And next, I'm defining a variable dataset. So dataset equal pandas.readcsv URL comma names equal names. So what it is basically doing, it is fetching the data from here, from this link, URL from this URL, and it is giving the name of the attribute as all these: sepal length, sepal width, petal width, and class. Okay, so this will basically load your data set. Fine, let's execute it. So our data set is loaded. Now let's summarize the data set. Now let's check how many rows and columns do our data set have. So let's execute this and check the shape of our dataset. So our dataset consists of 5 different columns and 150 rows. Okay. Next, if you want to check the sample dataset, then you have a head function over here. So this will give you first 20 result of your dataset. Okay, 0 to 90. Fine. Next is the dataset.describe function. So this will give you the various description from your dataset like count, mean, standard deviation, minimum, percentile, 25 percentile, 50 percentile, 75 percentile, and max. So count is basically the total count of sepal length, sepal width, petal length, and petal width. Okay. Similarly, mean of all, similarly standard deviation, and so on. Okay. Next, what if I want to check how many different classes are there or how many values contains in each class? So we'll group by the class and we'll find the size of each class. Okay. Let's execute it. So we got the output up here as Iris setosa 50, Iris versicolor 50, Iris virginica also 50. So this means that we have 3 different classes: Iris setosa, versicolor, and virginica. All 3 of them consist of 50 values. Okay, fine. So next is data visualization. So now that we have some basic idea about our data, let's create some visualization out of it. So we are going to look at two different types of plot. The first would be a univariate plot, that is to understand about each attribute, and next would be the multivariate plot to understand the relationship between the attributes. Okay, so first let's plot a univariate plot, that is plot of each individual variable. Okay, so this is the univariate box and whiskers plot. So let's consider just sepal length. So the bottom part of here, this represents the minimum value and this is the maximum value. Okay, and this green bar over here, it represents the mean value. So if you see the mean of sepal length, it's around 5.84. It's also representing the same. So it's 5.84. Okay, these circles above and below the minimum point are nothing but the outliers. Okay, yeah, one more thing, the minimum and the maximum value, right? So minimum is 4.3 for sepal length and maximum is 7.9. Okay, so the minimum value you got up here is 4.3. Okay, so this is my 4.3 minimum value, and here we have the maximum value as 7.9. Okay, and these are the outliers, these circles. Similarly for sepal width, my minimum value was sepal width was 2.0 and maximum 4.4. So minimum from here is 2.0, this value, it's an outlier, and the maximum value is 4.4, this value 4.4, it's also an outlier, and the mean value of sepal width is 3.05. So we got mean somewhere around here. Okay, so in order to understand our data in a better way, we created a univariate box and whiskers plot. Okay, this gives us a much clearer idea about the distribution of the input attributes. Okay, well, if you want, you can even create a histogram of each input variable to get an idea of the distribution. Okay, so let's execute it. So there's my histogram. So in sepal length and sepal width, I can find the Gaussian distribution up here. Okay, so this is a useful to note as we can use algorithms that can exploit this assumption. Okay, next we have is the multivariate plot. Well, multivariate plot is used to check the interaction between the variables. Okay, so let's just execute it and see what's the output. So here's a scatter plot of all pairs of attribute. So this can be helpful to spot structured relationship between input variables. Okay, so as you can see, we have diagonal grouping of some pair of attributes. So this suggests a high correlation and a predictable relationship. Okay, so from here you can say that sepal length is more dependent on sepal width as compared to petal length and petal width. Similarly, same thing over here, right? So petal length is more dependent on sepal width as compared to sepal length and petal width. Okay, and the petal width, it's more dependent on sepal length as compared to sepal width and petal length. Okay, so these are the things that we can conclude after visualizing our data. Okay, now it's time to create some model and estimate their accuracy on unseen data. Okay, so here we'll follow step-by-step procedure. Okay, first we'll separate out a validation dataset, that is divide our dataset into train and test part. Then we'll use a 10-fold cross-validation technique that will randomly distribute our data into 10 different data sets. Okay, so that we can perform training and testing on each part. Then we can finally combine the result of all of them to get a better accuracy. Okay, then we are going to build 5 to 6 different models to predict species from flower measurement. Okay, and then finally we'll select our best model. So our first step is creating a validation dataset, that is dividing our dataset into train and test. So here what we are doing, dividing our dataset into train and test.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Fine. Array equal dataset dot values. So it consists of all the values inside your dataset. Here you're defining x equal array starting. So here you're taking a portion of the array. Okay, and you're placing it in x. So what is that? So your row up here is nothing. So it will start from the very first row and the column 0 to 4. So it will take up to fourth column. So 4 column from the first row, that is x is storing all the name of the attribute. Fine. Similarly, we are defining a variable y. So y will consist of the fourth column. Next, I'm defining a variable y, array of starting from first row and fifth column. Okay, as 0, 1, 2, 3, 4. So here number 4 represents my fifth column. Okay, next I'm defining a validation size as 0.20. So here validation size means it will split my data as 80% in one part and 20% in other. Okay, So next we are defining a seed value. So this seed value is used to initialize a randomization. Saving or setting it to same number each time guarantees that every time you execute the algorithm, it will come up with the same result. Okay. Next we are defining scoring as accuracy. And here we are defining X train, X validation, Y train and Y validation. So here we are defining X train, X validation, Y train and Y validation. So X train would be my training data from this part and X validation is the testing data from same. Okay, so according to my above code, my 80% of the data will lie in the training part and the rest 20% would be treated as a validation data or the test data. As I have already mentioned, the validation size is 0.20 or 20%. So this means that 20% of my data is test data. Fine. Similarly, we'll define Y train and Y validation. That is 80% of the training data from this array and rest 20% of the testing data from same array. Okay, so here we are basically splitting our data set. Okay, on the base of X, Y, test size equal validation size that we have already specified as 0.20 and my random state equals C and my random state is C. So every time I execute it, the algorithm will come up with the same result. Fine. So now that we have created a split among our dataset and we have divided our dataset into train and test. So our next step would be to build our model. Okay. So this is how we are building our model. Okay. So from the scikit-learn library, we are calling logistic regression. We are calling linear discriminant analysis, KNN, decision tree, Gaussian Naive and SVM or support vector machine. Okay. Here what we are doing, we are creating 10 folds. Okay. So 10 folds, let me just go step by step. So here we are defining a variable as kfold. So kfold equal model underscore selection. Kfold, how many split we want to perform is 10 split and random state again C, that is 7. So every time it will perform the same random split. Okay, so this is how my data would be splitted into 10 different parts. Okay, now once the data is split into 10 parts, then we'll define a variable as CV underscore results. Okay, so CV underscore results equal model selection dot cross validation score. Inside that we are passing our model, what model we are choosing. We are passing the X train data, the Y train data, CV equal kfold, whatever the value of kfold is there, and then finally scoring, which we have initialized up here as accuracy. Okay, then what we are doing, we are appending our result. So our CV result would be appended to results, that is to this list. So next we have is result.append CV underscore result. So this list would be updated with the CV underscore result value, and here we are appending the name, and finally we are printing our desired result. So one by one this will go in a loop. Okay, so every time this loop execute, you will get the accuracy of one of the model. Okay, so here right now our model consists of all these values. Okay, as we are appending it, that is we are adding all these values one by one to our model. It consists of logistic regression, decision tree, Gaussian Naive and support vector machine. All of them are in our model. Okay, and finally it is printing the message. Let's check the output. So we got the output as this. So here the accuracy of a logistic regression is 0.96, that of linear discriminant analysis is 0.97, KNN 0.98, decision tree 0.96, Naive is 0.97, support vector machine as 0.99. So from this we can say that support vector machine is having the highest accuracy. Okay, so now our next step would be to compare the algorithm and select the best model. So just by looking at this output, we can say that support vector machine is having the highest accuracy. But let's compare all these algorithms and see which one fit the best. So for that, I'll be plotting a box and whiskers plot for the accuracy versus the name of the algorithm. Okay, so there's my algorithm comparison. Here I have the name of my algorithm and this is the accuracy for them. The green point which you can see up here is nothing but the mean values or this value. Okay, for linear regression I had 0.96, for linear discriminant analysis I had 0.97 and so on. So from this graph what I can say is KNN, Naive and support vector machine, these are having the highest accuracy. Okay, as there is no minimum and maximum value, only they are having a maximum value and few outliers, these outliers. Okay, so in case if you are removing these outliers like this one, these two and this, so by removing them KNN will give you the 100% accuracy result. By removing these two outliers, Naive would give you the highest accuracy result or 100% accurate result. So even in case of SVM, if you remove this outlier, you will get a model with 100% accuracy. Okay. Now next is making the prediction. Well, just accuracy shouldn't be your metric to decide that this is your best model. Okay, so for selecting a model, you have several other features which you should decide apart from accuracy. Okay, so your accuracy will not always be the metric to select the best model from. Okay, so let's move ahead and see how to make the prediction. So we have already calculated the accuracy, right? So now from this graph, we know that support vector machine is giving the highest accurate result even with the outlier. If this outlier is removed, then it's the best one. Okay, now let's make some prediction on it. Okay, so let's execute this. So here we are printing the accuracy score, we are printing the confusion matrix and the classification report for Y validation and prediction, that is testing and predicted value. So here we are printing the accuracy score for the tested value and the predicted value. We are printing a confusion matrix for the tested value and the predicted value, and finally a classification report, same for the tested value and predicted value. So if you check the score for tested value and predicted value, like accuracy score while using SVM or support vector machine is 0.93. So there's my confusion matrix up here. And finally, we have a precision, recall, F1 measure, and support data for all these three classes: iris setosa, iris versicolor, and iris virginica. So let me just explain you what is precision, what is recall, what is F1 score, and support. So this precision, it tells how accurate or precise is your model. That is, out of those predicted positive, how many of them are actual positive. So this is precision. Okay, next is recall. It calculates how many of the actual positives our model has captured through labeling it as positive. Okay, next is F1 score. It is used when you want to seek a balance between precision and recall because of a large number of actual negative values. Okay, and finally we have support, which is the number of sample of the true response that lies in that particular class. Okay, so while predicting with SVM, we had 7 true responses in case of iris setosa, 12 in case of iris versicolor, and 11 in case of iris virginica. Okay, similarly, I made prediction using SVM model. If you make prediction using KNN, you'll get a different result up here. In this case, we got the accuracy as 0.9, and the precision score, recall score, F1 score, and support score all are different. Okay, so here in case of KNN algorithm, you can see that we have the accuracy as 0.9 or 90%. The confusion matrix provides an indication of the 3 errors that we made. Finally, the classification report provides a breakdown of the class by precision, recall, F1 score, and support. Okay, so we use Python to create few machine learning model and select the best model out of them. So our best fit model is SVM, as it is giving the highest accuracy and high values of precision and recall. Okay.
So in this session, we'll take a look at what machine learning is and how you can use scikit-learn, which is one of the most popular libraries in Python for machine learning models, to use scikit-learn package to build models that could classify the data that we send to it. So now let's take a look at what is classification, because that is the kind of model that we'll be building. I'd like to help you understand what classification is. For those of you who are unaware, classification is a machine learning technique that comes under the supervised learning technique. In supervised learning technique, you can build regression models as well as classification models, and we'll be taking a look at classification. I'll also explain what regression is. So let's take a look at what is classification. So in machine learning, classification is simply an activity that consists of putting things into the categories based on the similarities or common criteria. If I give you a lot of people who have applied for the loan, who have applied, if you're working in a banking industry, you need to help understand them what are the kinds of transactions that could lead to fraudulent transactions, and to do that you can take in some data about the transaction, the date, the time, the username, the user's credit score, so on and so forth, and using that you can figure out whether or not this transaction is fraudulent or not. So that is the classification problem, when you already have some categories defined and you want to place the incoming data into one of the categories. So there are a fixed set of outputs that your input can map into. So for instance, our digit recognition is a classic example of classification, in which what we do is we take in an image, we analyze it, and we figure out whether or not it contains which number does it contain from 0 to 9. So it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, any one of those. So there are 10 possible classes that our input could go into, and that's what we do in classification. So that's what classification is. Another problem could be regression. Regression is basically when you're trying to predict a continuous value. So think of it this way: when you're trying to predict a continuous value, A continuous value would be you're trying to predict the temperature, you're trying to predict the housing price based on the features that you have. You're trying to predict the stock market price. These are continuous values because it could be a number in fraction, it could be a whole number, it could be a lot of things. There's no particular categories that you can put this into. So that's regression, and we're learning classification here. So that's the difference between those. So let's take a look at common classification problems. The first is character recognition. So if I give you if you've used anything like Google Lens, you probably know what character recognition is, in which it takes a look at an image and figures out what are the things that are written in that image. So it could be that it figures out what's written on a board, it could be figure out what's written on a piece of paper, so on and so forth. That's character recognition. Then comes face detection. So if you are unaware of what face detection is, if you ever used a mobile phone with a camera, you put someone's face in that camera and it creates a bounding box around it to help you help it focus on the person's face, and that's what face detection is. Face detection and face recognition are two different things. Face recognition is understanding who that person is. So in face recognition, what we do is, good example of it is that is the feature that Facebook has deployed, in which you upload an image and it understands whose face is in these images and then gives you the person's name around the bounding box and tags them automatically. So that's face recognition. This is face detection. Then comes fraud detection. So if you work in the banking industry, fraud detection is something that is used. Fraud detection is something in which machine learning is used quite a lot. It takes a look at a lot of transaction, users' credit scores, so on and so forth, and understands what are the different transactions that could be considered fraudulent. Finally, we have intrusion detection. This is used in cybersecurity. What they do is they take a look at a lot of logs that it has and takes a look at the activity that was performed by particular IP addresses or a range of IP addresses in those logs, and understands what are the IP addresses that have tried to intrude in our system. And if it looks like a person, if it's classified as a person who's trying to intrude in our system, we blacklist their IP addresses, we report them to the authorities. That's the kind of thing that we do. Yeah, so someone has asked, how do we use machine learning in this aspect? Are we using Jupyter in the aforementioned uses of machine learning? So Jupyter Notebook is a software that we'll be using, but machine learning statements don't really care about how you're creating those. Jupyter Notebook is really useful because it allows us to bundle up code with explanations and the output of the code all in one place. So that's why we use that. But if you were to use plain Python scripts, that would work fine as well. All right, so now we'll move on to the next section, in which we'll take a look at some popular classification algorithms. First one is logistic regression. So in logistic regression, we learn from the data, and with that we use a log loss function, and we try and make a prediction about the probability of some particular data point being in one of the following categories that we have. So for instance, in our digit recognition example, what we do is we have 10 different categories, and what logistic regression would do is it would take a look at all the data points that we have given it and figures out a probability that each data point belongs to one of the following categories. So for instance, if I give it an image that contains 7, it will pick a probability of, let's say, around 0.05 that it's 1, 0.4 it's 2, 0.3 it's 3, and it goes along so much. And finally, when we go to 7, it has given the probability of 0.9, which is the highest, which means that logistic regression algorithms give us a bunch of probabilities, and the one with the highest probability is the one that we should choose. So that's the basics of it, and that's how it makes the prediction. Okay, so now let's take a look at the other one, which is decision tree. In decision tree, it's very easy to conceptualize. What it does is that it takes a look at the data that we have, figures out columns and values in those columns, and tries to split the data on that. So if I give you, let's say I give you the temperature. I want to figure out whether or not tomorrow it's going to rain or not. So it's going to be classified as either rainy or sunny. In that scenario, we give it the data, it takes a look at the data and figures out what are the different category, what are the different columns that we have, or the features that we have, and using those features, how can we split the data so that we can make the decisions better. So, for instance, if it takes a look at the temperature previous days, and then figures out whether, okay, so in the previous days the temperature was 37 degrees. So on 37 degrees, whether if it's higher than 37 degrees, then it takes a look at other features, and if it's lower than 37 degrees, it takes a look at some other features. And doing that, after looking at all the features and coming up with these rules, it figures out, okay, the final answer that I can give you is yes, it's going to rain, or yes, it's going to be sunny. So then we go to random forest, and the random forest uses multiple decision trees to increase the accuracy of the decision. And after getting the results from all the decision trees, the result that has the highest frequency in the decisions that it is gotten from the decision tree is the one that's chosen. So if we get 5 decision trees, and all out of 5 of those, 3 of them predict that the number inside an image is 7, and others predict the number inside an image is 1. 7 is the output that's given to us. And then comes naive Bayes, or naive Bayes, how you pronounce it. It's the kind of algorithm that is used by using a probabilistic model. Inside naive Bayes, what we do is we take a look at the probability of something being mapping to a particular class. It comes up with probabilistic heuristics, and then tries to figure out how to use those probabilistic measures to use it. Now, in case you didn't understand a lot of these algorithms, it's fine. These algorithms do take a lot of time to digest, to understand, to implement. And as you can see that it could take you a lot of time to understand these algorithms, as well as to write these algorithms. It could be very difficult for you. So keeping that in mind, we use scikit-learn because it contains all these algorithms pre-written for you. So you could just take the data, use these algorithms that have already been built for you, and then figure out what's the accuracy and how well it predicts your data. So now we finally come to scikit-learn. So what is scikit-learn? Scikit-learn is a free open source machine learning library that contains generic implementation of common machine learning algorithms. So as we've already discussed, there are a lot of algorithms that you can use in order to build a machine learning model, but writing those algorithms from scratch on yourself by yourself is going to be really difficult. So using instead of that, what we do is we use scikit-learn. Scikit-learn allows us to import the algorithms ourselves after understanding the data, and we can just use those algorithms that have already been pre-written for us to implement our model instead of us having to implement the algorithms ourselves. Since they are common algorithms, they have been implemented by people already. Okay, so now the thing that we have to understand is that it contains a lot of functions to perform commonly used operations. So it doesn't just contain the machine learning algorithms that we want to use. It also contains a few functions that we use a lot. So for instance, if we have some data set and we want to split it into a 70-30 ratio, it has a function for that. If you want to figure out if you want to validate our data set against different distributions of data, it has a function for that. If you want to generate a confusion matrix, it has a function for that as well. So there are a lot of things that it covers. It doesn't cover everything, but it has a lot of functionality out of the box that we can use. All right. So with that, I have another question for you guys. Hopefully, if I show it to you on the polls, you'll be able to see it. Okay. So now I think you can see the question. For those of you who are unaware, the question is, can you build a machine learning model by only using scikit-learn and no other library? So if you are not using any other library other than scikit-learn, can you build a machine learning model? When I say no other library, I mean you are not able to use Python as well you are not able to write, you are not using any other thing other than scikit-learn. So for all the tasks involving machine learning and everything, can you use scikit-learn only? So the answers are that options that we have is yes and no. So I'll wait for the answers, and once I've gotten all the answers, I will tell you the correct answer. So I encourage everyone who's participating in the all right, majority of you have answered, and the options that were available were yes and no. I'd like to tell you the correct answer, which is for the question that can you build a machine learning model with only using scikit-learn and no other library. The correct answer is yes, you can. The people who have answered no, I'm assuming that you guys were thinking that because we have to use NumPy or Pandas or other libraries like that, we could probably not be able to use build a model without using those libraries. The thing is, you can build a model without using those libraries, but you would have to do a lot of coding yourself. You would have to import the data, parse it, split it, and then use it inside the library of scikit-learn. But only using scikit-learn, you can build a machine learning model. It's just going to be really difficult, and without using scikit-learn on any library, it's going to be even more difficult. So the correct answer is yes. For those of you who have answered yes, you were correct. For those of you who answered no, you were incorrect. But depending on how your thought process went, you were really close. All right. So now let's move ahead. I've closed the poll, and now let's take a look at why should you use scikit-learn. First of all, it's very easy to use. Scikit-learn is extremely easy to learn and use, and it makes the task of implementing mathematical algorithms really easy because it contains all the implementation with it. We just have to understand how to use the classes and the functions available in the library. It's very well documented. It's got an extensive documentation that contains information about how to use every available feature in the scikit-learn library. And using that, we can take a look at that. Then it's been created by experts. So scikit-learn is a library that has been created by expert data scientists who have been inside the data science business for a long time. They have written these algorithms themselves, and these people have been writing algorithms that are relating to data science from their hand for a long time. So they know how to make a generic implementation that many people can use. And finally, it's very well tested. It's been used by several developers across the world who contribute patches and bug fixes. Scikit-learn is an open source library, so if you want to take a look at the code underneath the hood, you can just go to GitHub, search for scikit-learn or sklearn, and you can get the library code yourself. If you find some problem or want to help scikit-learn grow and add some features to it, you can use GitHub to add some features in the code that the scikit-learn has, and then suggest a revision to the developers and maintainers. Because it's open source, many people have already found a lot of bugs and submitted a lot of bugs. So that means it's battle tested as well, and it has seen a lot of issues already. Now let's take a look at steps in building a classifier. This is an important concept, right? So now let's take a look at steps in building a classifier. So there are 5 steps in building a classifier, but there are several steps in building a classifier. 5 to be exact, but depending on how you're training a model, it could be more and could be less. Usually these are the 5 generic steps that are used. The first thing is we import the library. So if you're using sklearn, NumPy, Pandas, you import it. Many people import it throughout their code. So as soon as they need something, only then they'll import it. I like to import everything at the top of my file so that everyone who's using my application knows, or looking at the code that I've written, knows what are the libraries that my code depends on. So you can firstly import all the libraries needed to train and build the model that you need. And these libraries can perform tasks ranging from numerical manipulations, such as NumPy, and testing the accuracy that we'll be using scikit-learn for. All right. And then what we do is we import the data set. So data set is the data that we will be training our model on. It's important to understand what data set we'll be using and how we'll be using it. So that's how we firstly need to import the data set, or we can, after importing the data set, we view the data set, we load it, we manipulate it so that it's clean and it's in a state that we can use it to train our model and do the following steps. And after that, we can use it in machine learning models. After that, what we do is split the data. So when we get the data set, its X and Y variables are right with each other. So the thing that we are using to make the prediction and the prediction itself are right inside the data. First, we split that. And then we split our data into a training and testing set. Training set is used to train the model, testing set is used to test the model, and using that we understand what is how the model has learned and what is the accuracy that it's giving us. Then comes training the model, which is the task of the scikit-learn library. It creates an algorithm and allows us to feed it data so that it can learn from the data. And after learning from the data, it can do the classification or regression tasks that are needed. Finally, we test the model. We give it the data that we had set aside for testing. After giving it the data, we ask it to make the classifications, and depending on how many were correctly classified, we give it a percentage from 0 to 100. Higher percentage means our model is more accurate, lower percentages mean it's less accurate.
Just a quick info, guys. Intellipaat provides online data science master program in partnership with IBM. The course link of which is given in the description below. Now, let's continue the session.
What is the max percentage of a model accuracy? The max percentage is 100%, but no model can be expected to have 100% accuracy. If your model, when training or testing, it gives 100% accuracy, it could be that your training set is too small. That is, it either contains only 10, 20, 40, or 100 values, or it could be that your training set is overfitted, which is the variance issue that we have talked about recently. So you need to train your model again, and if it sees some data that it hasn't already seen, it will give poor results. Someone has asked some more detail on splitting the data set and why and how. So splitting the data set is basically the task when we get the data and we want to set aside some data that our model can be trained on, and the remaining data is used to test whether or not our model is giving us correct accuracy. So as in supervised learning, we already have the data and the output that it should map to. Once we feed in the data and we take a look at the predicted output and the correct output, the percentage of outputs that match are the ones that are correctly classified, and the ones that are correctly classified are the outputs that lead to higher percentage of accuracy. So someone has asked to explain some example on training the model. Training the model basically means just taking the algorithm from the scikit-learn library, feeding in the data, which is the x and y variables that we have splitted for training. Then that data, that algorithm learns from the data, and after that we can make predictions using it. We'll take a look at that in the demo. All right, hopefully you can see the question.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Question, yeah. So the question is, which set is used to validate the performance of the trained model? So once the model has been trained, which set is used to check whether or not our model's accuracy is good? So I'll wait for a few moments and you guys can answer in the poll and submit your answers. Whether it's training set or testing set. Training set is the first option, testing set is the second option. All right, in the meantime, people have asked a few questions. I'd like to answer those. Someone has asked, what is the ratio to split the training and testing set? So for training and testing, you can split the data into, depending on how large your data set is. If it's really large, like you have millions or billions of rows, then you can just take 1% or 10% of your data. If it's a small data set, then 70-30 is a good ratio to split your data on. It's testing set, which is the correct answer. The training set is used to train the model. The testing set is used to figure out whether or not the answer is whether or not the model is performing well, which is why we use it. And let's have our hands-on. We'll have a demo here. So I already have prepared a Jupyter notebook for you guys in which we perform all the 5 steps. So let me just first explain what we're doing. We're using the iris dataset that contains information about flowers. It contains information about the sepal length of a flower, sepal width of the flower, petal length of the flower, and petal width of the flower. Using these 4 features, we're trying to predict the kind of flower that it contains, or kind of the iris flower that it's containing. There are 4 kinds of flowers that our dataset has. 3 kinds of flowers that it has: Virginica, Setosa, and these are the different kinds. So what you do is, firstly, we import all the libraries. As you can see, the libraries were easily imported, so it works fine. And from sklearn, I'm importing the load iris function that will get us the dataset. It's a very common dataset, and so that you can follow along with me and you don't have to wait to load the data from some remote data source, you can just use this code that I'm showing you on my screen right now. And then we are using the train test split function, which we'll use to split our data set into the specified ratio. Someone has asked, can we try it on Google Colab? Yes, you can try it on Google Colab. That's a very good use case for Google Colab actually. So if you want to use Google Colabs, or if you want to use your local notebooks, you can use those as well. Okay. With that, we have train test split, which is the function that is used to split the data. We'll be using the logistic regression model, which we can import from sklearn.linear model. And finally, we will be taking a look at the accuracy score as well. And scikit-learn already gives us a function that does it for us. I'll be more than happy to answer you on the questions that you ask about the code that you're watching. If you want to follow along, you can type in the code in your Jupyter notebooks if you have it. If you don't have Jupyter notebook, then it's going to be difficult for you. You can use Google Colabs. That's a really good option for you to try if you want to follow along. So now let's take a look at it. So someone has asked that they need to import the data set. Should they need to import it with its name? So we are using the load iris function, and using that you can just import it. You don't need to specify any name. If you have a CSV file on your local system, importing that, you would need pandas library and need to know the file and the example. Okay. So now we load the data set. But now let's take a look at what the shape of the data set is. As you can see, it's a dictionary. Dictionary is a key value pair. It's a common Python data structure. It contains a key of data that contains all the data. And it's 5.1, 3.5, 1.4, 0.2. These are individual rows in our data set. Now, we don't know what these values mean. So taking a look at the data, we have targets as well. Targets ranging from 0, 1, and 2. Now let's take a look at the target name. These are the different types of flowers that we'll be predicting. These are the categories that we'll be predicting. Setosa, versicolor, and virginica. So 0 means Setosa, 1 means versicolor, 2 means virginica. The reason why we have encoded them into numbers is because machine learning algorithms only understand numbers. They don't understand words or strings or letters or sentences. So we need to first convert those numbers into letters in classes into numbers, and then we can make the prediction. And now for our columns, we want to be able to understand what are the different columns that we have. And what we get here is we get the sepal length, sepal width, petal length, and petal width. So it's given us the example of what we have. So feature names are: the first column has sepal length, second column has sepal width, third column has petal length, fourth column has petal width, and all of them are in centimeters. So that helps us understand the data. Now it's time to split the data. We'll split it in X and Y. We'll be using these features, and using those, we'll be predicting these targets 0, 1, or 2, which map to Setosa, versicolor, or virginica. So with that, after splitting the data, I try to split it into 70-30 ratio. So let me just explain what that means. Using the data set that we have, the data.data, the data key inside it contains all the data that we need. So let me just show you what the size of the data is. If I insert a row below and look at the length of X, we have 150 rows there. Now, if I split it into a 70-30 ratio, right? And now if I insert a row and I print the length of X train, we have 105. So 70% of 150 is 105, and remaining 45 are for testing. So we will use 70% of our data for training, 30% for testing. And with that, we create a logistic regression model. This is a class in sklearn. It just takes in the logistic regression model and creates an object of it. We use the fit method to fit our data. Fit basically means train our data. We pass in the training X variable and training Y variable. So the 105 rows that we have created for testing, we pass it inside our training and testing set. If you're following along, if you want me to scroll up to help you look at the code, this is what the first things we import is. Then we load the data set. You only need to write this code. This is just for explanation. This is markdown format, so you don't need to copy that. After we have trained our data, since our data set is small, it trains in a few milliseconds. Now we make the predictions. And after the predictions are made, we take a look at the accuracy. And accuracy is 88%, which is quite good. Because machine learning models use statistics, these accuracies could change. So if I train it again and then I check it again, it's giving me 100% accuracy because our data set is too small. And now it's giving me 91% accuracy. So it's giving us high accuracy, but the accuracy is variable. The reason why is because depending on how data is split. When we split the data using train test split, it splits it randomly. So it takes a look at 45 values randomly and splits it into another 45 and 105 random values from the entire data set, and then we can train the model. So someone has asked, is face recognition classification or face recognition is a supervised learning problem. It's a classification problem, but it takes a look at very different technologies that are not just part of classification. It takes a look at computer vision, handling the data. There are many other different kinds of things. Face detection is a classification algorithm. Face recognition is a system that uses classification algorithms along with other algorithms as well. Is computer vision in area of ML? Yes, it is.
So what is NumPy? Well, a NumPy is a most widely used Python library for linear algebra. It is used for performing mathematical and logical operations on multi-dimensional array. NumPy consists of various set of functions that can be used while performing your mathematical and logical operations. So this was about what exactly it is. Now the question arises, how to create a NumPy array? Well, we have shown some basic example up here, how to create a NumPy array. So we have created 1D array up here and 2D array. Let me show you this example in my Jupyter notebook. This would make things more easier for you to understand. So this is my Jupyter notebook. So the very first thing that I'll do up here is define my one-dimensional array. So how to define a 1D array? So for that, the very first thing that I have to do is import my NumPy library. So I'll be importing NumPy as NP. Why I'm using NP up here? So it's just because whenever I want to call some function of NumPy, I don't want to use NumPy every time. So apart from it, what I can do, I can just replace the word NumPy by NP. So once you have imported NumPy as NP, let's define an array as a equal np dot array. So here instead of writing numpy dot array, I can just go ahead and write np dot array. That's it. Okay. And inside the array we'll pass list of arrays. Okay, like 1, 2, 3. Okay, and print a. So this is how my 1D array looks like. Now let me show you how you can create a 2D array. So let's create a two-dimensional array. Again, let's import numpy as np. Let's define an array as v equal np dot array. Inside array, what do we pass? List of function, right? So let's pass 1, 2, 3, comma 4, 5, 6 and print b. I'm telling you this will generate an error. Just think why. It gave you an error of data type not understood, right? So why do you think you are getting up this error? Any guesses, anyone? Think. Remember what I said up here. What do you pass an array? List of array, right? So where is array up here? It's a list, but we have to pass a list of array, right? So you'll enclose everything in opening and closing square brackets. So this would resolve your error. Okay, so this is how you got the final output as 1, 2, 3, 4, 5, 6. So this is how you create your two-dimensional array using NumPy. Okay, how to initialize a NumPy array. Okay, so let's start. Well, there are several methods of initializing a NumPy array. Let's discuss them one by one. So first we have is initialize an array of x cross y dimension with all the values as 0. So let's check back in the Jupyter notebook. So what we need to do is initialize all the elements of x cross y array to 0. Okay, let's see how to do it. So here let's import the numpy as np. Now here I'll be using a function zeros. Well, this function is predefined in NumPy. Well, this is used to initialize all the elements of an array to 0. Okay, so np.zeros. Inside this, it takes a list of list. So inside this, what I'll pass up here is the size of my array. Let's take the size of the array as 3 cross 4. Okay, that's it. You don't need to do anything else. Mention the size as 3 cross 4. Let's execute it. So here you got the output as 3 cross 4 matrix, 3 cross 4 matrix with all the elements initialized to 0. Okay. Now let's move ahead and see our next example. Our next example says up here is arranging the numbers between x and y with an interval of z. So let's see how. So here what we have to do, arrange the numbers between x and y with an interval of z. Okay, so let's see how we're gonna do it. Again, import numpy as np, and the function we'll be using up here is arrange, ARANGE. Okay, inside that we'll pass 3 parameters. First the starting point, next the ending point, and next the interval. Suppose I want the interval of 2, so I'll write 2 up here. Okay, so here arrange the number between x and y with the interval of z. So here x is 1, y is 10, and z is 2. Fine, so let's execute it. So you got the output as 13579. So what is the output? So the output is all the numbers between 1 to 10 with an interval of 2. Okay, now let's just change these number and see what difference does it make. We want to print all the even numbers between 10 and 20. So let's see how we can do it. So here we are printing even numbers between 10 and 20. Okay, just to tell you, you don't need to import numpy every time you are doing it. Okay, I'll just show up here. If you're not importing numpy, it won't throw an error because Python is executing every statement line by line, right? So here numpy is already executed, so I can use np up here. I'll just write np arrange. Inside this, it should start from 10, right? And it should go till 20, and the difference should be 2 as we are considering the even numbers, right? So if you see the output, you'll get all the numbers between 10 and 20, but the number 20 would not be included up here. So it's like 10 till less than 20. Okay, so you got the output as 10, 12, 14, 16 and 18. Okay, fine. Now let's get back to our PPT. So next we have is arranging z number between x and y. So now our x and y values are fixed, but what we have to do up here is arrange z numbers in between them. Okay, so here what we are gonna do, arrange z numbers between x and y. Okay, let's see how to do it. So for arranging z numbers up here, we have a function as line space. So you can call np.linespace. It's not line, okay, it's lin. Don't make this mistake. Fine. And after that, what you'll do, you'll specify the first number and the ending number, that is the value of x and y, and how many numbers you want between them. Suppose I want 10 numbers between 5 and 10. So let's see what is the output. So I got the output as array of 10 numbers between 5 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. Let's take one more example of line space up here. Now again, let's print some even numbers like even numbers between 0 to 10. Okay, so here I can write np dot line space. Inside this, the number should start from 0, it should go till 10, and how many numbers I want in between? It's 0, 2, 4, 6, 8 and 10, right? So how many numbers? 6. Okay, so let's execute it. So we got the output up here as 0, 2, 4, 6, 8 and 10. Clear? So this was about the line space function and how you can arrange z numbers between two fixed values of x and y. Okay, let's get back to our PPT. So we have already discussed these examples. Let's move ahead. Next example we have up here is filling same number in an array of dimension x cross y. So it's like I want an array in which all the elements are initialized with the same number. Let's see how we can do it. So what I want to do, filling same number in an array of dimension x cross y. Let's see. So again, I won't be importing numpy up here. I'll just write np dot. So for filling the same number, we have a predefined function as full. It takes two parameters. First, the dimension of the array, and next, the element you want to fill in. So suppose my dimension of the array is 2 cross 3. Okay, and what value I want to fill in? Let's say I want to fill all the values with 6. So let's execute it. As you can see, we got the output as 2 cross 3 array with all the values initialized to 6. Okay, let's move ahead. Next we have is filling random numbers in an array of dimension x cross y. So now what if I want to initialize my array with some random numbers? So how can I do that? Well, for that you have a random function in numpy. Let's see how you can do it. Here we are filling some random number array of dimension x cross y. Okay, so let's see how we can do it. Okay, no point of importing numpy. So the numpy function I'll be using up here is random. I'll just write np dot random, again dot random values in an array of dimension, suppose 2 cross 3. So it will create me a 2 cross 3 array with all the random values in it. Let's see the output. So as you can see, we have a 2 cross 3 dimensional array with all the different random values. Correct? Let's move ahead. So this was all about how you can initialize a numpy array. Okay, numpy array inspection, and we'll see how we can inspect various aspects of a numpy array. Okay, so let's start it. So the very first thing we got up here is ndarray.shape. Well, this shape function is used to return a tuple consisting of array dimension. It can also be used to resize the array. Let's check the shape of our array. So what we have to do up here is inspecting the array. So in this, basically what we are doing is checking the size of the array. So let's define our array up here, like a equal np dot array. Let's define our array as 2, 3, 4, comma 4, 4, 6. Is it correct? Or am I missing something? Remember these square brackets at the beginning, right? So you have to add these square brackets if you want to avoid the errors, because you have to pass a array up here. Now I have defined my array. So now what I want to do, I want to check the size of my array. So I'll just write print a dot shape. Execute it. So you got the output up here as 2, 3. So it means it's an array of dimension 2 cross 3. Okay, so what if I just change my array? Okay, so let's just define an array like s equal np dot array. Let's define an array of different dimension like 1, 2, 3, 4. Another 2, 3, 4, 6. Let's define one more 6, 7, 8 and 9. So what do you think would be the dimension of this array? Guess the output. Any answer, anyone? We have 3 parameters up here. let's just compare these two values. So here we had two set of arrays, right? And 3 elements in each array. So while printing the shape, we got the output as 2, 3, right? 2, 1, 2, 3. So what do you think here the output will be? Well, here we have 1, 2, 3, 4. 4 elements in each array. And how many arrays we have? 1, 2, 3. So what do you think the output will be? 3, 4, right? So we'll get the output as 3, 4. Just add these square bracket in the end, okay? Execute it. At a dot shape, we have to print s dot shape, right? So you got the output as 3, 4, correct? Now, what if I want to resize my array? So what you're going to do up here is resize the array, right? Okay, let's see how can we do that. For that, let's just copy this array up here, okay? Well, even if you don't specify it, that won't be an issue, but don't worry, I'll discuss it later. So for now, let's define the same array. And as we know, the shape of this array was this 2 cross 3, right? Now, what if I want the shape to be changed as 3 cross 2? So what I'll do up here is I'll just write a dot shape and I want to change it to 3 cross 2. Okay. Now let's just print the value of a. Let's execute it. Okay. So we got the value as 234446. 234446. Okay. So it just resized the array and changed the dimension. Okay. Let's see one more example. Let's change the dimension, like 4 here. Let's write 2446. Okay. Now how many elements do we have? 1 2 3 4 5 6 7 8 elements we have. So now I want an array of dimension 8 cross 1. So since 8 elements are only there, so 8 cross 1. So now I'll get the output as 2 3 4 4 2 4 4 6. Okay. But yeah, you cannot just write random numbers up here. It's like if you'll write 8 2, you might get an error in this case as no elements are there. So you got an error of cannot reshape array of size 8 into shape of 8 2. Since the number of elements that you have is just 8, so maximum what you can have is 8 cross 1. Okay. So similarly, you can also get for 4 cross 2. It will be correct. Okay. So the trick up here is, let me tell you the trick. Hashtag trick. The multiplication of these two numbers must be equal to the total number of elements. Okay. So x multiplied by y should be equal to total number of elements in the array. Okay. So 4 cross 2, 2 cross 4, or what else? That's it, right? The factors of 8 are 2, 4, 8, 1. We tried with all. Okay. Let's just change it to 8, 1. So that's the output. Got it? So this is how we are resizing our array. Fine. Next, what if I want to check the dimension of my array? How will I do that? So just now I checked the shape of my array. Now what if I want to print the dimension of my array? So how will I do that? So for that we have a ndim function. Alright. Let's see how we are going to do it. So what task we have is return the dimension of the array. Okay. Let's see how we'll proceed. So let's define an array as a equal np dot a range 24. So here what it did, it created me an array from 0 to 23. Okay. So now what I want to do, I want to check the dimension of this particular array. I'll just write print a dot ndim. So ndim is the function which will return me the dimension of this particular array. So what do you think the dimension of this array is? Any guess? It's 1, right? So the dimension of this particular array was 1. Now since that we have defined a single dimensional array, let's just reshape it. So here we are reshaping our array. So for reshaping, let's define another variable as b equal a dot reshape in the dimension of 2, 4 and 3. So here as a part of dimension, you can use any number whose product is 24. So for that, one trick is there. Like what you can do is first calculate the factors of 24. What are those? 1, 2, 3, 4, 6, 12 and 24 itself, right? So here what all value it can take? So here you can select only number from 1, 2, 3, 4, 6, 12 and 24. So it's like if you are selecting 1, then another would be 1. If 2, then 2 cross 3 it's 6, 6 cross 4 it's 24, right? So here we took as 2, 4, 3, or you can even take 2, 3, 4, anything. If you are taking 6, then 6 multiplied by 2 is 12 and again multiplied by 2 is 24. So you can even reshape this array to a dimension of 6 cross 2 cross 2. Okay, let me just print the dimension of B and show you the output. So what is the dimension of B array? Let's see. Ndim, execute it. So here we got the output as 3. This is from the previous thing only, just remove it. So here the dimension of B is 3, 3-dimensional array, right? If you change it to like what? Let's change it to 12, comma 2. This will work, right? And the dimension of this array would be 2, right? It's a 2-dimensional array. Okay, got it? So basically in reshape up here, what we are specifying is the value of x, y and z coordinate. Okay, since we are not specifying any z coordinate, so it's a 2-dimensional variable and the value of x is 12 and the value of y is 2. So we need a 12 cross 2 matrix up here. Let's even print B. Let's see what we get. So you'll get the output something like this. So 12 in a column and 2 in a row. Okay, so now you know how to find out the dimension of any array and how you can reshape any array to your need, right? Let's move ahead. Now, what if I just want to return the number of elements in an array? How will I do that? So find the number of elements in an array. Let's see. We have already defined an array A up here, right? Here's array. Here's array. A equal np dot a range 24. So our array A consists of 24 numbers that we already know, right? Now, how do we find the number of elements in an array? So up here we have already defined an array as A equal np dot a range 24. Okay, so here we already know that number of elements in our array is 24 since we are only defining it, right? So what if you get a scenario in which you don't know how many elements are present in the array? So for that we'll be using size function up here, right? Let me just verify how size function work. So currently you know how many elements are there in A, right? It's 24, you have only defined it. So in order to find out the number of elements in an array, all you need to do is use a function size. So name of the array A dot size. That's it. Execute it. So we got the output as 24 and it's verified. So even you have initialized the array with 24 elements, right? And this function has verified this. What if I just change it? Let me just show you. Let's change it to 25. Let's remove this.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, let's print our size. Well, the output up here would be, any guess? 25 obviously, right? Okay, so this is how you count the number of elements in your array. Let me just take one more example. Let's define an array as A equal 1, 2, 3, 4, okay, comma 3, 4, 5, 6, comma 2, 3, 7, 9. Okay, so this is my new array. Let's name it as D. Okay, Now let's print the size of D. How many elements are present in D? D dot size. So let's see what's the output. So we have to define a tuple up here. Okay, tuple object has no attribute size. Let's take one more example up here. So here let's define our array as D equal np dot array. Inside this, let's define few arrays like 1, 2, 3, 4, 5, 6 and 6, 7, 8. Okay, now let's just print d dot size. So this will return the number of elements present in D, and the output is 9, 3, 3, 3. Okay, well, what if I just add one more element up here like 8, 9? So what should be the output? So once we added 9 up here, we got the output as 3. Well, I know we'll be getting the output as 10, right? So here we don't have an equal number of elements in the array, right? So in this case, if you print d dot size, what it will return? It will just, so in this case, if you print d dot size, what it will return? So it will just return how many number of rows are there in your array. Okay, so how the size is working, it's multiplying the number of rows to the column. Okay, so if I remove 9 from here, so what we have is 3 cross 3, 3 rows and 3 columns, right? So 3 cross 3 is 9. So that's how it's calculating the value 9 up here. If you change the value of 4 here, again 4, and again add some value as, let's say, 9. Okay, so in this case, what value you will get is 4 cross 3. 4 cross 3 is 12. So total number of elements in that array is 12. Okay, so this is how you count the number of elements in an array. Fine. Now let's just get back to our PPT and see what's left. We discussed this. Yeah, we already discussed how you can change the dimension of an array or resize it. Then another example, this also we discussed. Next, counting the number of elements in an array. We just did it. I'm assuming all these things are clear to you, right? In case you have any doubt, feel free to reach out to us and we'll make sure that the doubt is clear to you within 24 hours. Okay. So next we have is we want to find the data type of the array. So let's see how to do it. So here we have is find the data type of the array, right? So let's take an example up here. So let's define our array as a equal np dot arrange 24 numbers, and each of data type, for that I'll write d type. So what's the data type? Let's say all are of float. Okay, let's check print a dot d type. So it's a float, right? Now what if I just remove it? What if I just write np.arange 24 and print the data type for that? So here we'll get int 32 values. So in this case, if you print the values of a, you are getting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on, right? And just if you change the data type using d type equal float, so all you'll be getting is 0 point something, 1 point something. So you got a float value up here. Okay. And even the data type which we are printing up here changed from int 32 to float 64. Correct? Okay. So this was all about NumPy array inspection, NumPy array mathematics. We'll see what are the various mathematical functions that we can perform using NumPy. Okay. So let's see. So first we have is addition using NumPy. So for performing some addition, we have a sum function up here. Let's see how does it work. NumPy array mathematics, and in this we are learning about addition. Okay, import NumPy as np. You can write any name apart from np. If you write na, that is also fine. We are just following the convention and writing np up here. Okay, so now what if I want to find the sum of two numbers? So what I'll do, I'll call this sum function. So I can call np dot sum. np.sum, inside that sum of two numbers. What are those two numbers? 10 and 20. It will just give me the result as 30. As simple as that. You can even use a variable, like using a variable. So let's define a comma b equal 10 comma 20 and np.sum. I want a sum of a plus b using a variable, that is sum of a plus b. Okay, so np.sum a comma b. Execute it. What error did we got? Access 20 out of bounds for array of dimension 0. So always remember, whenever you are writing some parameter inside the sum, make sure that you are placing them inside the square brackets. Okay, as the sum function only takes the array of values. Okay, so now if I execute it, the error would be resolved. Okay, so we got the value as 30. Now what if I want to find the sum of a particular axis? Like I have a 2 cross 2 matrix, and inside that I want to find the sum of just my first axis or just my first column. So let's see how we can do it. So here let's define np.sum. Inside that let's pass some array like 1 comma 2 and another array like 5 comma 6. Okay, so now what if I want to print the sum of 5 plus 1 and 6 plus 2? So in that case I'll just mention like axis equal 0. Okay, so you'll get the output as 6 comma 8. 5 plus 1 6 and 6 plus 2 8. Now what if I want to print the value of 1 plus 2 and 5 plus 6? So in that case np.sum array of 1 comma 2, same number, nothing need to be changed, just the axis value would change. Okay, 5 comma 6. Now specify the axis value as 1. This is the only change that you have to do. So here you'll get the output as 3 and 6 plus 5 11. So you got the output as 3 comma 11, correct? Now what if I don't specify the axis up here? So what values do you think I'll get? What if I remove this? Let's see. So I got the value as 14. How? So it summed up 1 plus 2 plus 5 plus 6. So it gave me the entire sum of all the elements of the array. That is 1 plus 2 plus 5 plus 6. That is 14. Okay. Similarly, like sum, we have other important function up here like subtract, divide, multiply, exponent, square root, sine function, cos function, log function, and many more. Let's see some of them. Now let's copy up this title, numpy array addition. Here what we are performing, let's change it to subtraction. Now to perform subtraction, we have a method as, so we have to call the function subtract. Let's see an example like np.subtract. What do you want to subtract? Like any value of like 10 comma 20. So we'll get the output as minus 10. 10 minus 20. So you got the value as minus 10. Okay. Similarly, what if I want to find the multiplication of two numbers? I'll just write np.multiply 2 comma 3. Let's take two number multiplication of two number. So we'll get the output as 6. Let me just add one more heading up here. All other numpy mathematics function. So inside this we saw for multiply. Now let's check out for division. So for dividing two numbers we have function as divide. So np.divide. Divide what? Let's divide 10 by 5. Here we are dividing two numbers. Okay, let's execute it. So we got the result as 2.0. Okay, so here all the operation that we perform with sum can also be performed with subtract, multiply, divide, or anything. Okay, it's like here we use a variable. So here we are summing up two array with axis 0. Here we are summing up axis 1. So all those function can even be done with np.subtract, np.multiply, or np.divide. Let me just show you with one example. Let's just copy it and let's paste it up here. So instead of sum, let's change it to divide and execute it. Invalid number of arguments. Now let me just show you how you can divide two arrays. So let's define two array up here like a equal np.array. It consists of 2, 4 and 6. Okay, and other array b equal np dot array. Inside this I'll pass 1, 2, 3. Now let's divide array A with array B. So np dot divide array A with array B. Let's see what result do we get. So we got the divided result of two different arrays. Fine. Similar operation we can perform with multiplication. So you got the value as 2, 8 and 6 3s are 80. Okay. So we also have other function as exponent, square root, sine, cos and log. So let's see them one by one. So all you have to do is change the function. So we have exponent function for calculating the exponents. So we have exp function for calculating the exponents, sqrt function for calculating the square root, sine function for finding out the sine value of an array, similarly cost function for finding out the cost value of the array, and similarly log function to find out the log value of the array. Let's see them one by one. Again, so there's our array, we have already defined it.
Just a quick info, guys. Intellipaat provides online data science master program in partnership with IBM. The course link of which is given in the description below. Now, let's continue the session.
So let's use all these functions one by one. Print np dot exponent of a. Okay, execute it. So this is the exponent of a, that is e to the power a. Okay, e to the power 2 is 7.38, e to the power 4 is 54.5, e to the power 6 is 403.42. Okay, let's just copy this function and let's find the square root of all the elements of a. So sqrt. So this is our square root. Let's add one more thing. This will make things more clear. Square root, and here it was exponent. Fine, copy this. Now we'll calculate the sine. Sine is np dot sine value of a. Again we have to check for cos. So cos is np dot cos, and finally log. So we have log as np dot log. Okay, execute it. So we got all the values of here. Exponent is this, square root is this, sine of 246 is this, cos of 246, log of 246. Okay, so these are some of the mathematical function that you can perform using NumPy. So let's move ahead. Let's go back to our PPT. So we already discussed this part, and we also learned about all these different types of other function that you can perform, and we also discussed about the error that you might get. So let's move ahead. So next we have is the array comparison. So in this we have element wise comparison and array wise comparison. Let's see them one by one. So here we have is array comparison. Okay, so let's define 2 or 3 arrays. Okay, so a equal like 1, 2, 4. Let's define b equal to 4, 6, and let's define one more, c equal again 1, 2 and 4, same as a. Okay, so now let's use NumPy to perform a element wise comparison of these arrays. So for this I'll write np dot equal, let's write a comma b. So it will compare 1 with 2, 2 with 4 and 4 with 6. So if these two elements are equal, it will return true. In other case, false. So for now, what output do you think we'll get? Well, for now, all the output would be false, right? As 1 is not equal to 2, 2 is not equal to 4 and 4 is not equal to 6. But what if you change this b to c? So in this case, you'll get all the true values. Just for understanding, just change this 6 to 4. Now let's compare a with b. So in this case we have last as true, so these two are false and one is true, so 2 false and 1 true value. So 2 false and 1 true, correct? So this was about the element wise comparison. Okay, now next we'll see Now next, let's perform a array-wise comparison. Okay, let's just copy them. Okay, now in this, I want to compare the entire array. If all the elements of array A equal to all the elements of array B, then only in that case we'll get the output as true. In all the other case, we'll get the output as false. Let me just show you with this example. So np dot array underscore equal. So this is the function that we are going to use for comparing two arrays. So like this, compare A and B. Even if one of the element is different, we'll get the output as false. So here we got the output as false. See, executed false. So here what we have, A124 and B144. So we had two elements equal in A and B, right? Just 2 and 4 were different, and even then we are getting false. What if I just change the value to C? So in this case, you will get the output as true, correct? So this was about array-wise comparison. So now that we have learned how to compare two arrays, both element-wise and array-wise. So let's move ahead and see what we have next. So we are done with this example. Next we have is the aggregate function. So under this, we'll see how to perform various statistical calculations on the array. Okay, let me show you with an example. Aggregate function. So here, let's again copy paste the value of A, B and C. So in aggregate function, what all things we can do? We can perform an array-wise sum, or we can find the minimum value of an array, or the mean of an array, the median or correlation coefficient of an array, or even the standard deviation of the array. Alright, let's print all of them one by one. So here I want to print my sum. So print np dot sum of array A. So it will give me the sum, right? 4 plus 2 plus 1, that is 9. Wait, just to clarify it, sum is this. Then let's print the minimum value from the array. So our minimum value is np dot min of A. Now let's print the mean value. So mean is np dot mean of A. It's as simple as that, right? Print median is np dot median of A. Then print correlation coefficient is np dot correlation coefficient of A. And finally the standard deviation. Standard deviation is what? It's np dot std of A. Okay, so let's execute it. So we got the value as sum 7, minimum value is 1, 1 to 4, correct? Mean is 2.33, that is 4 plus 2 plus 1, that is 7 by 3, 2.33. Median is 2.0. Correlation coefficient, that is 1, and standard deviation is 1.24. Okay, so this was about the aggregate function. Let's come back. So next we have is NumPy broadcasting. So let's see what exactly is. For example, we have two array with different dimension, right? But make sure the number of rows or number of columns are same. Okay, so in this case what we have is same number of element in each array. Okay, so it's like when you add first array to the second array, what it does, it simply adds it. Like, so here you can see we got as 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 2 is 2. But here again, 10 plus 0 is 10, 10 plus 1 is 11, 10 plus 2 is 12. So similarly, what it did, it broadcasted this value and add all these values to different rows of this array. Okay, so same values being added to this row, this row, this row, and this row. Okay, so this is the concept of broadcasting, as this particular array is broadcasted and summed with all the element of this particular array. Let me just show you with an example. This is concept of broadcasting. Okay, let's import NumPy as np. Let's define an array as np dot array. Inside that, let's place few values 0, 0, 0, then 1, 2, 3, then 4, 5, 6. Let's take one more. Let's take it as 5, 6, 7. Okay, now let's define another array b equal np dot array. So in this, let's specify a number like 0, 1 and 2. So this is the number which will be added to 0, 0, 0, 1, 2, 3, 4, 5, 6 and 5, 6, 7. And this is the concept of broadcasting. Okay, let me just show you. Print first array. First array is what? A, right? Change the line. Then print the value of second array. And then print the value of first array plus second array. That is A plus B. Okay, execute it. So here we got the output as first array is this, second array is this, and first array plus second array, you can see that 0, 1, 2 is added to all these numbers. Fine. So this was the concept of broadcasting. Array manipulation in Python. So as a part of array manipulation, so we have concatenating two arrays together, stack array row wise vertically, stack array column wise horizontally, and combining column wise stacked array. Let's take an example in Jupyter Notebook and learn them one by one. So here we want to start about array manipulation Python. Okay, so first of all, let's define two arrays. Let's take a equal np dot array. Inside this, let's say 1, 2, 3. Okay, so this is my array A, and b equal np dot array 4, 5 and 6. Okay, so first of all, we'll see how we can concatenate these two arrays. So first is concatenation of two arrays. So for this, we have a function concatenate under numpy. So we'll just call it np dot concatenate. We'll just write A and B. That's it. So here you got the output as 1, 2, 3, 4, 5, 6 in all the element in a single array. So therefore what it did, it concatenated both the array A and B into one. Okay, so next we have is stack array row wise, that is vertically. So stack array row wise vertically. Okay, so again for this we have another function in numpy as vstack. So just take two parameters, the name of two arrays A and B, execute it. So as you can see, my two arrays are stacked one above other vertically. Here one more thing I have to say, like if you want to stack array row wise but in a horizontal fashion, so it's again same as your concatenate function, but here we have another function as hstack, and even this takes two parameter A and B, and it's quite similar to the concatenate function. It will give you the same result. Okay, so this was about hstack. So till now we discussed about concatenating or stacking row wise, right? Now what if I have to combine column wise? So let's see here, combining column wise. So for this I have a numpy function column underscore stack. So let's call it np dot column underscore stack. Inside this, let's pass our arrays A and B, executed. So here you can see that my array A and B are stacked in a columnar fashion. Okay, so this was about combining column wise stacked array. Okay, so let's get back to our PPT and see what is the next topic. So next topic in array manipulation in Python we have is splitting array. That is, what if we want to perform some horizontal split or vertical split in the array? Let's see how to do it. So for this, let's define an array. Let's take x equal np dot arrange 16 numbers and reshape this 1D array in the dimension of 4 cross 4. Okay, let's print x and see our array. So this is our 4 cross 4 array consisting of numbers between 0 to 16. Now what if I want to split my array horizontally from here, this point, such that my first array contains 0, 1, 4, 5, 8, 9, 12, 13 and my next array contains 2, 3, 6, 7, 10, 11 and 14, 15. Let's see how to do it. Well, for this we have another function as hsplit. Let me just show you. Print np dot hsplit. Inside this you have to pass your array and define from which position you want to split. I want to split it from second, like there's my 0th index, first index, my second index. Okay, so I want to perform a split from this point. Okay, so let's see the output. Let me make things more clear for you. Let's add a new line up here, horizontal split. After performing the split, so here you can see that I have two arrays. First array is this, consisting of 0, 1, 4, 5, 8, 9 and 12, 13, and my next splitted array consists of the rest half, that is 2, 3, 6, 7, 10, 11 and 14, 15. Okay, I can even perform some customized split over here. Let me show you some example, like print np.hsplit start from x and until np.array 3, 6. So let's see what's the output. But before this, let's add some new line. Let's check the output. So here we got two arrays, right? First one is this 0, 1, 2, 4, 5, 6, 7, 8, 9, 12, 13, 14, and the next one is the last column. Okay, so here let's split it from this point such that 0, 1, 2, 4, 5, 6, 8, 9, 10, all are these in. So all of them are in one array and rest of them, that is 3, 7, 11, 15 is in different array. Okay, so let's do it. np dot horizontal split and just write x comma np dot array.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So here you will get the output as this. Okay. Now from this example, what if I want these two columns together and this entire column has a separate array? So I want three arrays in total. So I just have to make a little change in it. Just write 2, 3. That's it. So it's like np.hsplit x, np.array second and third column. So here I got the output as this. This is my first array, this is my second array, and this is my third array. Okay, so guys, this was all about splitting arrays and array manipulation in Python, indexing and slicing in Python, and we'll see how to select certain elements from the array. So let's start with what exactly is indexing and slicing. Well, indexing just refers to a position. For example, if you are storing some numbers or a string in an array, so each cell of an array has some index number associated to it. For example, the image shown on your screen represents an array in which each cell has a different character. So we have Monty Python stored in an array. So here index number of m is 0, 1 and so on till n is 11. So this is the index number when you are going from top to down. Okay, and suppose if you directly want to extract the last character from the string and you don't know what is the length of the string, so in that case you can use the negative index number. It starts from -1 at the end and goes till -12 at the beginning. Let me just show you an example and make things more clear to you. So this is our Jupyter notebook. So let's define an array a equal Monty Python. So each character is stored in a different cell. Okay, so now what if I want to extract Monty from here? So how will I do that? A of Monty, that m starts from cell number 0 and it will end till MONTY 0, 1, 2, 3, 4 and 5. So before the colon we write the part which is included, so m is included. So after the colon, that is cell with index number 5 is not included, so just before 5. So it's like 0 to 4. Let's see the output. So here we got the output as MONTY. Now what if I want to extract, let's say, these characters? Start from 0, 1, 2, right? Start from 2, ends at 3, 4, 5, 6, 7, 8 and 9. So I'll just write 0, 2. Start from 2 and end before 9. So this was my requirement and I got the output as NTYPYT. So this was a very basic example of indexing and slicing in Python. Let's move ahead to learn more about it. So let's learn how to slice a 3 cross 3 dimensional array with the numbers 1, 2, 3, 4, 5, 6, 7, 8 and 9 stored in them. Okay, so let's learn how to extract or slice the array. So what if I want to extract the selected element? So here my selection is in first row, right? That is 0th index. So I can directly extract with a of 0. So if I write a of 0, this includes all the element from the first row. That is 1, 2, 3. But when I write colon 1, it means you don't have to include 1. That is whatever part comes after colon, we have to exclude that part. That is, we have to take number just before that. That is, if colon 1 is there, so we'll take till 0. And this will extract the first row from the array. The first one, it extracts all the elements from the first row. And next one, it extracts the first row from the entire array. Next, what if I want to select these elements? So here my selection is in the first row, right? That is 0th index. So if I write a of colon 1, now how to extract this selected element? Well, in this, I know that my selection lies in the first row, right? That is 0th index. Now I'll write a colon 1. So what it will do, it will extract the entire first row, or extract till row equals 0. Only this row will be extracted. Next, I don't want to include the part of 0, 0. So I want my selection to start from column 1. Okay, so I'll write 1 colon up here. So after writing 1 colon, what it did, from the 0th row, it then selected the column index starting from 1 till last. And therefore we got a selected value. Let me show you this example in my Jupyter notebook. Let's define an array. Let's say a equal np.array. Inside this, 1, 2, 3, 4, 5, 6 and 7, 8, 9. Okay, so let's extract the first array from here. Let's extract first array. So we saw a of 0. A of 0 gives us all the element from the first row. Next, if I write a of colon 1, so this will extract the first array. Fine. Next, what if I want to extract 2, 3 from here? Okay, first let me just show you the entire array. So this is our array. Now I want to extract 2, 3 from here. So how I'll write a, first select the entire row. So 2, 3 lies in first row, right? So I have to select the entire row. Then it should end at 2, 3. Then my 2, 3 starts from column number 1. So I'll write 1 and 1 till last. Okay, execute it. So you'll get the output as 2, 3. Go back. Now if this is our requirement, so how to extract the selected element? So in this, my selection lies in first 2 rows, right? That is 0 and 1 index. So here, if I write a of colon 2, so this will extract both the row 0 and the row 1, okay? But now I want my column number to start from 1. So I'll just write colon 2 and start from 1 till end. Okay, let me show you this as an example. So there I wanted to extract 2, 3 and 5, 6, right? So let's see how can I do that. So a of 2, 3 and 5, 6. These numbers or the selection lies in first 2 row. So starting from 0 before 2, that is till 1. So select all the rows from 0 to 1. Then in the column part, the column starts from 1, right? 0, 1, 2. So it will start from here, right? So it should start from 1 and it can end till last. So let's execute it. So in this case, we'll get the output as 2, 3 and 5, 6. 2, 3, 5, 6. Clear? Let's move ahead. Again, same example. This one you can work it out on your own. Can you say what's the answer for this? Okay, let me give the solution of this. So a of 1 colon comma. So what does it mean? Start from row number 1. So this is our row number 1 till end. So include everything from here. Okay. So we have a of 1 colon comma. Okay. So what does it mean? So it means extracting starts from row number 1 till end. So this is my row number 1 till end. So this will include all of these values 4, 5, 6, 7, 8, 9. Okay. And it should continue till 1 colon, which means after extracting all the elements from row number 1 till the end, that is row 1 and row 2, when all these elements are included, from these elements I want to start from colon number 1, that is from here till the end. So the output what I'll be getting is 5, 6, 8, 9. Let me just show you. So I want to extract 5, 6, 8, 9, right? So a of here 5, 6, 8, 9. So these lies in first and second row, right? So row it should start from 1 and till last. Okay. and my column 5689, let's start from first column, right? 0 1 2. Even the column should start from first until last. So here I'll be getting the output as 5689. So here are a few more examples that you can try. Now a question might arise in your mind, like what is so special about NumPy arrays? So why can't we use simple Python list for these scientific computation? So let's move ahead and see what are the benefit of using NumPy array over the list. So NumPy array consumes less memory when compared to a list, is also faster and more convenient as compared to a list. Okay, let me just take few examples in my Jupyter notebook and show you how exactly it consumes less memory, how it is faster than a list, and how it is more convenient than it. Okay, so let's just get back to our Jupyter notebook. Advantages of NumPy over a list. So first, let's compare NumPy and list on the base of their memory size. NumPy versus list parameter is memory size. So for this, let's import NumPy as np and again import sys library. Now let's define a list. So let's say there's our list L equal range, range less class 1000 numbers in it. Okay. Let's print the size of it. So print sys dot get size of any integer between 1 to 1000. For example, I can take 1 over here. Size of any integer multiplied by how many total integers are over there? 1000, right? So either you can write 1000 or you can write length of L. Okay. Now I need to compare it with NumPy array. So let's define a NumPy array. So let's say our NumPy array A equals np dot arrange 1000 numbers. Okay, again print a dot size multiplied by, you can directly write 1000 over here or you can use a dot item size. Okay, let's execute it. Let's modify our code a bit. Here size of a list and here size of an array. So we got the output as 28,000 as the size of the list and size of the array is 4,000. Okay, so from here I can say that storing a NumPy array occupies less memory when compared to a list. Okay, so now that we have compared their memory size, now let's compare NumPy and list on the basis of their speed. So NumPy versus list on the base of their speed. For this we have to import another package, import time. We have already imported NumPy as np up there. Now let's create a function. Here I'm defining function as using list. Let's define our starting time t1 equal time dot time. Okay, now let's define a list x as x equal range of 1000 numbers, and let's define another list y as a range of 1000 numbers. Let's make them 10,000. Okay, this way we can check the speed of their processing in a better way. Okay, now let's add all the element of each list. So z equal x of I plus y of I for I ranges in length of x or length of y or maybe 1000. Okay, length of x or y anything, or you can just write 1000 up here. Okay, so this is my z, and from this function what I want, return time dot time minus t1. Now here this t1 was the initial time, right? And now this time would be the process time, that is time after executing this statement, right? So if we subtract this time minus the initial time, we'll get the total time taken to process this particular line. Now let's define another function. So define using NumPy. Same, define the starting time. Wait, let me just add some comments up here. Starting or the initial time. This is also the starting of the initial time. Next, let's define a NumPy array. Now x equal np dot arrange 10,000 numbers. Okay, and b equal np dot 10,000 numbers. Now for the processing part, what I want to do, I want to take the sum of both a and b. Z equal just a plus b. It's as simple as that. And this is how it is more convenient than a list. More convenient than a list. Okay. Now again, what I want from here, return time dot time, that is time after things are processed, that is this particular statement is processed, minus the initial time, that is t1. Okay, now let's call these two function and store their output in two variables. Let's say list time equal using underscore list, and numpy time equal using numpy. Okay, and then finally let's print them. Print list underscore time comma numpy underscore time. And one more thing you can add up here is like in this example, numpy is string value of.
Just a quick info, guys. Intellipaat provides online data science master program in partnership with IBM. The course link of which is given in the description below. Now, let's continue the session.
List time divided by numpy underscore time, that is the time taken to execute the numpy array, this many times faster than a list. Okay, fine, let's execute it. The name using underscore list capital. So for this example, we got the processing time for list is 0.00199, while for numpy we got 0.00099. So in this example, numpy is 1.99 times or almost 2x time faster than a list. Okay, so this is how a numpy is faster than a list, and here I showed you how it is more convenient than a list. So I hope these things are clear to you. Coming back to our PPT, let's see what we have ahead. So we have already done this example, numpy versus list memory size. We also compare on the base of their speed, and here I showed you how it is more convenient than a list.
What is SciPy? Well, SciPy is a free and open source Python library which is used for scientific and technical computing. Okay. It contains module for optimization, linear algebra, integration, interpolation, special functions, Fourier transformation, signal and image processing, and other scientific computations which are most common in science and engineering. This library is built upon NumPy to make the scientific calculation more efficient. But before we actually move ahead, there's few special characteristics of SciPy that you should be familiar with. So let's move ahead and discuss about some of the characteristics of SciPy. So first of all, it contains toolboxes dedicated to common issues in scientific computing. Secondly, SciPy offers different submodules for different applications. Third is, it operates very efficiently on NumPy. We can say NumPy and SciPy works hand in hand. Okay. So fourth is, it adds significant power to the interactive Python session by providing the user with high-level commands and classes for manipulating and visualizing the data. Finally, SciPy routines are tested and optimized. Therefore, SciPy should be used whenever possible. Non-programmer scientists face difficulties while performing scientific calculations in large real-world data. So this issue can be resolved very efficiently with the help of short and simple codes offered by SciPy. So this was about some of the characteristics of SciPy. So till now we know what exactly is a SciPy and what are its various characteristics, right? So let's just move ahead and see what are the various sub-packages or sub-module that this library has to offer, okay? So these are the various sub-packages which are a part of SciPy. So first of all, we have something called scipy.clusters, which comes in handy while dealing with vector quantization or k-means clustering. Second, we have is scipy.stats, which is generally used for statistics. Then comes scipy.optimize, which is used for minimizing or maximizing objective functions. Another very important sub-package is scipy.integrate. This is useful while dealing with different integration routines. Then we have scipy.linalg, which is generally used to perform linear algebra routines. And finally, we have scipy.fftpack, which is used for fast Fourier transform. Okay.
So these are the various sub packages which are available under SciPy. SciPy.cluster. So in this session, we'll see why do we use SciPy.cluster, what exactly is clustering, and how do we find clusters. Okay. So I hope the agenda is clear to you guys. So let's move ahead and see why do we use SciPy.cluster. Well, this subpackage is very useful when we have to divide the dataset into cluster based on some attributes. So in the k-means function, we have to pass the data and the number of clusters that we need to divide them in as the parameter. Now a question might have popped into your head, right? Like what exactly is this clustering? So let's discuss that first. So let's say we have a dataset that looks something like this, and you want to group them into two clusters, the green and the blue cluster. So from here you can say that clustering is the process of grouping similar items into one single group. For example, you can say that we have selected two clusters over here, right? So all the data points in green cluster are completely different from all the data points in the blue cluster. Okay, but all the points within the green cluster are quite similar to each other, and same is the case with the blue cluster. Okay, so summarizing it, you can say that clustering is a process in which the data points are clustered into groups. The data points within one cluster are quite similar to each other, but when you compare it to the data point in different cluster, it's completely different. There is no similarity between them. Okay, so now the question arises how to calculate this, or how can we create this cluster. Okay, so let's see how to create this cluster. So how do we find cluster? So first of all, we randomly pick two different cluster centers. Okay, then as a step 2, what we'll do, we'll assign our data set into two clusters based on minimum distance to the cluster centers. Fine. Then we'll calculate the mean distance of each member in the cluster. Then as a step 4, what we'll do, we'll shift the cluster center towards the mean, and we'll consider that two mean values are the new cluster centers. Okay. Then again we'll repeat step 2 and step 3 until no member changes the group. Okay. So I hope you got an idea of clustering from this. So let us discuss with the help of an example to make it even more clear. So let's say we have a data set in which we have coordinates as x, y, distance k1, distance k2, minimum, and cluster. So these are our attributes over there. Distance k1 is the distance between the point and the centroid of cluster 1, and distance k2 is the distance between the point and the centroid of cluster 2. So let's say we have a data set 1, 1, 2, 2, 4, 4, 5, 5 and 6, 6, and we need to divide them into two different clusters. So first of all, we'll randomly pick two cluster center or centroids. Let's say k1 equal 3, 3 and k2 equal 5.1 and 5.1. Okay. Then what we'll do, we'll calculate the distance from each point to k1 and k2, and based on the minimum distance, we'll assign them the clusters. Okay. So for example, the distance from 1, 1 to k1 is 8, but that to k2 it's 33.62. So clearly here minimum distance is 8. So our first point goes to cluster 1. From the point with coordinate 2, 2, so the distance from k1 is 2, but to k2 is 19.22. So this also belongs to cluster k1. And similarly, we'll find the distance for rest of the point, and based on minimum distance, we'll put them into the different cluster. Okay. So now after assigning the cluster, it looks something like this. So cluster 1 has the point with coordinates 1, 1, 2, 2 and 4, 4. And cluster 2 have the point with coordinates 5, 5 and 6, 6. So our next task would be to find the mean of all the member in a cluster. Okay. So the coordinate of mean of cluster 1 is 2.33, 2.33. And the coordinate of mean of cluster 2 is 5.5 and 5.5. Okay, so now consider the coordinate 2.33, 2.33 and 5.5, 5.5 as new k1 and k2. Okay, again find the distance of each point from k1 and k2. Then based on minimum distance, put them in clusters. Okay, now repeat these steps until no member changes the cluster. So in this example, we had very less number of data, so the whole calculation with repeating steps doesn't look that annoying, right? But what happens if the data set is large, right? That would be too hectic task for you to calculate it manually. So now to reduce this computational complexity, we have SciPy.cluster. Okay, now let me show you how you can use it in Python. So to perform clustering operation, we'd be needing some data. So here I have imported some car dataset using pandas. Okay, so my dataset consists of 11 columns and 32 rows, and all these 32 rows consist of different numerical data. Okay, here in this slide I have just shown first 13 rows of the dataset. So as you can see here, my dataset consists of mpg, cylinder, displacement, horsepower, DRAT, weight, QSEC, VS, AM, gear, carburetor, right? So now we'll be using this dataset to create the cluster. Okay, so import pandas as pd, data equal pd.readExcel, inside that the name of the file. So this is how you can import the data. Okay, so now to perform clustering operation, we first need to import k-means and vq from the scipy.clustering subpackage. Then we'll pass our data and the number of cluster that we need in k-means function. In our case, we need 3 clusters, right? So this k-means function will return the array of 3 centroids. Okay. So after we get the centroids, we'll pass our data and the centroids into the vector quantization function, which returns an array of cluster index values for each record. So let's see the output. So as you can see from the array of cluster index, our dataset is divided into 3 different clusters. It was simple, wasn't it? But there's a common pre-processing step for machine learning algorithm called the data whitening. We need to perform data whitening when we use features that represents different characteristics and are on very different scales. So which we are going to see in our dataset. Okay. So we'll now see if there is any change in the cluster after we perform whitening. Well, again, to perform data whitening, we'll be importing whiten from scipy.cluster.vq. Then after importing the data, we'll pass the dataset into the whiten function. Then repeat the same steps to find the centroids and the array of index. Now comparing to the array of cluster index, you can see that many of them has been changed, right? In this and in this. Okay. So this is why we need to perform data whitening before passing the data into the k-means clustering function. So this was all about scipy.cluster. Okay, scipy.stats. So in this session, you will understand why do we use scipy.stats and how we can use it. Okay, so without delaying any further, let's start with why do we use scipy.stats. Well, scipy.stats consists of all different types of statistical functions in it. Okay, it also contains a large number of probability distribution. To see or to know more about what functions or the package this library has to offer, you can just use info and inside that mention stats, and this will display you the list of all the different functions available under it. Okay, but now let's just move ahead and let me just take an example and show you how does it exactly work. So let's say the nutritionist measured the sugar content in grams for 13 drinks at a coffee shop. So this is how his data looks like. Okay, now the drink had a mean of 21.5 gram and a standard deviation of 8 gram, and the distribution was roughly symmetric. Okay, so for that we are creating a visualization out of it. So first of all, we are importing the numpy library and we are storing all these data in the numpy array. Okay, so copy equal np.array, and then inside that we are passing all these values of sugar. Okay, next what we are doing, we are printing the mean and standard deviation of it. So as you can see, we got a mean of 21.5 and a standard deviation was 8.06. Okay, then what we did, we created a plot out of it. So for creating a plot, I used a matplotlib over here. Okay, and on the x-axis we have range of 30 number, that is 0 till 13, and on the y-axis we have different values of sugar in the coffee. Okay, so this is how our plot looks like. So the distribution in this plot is roughly symmetric. Now let's say a grand mocha cappuccino at the coffee shop contains 14 gram of sugar. So calculate the standardized score or z-score for the grande mocha cappuccino. So how will we do that? So for calculating the z-score, so you have to import stats. So from scipy I'm importing stats, then print stats.z-score coffee. Okay, so here we got the list of different z-scores for different values. Okay, so the z-score of a 14 gram sugar coffee is minus of 0.93, right? So but what does this mean? So any guess, anyone? What do you think it means? This drink has 0.9 gram of sugar less than the mean of the 13 drinks, or it's B, this drink is 0.9 standard deviation below the mean of the 13 drinks, or it's C, that is about 90% of drinks have a lower sugar content than this drink, or it's D, that about 90% of drinks have a higher sugar content than this drink. So what do you think the answer should be? The answer is D. That is, the value of z-score as 0.9 means about 90% of drinks have a higher sugar content than this drink. So this was about how you can use scipy.stats to calculate z-score for your data. Now let's take another example over here. So this data set consists of frequency of people going to gym and frequency of smokers. So in this example, we are trying to find out whether frequency of going to gym is related to frequency of smoking for our data or not. Okay, so how will we do that? So for doing this, we have another function offered by this sub package, that is chi-square. So this chi-square test is used to determine whether the output variable is dependent or independent of the input variable. Also remember that a chi-square test is designed to analyze the categorical data. So we'll be finding out the p-value with the help of the function offered by this sub package. But how to define whether one variable is related to other or not based on its p-value? So there should be one cutoff, right? So by convention, the cutoff point for a p-value is 0.05. So if p-value is less than 0.05, we can say that they are related. But if it's greater than 0.05, they are not related. Okay, so let's go ahead and find out. So we imported the NumPy library, created the data, then we imported the stat from SciPy. Okay, so we passed our data into the chi2 contingency function. So this function gives us the value of chi2, p-value, degree of freedom and expected frequency. But here we need only p-value. So let's just print the p-value for that. Okay, so as you can see, we got a p-value of 0.482, which is greater than 0.05. So based on our records, we can conclude that there is no dependency between frequency of smoking and frequency of going to gym for our observed data. scipy.signal. So in this session, you'll learn about why do we use scipy.signal and how do we use it. Okay. So without delaying any further, let's see why do we use it. Well, the scipy.signal is used for typical signal processing. You can process your one-dimensional or periodic signals in that. Let's say you need to resample a signal with n data points to x data point. So in that case, you'll be using scipy.signal. So what scipy.signal is basically doing, it is resampling the data point using FFT, that is fast Fourier transformation. Okay. So now that you know why do we use scipy.signal, let's move ahead and see how do we use it. So here we are performing the resampling. So the very first library that I have imported up here is matplotlib.pyplot for creating our visualization, numpy for creating our dataset, and finally signal from scipy. So here we are creating a signal with 200 data points, right? So np.linespace -10 to 10 and 200. So here we have 200 data points between -10 to 10. Okay. Next we are defining the sign graph. So y equal np.sign of t. So what it is basically doing up here, it is creating a sign graph with this data point. Okay. Next we are resampling it and we are specifying the number of required sample. So here for resampling we are using signal.resample. Inside that we are passing y, 100 sample. Okay. So number of required sample over here is 100. And then we are plotting t, y, that is these two. So our first sign graph is plotted, and then we are plotting t of :2, which means what? We are printing all the values from the t with a gap of 2. So next what we are printing? On the x-axis we have t :2. What does it mean? It means that we want all the values from the t, that is this, with the equal gap of 2. Fine. Next on the y-axis we have is the x_resample, that is this value, our resample value, and this O represents the dot. Okay, these dots over here, and then finally after doing the plt.show we get this thing. Okay, so this was about how you can use scipy.signal to resample your data. Okay, scipy.optimize. So in this session you will learn about why do we use scipy.optimize and how do we use it. So why do we use scipy.optimize? Well, scipy.optimize provides algorithm for function minimization. Either it can be a scalar or multidimensional. You can also use it for curve fitting or root finding. So let us discuss how can we do that with the help of an example. So here I'm importing matplotlib library and numpy library. I'm using numpy library to create my dataset and matplotlib to plot this particular graph. Okay.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val, B. Raise, C. Try, D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So here I have generated one function f of x where x varies from 0 to 1 evenly with a step size of 0.1. Okay. So this good. So when you plot this function, it looks something like this. Okay. So as you can see, we have a global minimum of this function at this particular point. So now our task is to find the value of x at which we get the minimum. So you must be thinking that you can find the minimum by plotting all the values of x in that function, right? But that increases our computational complexity. So this is where optimization function comes in handy. So you can directly use optimize.minimize and inside you can pass your function over there. Then with the help of result.x, we'll find the x at then with the help of result.x, we can easily find the value of x at which the function is minimum. So as you can see, we got the output as 0.69. So this means that at x equals 0.699, we get a minimum out of our function. SciPy.integrate. Well, this is another very important sub-package in SciPy. So in this session, we'll learn about why do we use SciPy.integrate and how do we use it. Okay, so without delaying any further, let's start with why do we use SciPy.integrate. Well, this library is used to perform integration. I'm sure you guys are familiar with what exactly is integration, right? When analytical integration becomes difficult, numerical integration comes handy. So this subpackage offers number of routines for performing numerical integration. Okay, so here we have something called quad for single integration, DBL quad for double integration, TPL quad for triple integration, and N quad for n-fold multiple integration. Let's see how these things work. Now let's move ahead and let me just show you an example. So if function of x equal x square where y equal f of x, then find the value of integration of a to b y of dx where a equals 0 and b equal 1. So there's my problem statement. So mathematically y equal x to the power n, right? So here the value of n is 2. Okay, so integration of a to b x to the power n dx equals a to the power n plus 1 divided by n plus 1 minus b to the power n plus 1 divided by n plus 1, right? So here n equal 2 and a equals 0 and b equal 1. So once we put all these value to our equation, we get something like this. Integration with the limit of 0 to 1 x square dx equal 1 to the power of 2 plus 1 upon 2 plus 1 minus 0. Okay, which equals to 0.33. Let's take an example. Let's say I have a function f of x equal x square where y equal f of x, then find the value of integration of y dx with the limit of a to b where a equals 0 and b equal 1. So mathematically y equal x to the power n equal x square, right? So if you see the formula, integration with the limit of a to b x to the power n dx equal b to the power n plus 1 upon n plus 1 minus a to the power n plus 1 upon n plus 1. So here if you compare these value, you can say that the value of n equals 2, right? So if you put all these values over here, the value of a, b and n to this equation will get something like this. So integration of 0 to 1 x square dx equal the value of b was 1, right? So 1 to the power of 2 plus 1 upon 2 plus 1, that is 1 by 3 minus value of a is 0 itself, so it will be 0. So 1 by 3 equals to 0.333. Okay, so this we calculated it mathematically. So now let us see how SciPy.integrate function work and make things easy for us. So here the very first thing that I'll do is import the integrate library from the SciPy. Then I'll define a function integrad which returns the value of x square. Okay, then what we'll do, then we'll apply the intg.quad and inside that we'll pass the function integrad and the value of a and b, that is 0 and 1. Okay, so this function returns answer as well as the error value, but we are just concerned with the integrated answer. Okay, so here we got the answer as 0.333. So similarly, for double integration you will be using DBL quad, and for triple integration you will be using TPL quad. Okay, so this was all about the integrate function of the SciPy. SciPy fast Fourier transformation pack. Okay, so in this session you'll learn about why do we use SciPy.fft pack and how do we use it. Okay, so I hope the agenda is clear to you guys. So without delaying any further, let's start our session with why do we use SciPy.fft pack. Okay, well, this subpackage is used to compute fast Fourier transformations. Fast Fourier transform is an efficient implementation of the discrete Fourier transform. Okay, it also provides function as SciPy.fftpack.fft. It is used to compute fast Fourier transform. FFT fric, that is used to generate the sampling frequencies of the digital signal. And finally, IFFT, that is used to compute the inverse Fourier transformation from frequency space to signal space. So now let's move ahead and see what fast Fourier transformation package has to offer. So let's check its behavior in the frequency domain. So in order to work with our fast Fourier transformation subpackage, the very first thing that we are going to do is generate one digital signal which has some noise in it. Okay, so we can easily do that using NumPy library. Okay, so let's see what we have done here. So here the very first thing that I am doing up is importing my NumPy library. I am defining a time step as 0.02 as I need to have equal number of spaces over here, right? You can directly put this value over here. So using np.arrange, what it will do, so your initial point is 0 and ending is 20. So np.arrange will give you all the points between 0 and 20 with an equal interval of 0.02. Okay, and all these values will be stored inside time vector. Okay, so we have also defined a period as 5. Okay, so next thing what we are going to do is define a sine wave. So signal equal np.sine of 2 pi by 5 times of time vector. Okay, and this part is what? This is our noise, that is 0.5 times of np.random.random time underscore vector dot size. Okay, we are adding any random value just to create noise. Okay, finally we are defining a figure size for it and we are plotting it. So on our x-axis we have time vector and in our y-axis we have signal, that is this. Okay, and finally we are doing plot.show to create this particular visualization. So now that our signal is ready with its noise, so we can apply some fast Fourier transformation on it. So let's move ahead. So here we are applying the fast Fourier transformation. Now that the signal is a real function, so its Fourier transformation will be symmetric. So here the very first thing I'm doing is importing FFT pack from SciPy. Okay, so inside FFT pack we have FFT frequency. The FFT frequency function is used to estimate the sampling frequencies. Okay, and we have FFT over here. So this FFT is what? This FFT function will generate the fast Fourier transformation of the signal. Okay, and finally we need to check the peak. Finally, the peak signal can be found with the help of frequency inside that power.maximum argument. Okay, so after applying the fast Fourier transformation, our signal looks something like this. Fine. Next, we are applying IFFT to get the noiseless signal. So now that we have already applied the FFT, so our next task would be to apply IFFT to get a noiseless signal. So here the very first step is to filter out sample frequencies that are greater than 0 with numpy.where condition. So position under mask equal numpy.where. So wherever the sample frequency is greater than 0, all the values would be stored in position underscore mask. Then apply the filter of sample frequency and store the positive sample frequency on freq. So I have a variable as freq equals sample underscore freq, and inside that I'm passing position underscore mask, this value. Okay, so if you want to get the peak signal frequency over here, you can just print power of pos underscore mask dot argument max. Okay, then what we are doing, then our next task is to find the peak frequency. Here we are focusing on positive frequency. So peak frequency equal frequency of power
inside that par mask dot argmax. Okay, so the maximum peak frequency value would be stored in peak underscore frec. So now our next task would be to get an array copy of the signal where we have already applied FFT. So high frequency FFT equal sig underscore FFT dot copy. Then what we are doing, we are assigning the ones greater than frequency as 0 in order to remove the noise. So high underscore frequency underscore FFT, inside that absolute, we are checking the absolute value of the sample frequency. If it is greater than peak frequency, then assign it 0. So if you want to check it, you can just print the high frequency FFT. Okay. Next task would be to apply the inverse FFT on a high frequency FFT. So this will be the filtered signal. So filtered signal equal FFT pack.IFFT, and inside that we are passing high frequency FFT. Okay. And finally we are plotting it. Here we are defining the figure size, then plt.plot time underscore vector signal label. So label what we have is original signal. So here we are differentiating the original signal with a filtered signal by changing its line width. So we are defining a line width as 3 and its label as filtered signal. Then we are finally adding some X label, Y label and a legend to our graph. Okay, and finally we are showing it. So this would be the output of our code. This yellow signal, what you can see up here, is nothing but our filtered or noiseless signal. So here we have applied IFFT to get the noiseless signal. Okay, so I hope this thing is clear to you guys. So this was all about FFT pack.
What exactly is Panda? Well, Panda is an open source, simple and powerful Python library which is mainly used for data manipulation and data analysis. Okay, now you might be wondering, where does this name Panda come from? So what do you think? Is the name of an animal? Is it? Wrong. The name Panda is derived from the word panel data. Okay. Now what is panel data? Well, this is our panel data. It's a multidimensional data involving measurements over time. Okay. So it consists of various attributes with different attribute value. Okay. So this is how the name Panda came from the word panel data. Okay. Now the question arises, who created pandas? Well, pandas was created by an American software developer and a businessman named Wes McKinney in the year 2015. Okay, so this is the guy who created pandas. Now let's move ahead and see some of the features of Panda. So on number 1 we have is series object and data frame. Well, this is the primary and one of the most important features of Panda. It allows it to deal with one-dimensional and two-dimensional label data in the form of series object and data frame. Don't worry, we'll discuss about them in detail later in our session. Okay. Next, on number 2 we have is handling of missing data. Well, whenever you have a missing data, Panda represents it as NAN. Okay, so this is how Panda easily handles the missing data. Well, no matter where your data is a floating point data or it's a non-floating point data, Panda handles the missing data very easily by representing the missing data as NAN. Okay, next feature is data alignment. Well, this says that the object can be explicitly aligned to a set of labels, or the user can simply ignore the label and let series, data frames, etc. automatically align the data for you in computations. Okay. Next point we have is group by functionality. Well, this is a very powerful and flexible function provided by pandas. It is used to perform split, apply and combine operations on data for both aggregating and transforming the data. Okay. Next on number 5 we have is slicing, indexing and subsetting. Well, using pandas, you can perform intelligent label-based slicing, fancy indexing and subsetting large data set. So we'll see in this module how we can perform all these functions using pandas. Okay. Let's see some more features of Panda. Next we have is merging and joining. Well, using Panda, you can perform both merging and joining operations on your dataset. Okay. Next is reshaping. Well, you can easily reshape your data and pivot your data points using pandas. Okay. Next is hierarchical labeling of axes. Well, this hierarchical labeling of axes allows you to have multiple labels per tick, and this can be done using pandas. Next is robust input-output tool. Well, Panda is a robust input-output tool for loading data from flat files including CSV and delimited files, from flat files like CSV or Excel files, databases, and saving or loading data from the ultra-fast HDF5 format. Okay. And finally, the last feature that we have is time series specific functionality. Well, this time series specific functionality include date range generation, frequency conversion, moving window statistics, moving window linear regression, date shifting, lagging, etc. So all these types of function can be performed in time series using Panda. Okay, so these were some of the features of Panda. Now let's move ahead and compare Panda with NumPy. So you might be thinking there are so many functions and features that make Pandas and NumPy quite similar. But what exactly is the reason that we are preferring Panda while dealing with some of the data then? Let's discuss that with the help of a comparison between Panda and NumPy. So the first point that we have is Panda works better with NumPy while dealing with data which has more than 500,000 rows. Okay, and when you are using NumPy, so it performs better for 50,000 rows or less. Okay, so in working with large real world data, you would need Panda for computation. Okay. Next we have is Panda series object is more flexible as you can use it to define your own label index to index and access elements of an array. On the other hand, element and NumPy arrays are accessed by their default integer position. Correct? So this is how Panda is different from NumPy. So now that you know how Panda differ from NumPy, next we'll see how we can import pandas in Python. So for that we have a command import pandas as pd. That's it. Okay. Next is what kind of data does suit pandas the most? So we have tabular data, time series data, and arbitrary matrix data. All of these kind of data you can feed it to the pandas. So now that we have learned the history, features, and how to import Panda, let us dive deep and see what kind of data suits pandas the most. So it deals with tabular data with heterogeneously typed columns as an SQL table or Excel spreadsheet. You can also work with ordered and unordered time series data. And it also helps you to work on arbitrary matrix data with rows and column labels. Okay. So guys, this was all for the introduction to pandas. Pandas series object. So in this session, we'll learn about what are the different types of dataset in pandas, what is a series object, how to create a series object, how to check the type, and how to change the index name of a series object. I hope the agenda is clear to you guys. So without delaying any further, let's see what are the different types of dataset in pandas. So we have one-dimensional and multi-dimensional data. So you can work on one-dimensional, two-dimensional, or any multi-dimensional dataset in pandas. If you are working on a one-dimensional dataset, it's known as a series object. If you are working on a two-dimensional, the Panda will create a data frame for it. If you are working on more than two-dimensional data, Panda would create a panel data for it. Okay. Now you might be wondering what are these terminologies, right? So let's have a look at them one by one. So for this session, we'll be mainly focusing on series object. So what exactly is the series object? Well, a series object in Panda is a one-labeled array which is capable of holding any data type like integers, strings, floating point number, Python object, etc. Okay, it can contain data of similar or any mixed data type. You can also say that a series in Panda is quite similar to a list or an array in Python, but yet it's more powerful. It represents a series of both numeric and non-numeric values as a column of data containing any type of mixed data. So you must remember the fact that a series can contain any type of data even if it's of a mixed data type. Okay. Now let's see how we can create a series object in pandas. So here in this example, we have a list of numeric data stored in data. Okay. And now we want to create a series object out of it. So for this, Panda has a function series with capital S. So here we are calling that function using pd.series of data. Okay. And storing it in a variable or a series object name series1. If you print it, you'll notice that in the output you have one-dimensional array labeled as 0, 1, 2 and 3. Let's make it more clear using my Jupyter notebook. First topic is series object in pandas. So the very first thing that I'll be doing up here is importing my pandas library. So import pandas as pd. Next, I need to define the list of the data. So let's say data equal 1, 2, 3 and 4. Fine. Now I want to create a series object out of this one-dimensional data. So how will I do that? For that, let's define a series object name. Let's say it's series1. So series1 equal pd.series. Make sure you are using capital S, not small. Series, and inside that pass data. Okay. Now if you print your series1, you will see that you have one-dimensional array of 1, 2, 3 and 4 which are labeled as 0, 1, 2, 3. Okay. So this was about series object in Panda. So let's move ahead. Next is how to check the type. Now what if I want to check if it is a series object or not? So you can do it simply by typing the command type, and inside that pass the name of the object. So here we have passed series1 as the name of the object. Let's check it in our Jupyter notebook, what it has to say. So in order to check the type, all you have to do is mention type, and inside this write the name of the series object, which is here series1. So if you execute it, you'll get the output as pandas.core.series.series. So definitely it's a series object. Okay, to our PPT. Next topic is how to change the index name. Now what if I want to change the index name from 0, 1, 2, 3 to ABCD? So how will I do it? So let's see. So for that, all you have to do is add a new parameter index over there and define the index inside it. That's it. Let's see how. So what we are doing up here, changing the index of a series object. Okay, so I don't want to write the entire code, so let's just copy this thing, and all you need to do is specify index parameter over here. So index equal, inside this, let's say first is A, next is B, next is C, and the last one D. Okay, and now if you execute series1, you'll see that the index name is changed. So here we had index name as 0, 1, 2, 3, which here changed to ABCD, or customize index name. Okay, so I hope this thing is clear to you. Well, next is create different series object data type. Well, pandas is not just about the list. You can use different arrays, you can use dictionary over there, or you can use any scalar or any constant value to create a series object out of it. Okay, I hope the concept of series object is clear to you. Pandas data frame. So in this session, you will learn about what exactly is a data frame, what are the various features of a data frame, and finally, how to create a data frame. So without delaying any further, let's start with what is data frame. Well, as I told you earlier, in pandas, two-dimensional data is found in the form of data frames. So now the question arises, what exactly is a data frame? Well, a data frame is a two-dimensional label data with columns which can contain data of different types. Correct? Let me show you an example. So here in this example, you can see we have a two-dimensional data with the column label on the x-axis and the index on the y-axis. Correct? So this is an example of a data frame. So now that you know what exactly is a data frame, let's move ahead and see what are the different features of a data frame. So a data frame contains column of different type. We can even change the size of a data frame as it is mutable. You can even have data access labeled, and you can also perform various arithmetic operations on rows and columns. So these are the various features of a data frame. So now that you know what exactly is a data frame, let's see how to create one. So you can create a data frame using this command, pd.dataframe, and inside that mention the data. Okay, let me just open my Jupyter notebook and show you how exactly it is created. So this is my Jupyter notebook, and this is where we left in our previous session. So today we'll learn how to create a data frame. Okay, let me just change it to markdown. So again, in order to create a data frame, the very first thing that you will be doing is importing the panda library. So import pandas. Let's say I want to import pandas as PD. I don't want to use the name pandas again and again. Okay, so now that I have imported my library, let me just define some data. So let's say data equal 1, 2, 3, 4, 5. Okay, and now I want to create a data frame. So let's say df equal pd dot data frame, and inside that what I need to pass is the data. In this, make sure that your D and F is capitalized. Okay, and let's print the data frame. Let's see what is the output. Okay, so here we got the output of data frame. So as you can see, on our x-axis we got the label as 0, and on the y-axis we got the index as 0, 1, 2, 3 and 4. Okay, so there's a simple example of a data frame. So this data frame was created using list. So let me just add this, creating a data frame using a list. Okay, so next what I'll do, I'll show you an example of creating a data frame using a dictionary. Okay, so let's define our dictionary. So let's say my dictionary equals, inside this I'll write fruits, and my fruits consist of array of different fruits like apples, banana and mango. So let's add one more key value to it. So let's say I'm adding count. So count equal, I have 10 apples, 20 bananas and let's say 15 mangoes. So here I have defined my dictionary. Now I need to create a data frame out of it. So let's say data frame equal panda pd dot data frame dnf capital, and inside this I'll pass my dictionary, and let's print it out. So as you can see here, we got a data frame with the labels as fruits and count and the index over here as 0, 1 and 2. Okay, so this is how we create a data frame using a dictionary. So now that you know how to create a data frame using a list and a dictionary, now let me show you how you can create a series. Well, the series is the same which we learned in our previous session. It's a one-dimensional labeled array which is capable of holding data of any type. You can have any integer, string, float or any kind of value in it. Okay, let me show you how you can do it. So here what we are doing, so here we are creating a data frame using a series.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, so let's define our series. Let's say series equal pd dot series. Inside this, let's say I have 6 comma 12, and also let me specify the index. So let's say index equal a comma b. So there's my one-dimensional array with its defined index.
Just a quick info, guys. Intellipaat provides online data science master program in partnership with IBM. The course link of which is given in the description below. Now, let's continue the session.
Okay, now I want to create a data frame out of a series. So how will I do it? So let's see. So df equal pd dot data frame with dnf capital, and inside this I'll pass the series. Okay, now let's just print it. So as you can see here, we got this output. So here our one-dimensional series got converted to two-dimensional data frame with index as a and b. Okay, so now that you know how to create a data frame using a series, next we'll see how we can create a data frame out of a NumPy array. Okay, so let's see how. So here, creating data frame using a NumPy array. Okay, so here the very first thing that I'll do is import my NumPy library. So import NumPy as np. Since I have already imported pandas up there, so I don't need to import it again. So after importing the libraries, next what I'll do, I'll define my NumPy array. So let's say my NumPy array equals np.array, and inside this let's have some salary value like 50,000, 60,000. Let's say these are the salary of employee whose names are, let's say, John and James. Okay, so now that I have defined my NumPy array, let me just create a data frame out of it. So data frame df equal pd dot data frame. So let's add the name of the employees over here. So name, and this will fetch data from NumPy array with cell, first cell. Okay, and next let's define salary. So salary will fetch data from NumPy array 0th index, right? So my data frame is created. Now let's just print it, execute it. Data type not understood. Okay, so I've missed this opening and closing square bracket over here. That's why I'm getting this error. Let's execute it. Okay, It's resolved. So here you have just created a data frame out of a NumPy array with column name as name, salary, and here's the index numbers 0 and 1. Okay. Merge, join, and concatenate operations that can be done on the data frame. So today you will see how you can perform merge operation on two different data frames using pandas, how you can perform join operation between them, and how you can perform concatenation between them. Okay. So I hope the agenda is clear to you guys. So without delaying any further, let me just switch back to my Jupyter notebook and let me show you how you can perform these operations. So here's my Jupyter notebook, the way we left it in our last session. So today what we are going to do, today we are going to see how to perform a merge operation between two data frame. Okay, so for this, the very first thing that I need to do is create my data frames. So first of all, let's import the libraries. So import pandas as PD. I'll be needing this library only. And now let me just define two data frames. Now once I've imported the library, so next thing I'll do is define few lists over here. So let's say player equal player 1, player 2, and player 3. Okay. Next, let's define a list of points. So point equal, let's say 8, 9, 6. Okay. Let's also add a list of title to it. So title equal game 1, game 2, and game 3. So now that I have defined three lists over here, I need to create a data frame out of it. So let's say my first data frame equal pd dot data frame, and inside this let's create a dictionary. Let's add a label, let's say player, and this player contains all the values from my list of player. Okay, comma points, and this points consist of all the values from the point list, and the title which consists of all the values from the title list. So I have created my data frame over here. So let's just print it. So this is my data frame which I just created. So one of the data frame is ready. Now let's define another data frame. For this we'll be needing different list. So let's say here player equal player 1, player 5, and player 6. Let's define another list as par. So par equal punch, kick, and elbow. Fine. Next I'll define a list of title. So here title equal player is from the game 1. Next is this one from the, let's say, game 5, and this one from game 6. Okay, here all our lists are ready. Now let's create a data frame for it. So here df2, that is second data frame, equal pd dot data frame. So inside this let's define our dictionary. Say column name is player, which consists of the values from player list. Next is par, so my next column is which consists of the values from par list. And the next is title, again which consists of the values from title list. So there's my second data frame. Let me just print it. So here my second data frame is also ready. So this one is my first data frame and this one is my second data frame. So now that our data frame is ready, so the very first thing I'll be performing on it is inner merge. So what exactly is this inner merge? Well, the result of this inner merge would be return you the row which is common in both the data frame on the base of any key value. So let's have a look at our data frames. Any common value over here, like any common column you can say. So we have player and title in both our data frame, right? So we can perform the inner merge using any of these two columns, either player or title. Let me show you how. So let's say I want to merge my data frame 1 with data frame 2. So I'll write data frame 1 dot merge with what? Data frame 2. Okay, and on the base of what, you have to specify your key value over here. So on, let's say I want on the base of title. Okay, and how I want to merge them. So how equals inner. So this will give you the inner join. So we got this result over here. So here player underscore x represents that this attribute is from data frame 1, and player underscore y represents that this attribute is from the data frame 2. Okay, So why did we got just one value over here? Let's explore it. So on the base of title, so we are merging on the base of title. So what are the common values in it? As inner merge give you the common set of values in both the data frame on the base of what attribute you are choosing. So as we have chosen title over here, so common attribute is game1. So only game1 is common, right? So whatever values are associated with game1, you got that. Okay. If I change the value of title to player, let's see what's the difference. So here I got the value of player 1, as player 1 was only common in both the data frame, right? So here player did not get split into player underscore x or player underscore y. So instead of that, title got splitted up to title underscore x and title underscore y. Okay. So here title underscore x is game 1 and title underscore y is also game 1. So this is how we perform an inner join on two data frame. So just to tell you, by default, if you merge two data frame, it will perform an inner join. Okay, see. So this was all about inner merge. Now let's move ahead and see how you can perform left merge. So even performing left merge is quite similar to the one which you performed in inner merge. Just have to write data frame 1 dot merge data frame 2 on player, and instead of this inner you have to mention left. That's it. So in case of left merge, both of the table would be merged together, but in this case all the values from table 1 would be there. So our table 1 has, or the data frame 1 had player 1, player 2 and player 3, right? So all these values are over here, and apart from it, what else you will get? You will get all the values from second data frame, and here you will get all the common values from your second data frame. So here my player 1 was in both the data frame, right? So it merged both the table and it showed me these values over here, punch and game 1, right? But for player 2 and player 3, they were not in the second data frame, right? So that's why Panda was not able to identify what value should it give in power and title. So that is why it mentioned NaN over here. Okay, so this is how you perform a left merge. Now next, let's see how to do a right merge. So again, you don't have to do anything, just change left to right. So left becomes right. So you got this value. So why I'm getting this value? So similar to left merge, now it's performing right merge. So all the values from your right table would be here. Okay, so player 1, 5, 6. I'm getting all the values from my right table or right data frame or second data frame, right? So 1, 5, 6 are over here. 1, 5, 6, punch, kick, elbow, and game 1, game 5 and game 6. And apart from it, what are the common values from the left data frame, right? So from our first data frame, we got this value, as player 1 was common in both of them, correct? And apart from it, we didn't had any value for player 5 or player 6. That is why we got NaN, NaN, NaN and NaN values over here. So this was about the right merge. Now next is how to perform an outer merge. Let's see. Outer merge. So here all you have to do is change this to outer. Execute it. So in this case you will get all the values, and wherever the value is not common you will get NaN over there. Okay. So this was about the outer merge. So guys, this was all about the merge. Now next, let's move ahead and learn about the join operation using Panda. There's a slight difference between the merge and join in case of Panda. Let me tell you what. In case of merge, the two data frames were getting merged on the base of their attribute name or the column name, right? So it's a must that both the data frame must contain at least one common attribute name, right? But this is not the case in join. It's a bit different. In case of join, the two data frames are joined on the basis of their index value. Join is generally used when two tables have completely different attributes, and this is the reason why you have to specify the set index while performing join. Okay, so here you can say that it's must to have a common index between the data frames. Okay, so let's move ahead and let me just show you how you can perform join operation. So here, how to perform join operation in pandas. So similarly, the very first thing that we need to do is define our data frame. So let's just copy the one which we already created. So here I need to make some changes in it. What change? Here I have to add index value for it. So let's say index equal L1, L2 and L3, as this is my left data frame. Okay, and let's define our fourth data frame, and in this let's change the name of the attribute. So here let's make players and titles, and also let's change the index number. So let's say we have L2, L3 and L4. Okay, so our data frames are ready. Here I'll be performing the join function. So first let's perform inner join on it. Well, the concept of inner join and inner merge, everything is same. Okay, just the difference is how it is used. In case of join, the two data frames are joined on the base of their index name. In case of merge, two data frames are merged on the base of their attribute name. It's the only difference. Okay, and it's same with inner join, left join, right join, outer join, everything. Now let's see how to perform a inner join. So I want to join my data frame 3 with data frame 4. Okay, we have to change it. Let's name it 4. So I need to join data frame 3 with data frame 4. So df3.join inside this data frame 4. And how I want to join? So how equal, I want to perform inner join between them. That's it. Execute it. Okay, we are getting error of columns overlap. Okay, I guess we missed one value over here. Okay, now both our tables are also different. Okay, now let's perform inner join on it. So while performing inner join, you can see that it has joined both the tables on the base of their common index name, right? So L2 and L3 are common part over here. So that's why we got these values. So this player is from the left data frame and this player is from the right data frame. Fine. So this was about the inner join. Now let's change it to left join. So left join, let's copy it and just change inner to left. That's it. So here you can see that we are getting some null values over here. So why we are getting null values over here? So it's the same reason what happened in case of merge. So in case of left join, it is merging both the data frame with all the datas from the left data frame and all the common datas from the right data frame, right? And wherever the data in right data frame does not matches that to the left one, so there we are getting a null value. Okay, similarly right join, how? Right. In this we are getting all the values from our right data frame and all the common values from the left data frame. Fine. Next is outer join. Just write outer over here. So what it did, it just merged both the data frames. Wherever it was not able to find the common values, it assigned null values to it. Okay. So this was all about join. Now next we'll see how to perform concatenation using pandas. So here we'll write how to concatenate two data frames in panda. So we already have defined data frame 3 and data frame 4, right? 3 and 4. So let's just concatenate them. So for concatenating data frame 3 with data frame 4, all we need to do is pd.concat, and inside it mention what all data frame you want to concatenate. So here data frame 3 with data frame 4. That's it. Execute it. So you got this value over here. Okay, so it is basically concatenating both the data frames. Okay, how to import and analyze your data set. So in this session, you'll learn about how to import a data set using pandas and how to analyze various attributes of the data. So I hope the agenda is clear to you guys. So without delaying any further, let's start and see how we can import a data set using pandas. So for importing the dataset, the very first thing that you will be doing is importing the pandas library. So I'm importing pandas as PD. So next we are going to read the dataset and store it in a data frame. So I'm defining a data frame named cars, and inside this I'm passing the path of my CSV file, which is empty cars2.csv, At this point, you can specify the path to your CSV file. Okay. And finally, we are printing it. Let's see the output. So this is my entire data. So let's move ahead and see what are the various analysis we are going to perform on it. So first is type cars. So this type car is used to check the type or check the data type of the car. So it's a data frame, right? So as a part of output, we got pandas.co.frame.data frame. Okay. So the type of cars is, it's a data frame. Next is cars.head. Well, this is used to view only the first 5 records of your data frame, which in our case is this. Okay. Next is if you want to view first 10 records from your dataset, you can pass the attribute over here as 10. And so as an output, you'll get first 10 dataset from the data frame. Okay. Next is what if you want to view last 5 records, then you can use the parameter dataframe.tail, which in our case is cars.tail. Okay. So this will give you the last 5 record of your data frame. Okay. Similarly, if you want last 10 records from your dataset, you can specify a value over here. So dataframe.tail, inside this I pass 10. So this is giving me last 10 records from my dataset of cars. Okay. Next is cars.shape. Now if you want to view the total number of rows and columns in your data frame, for that you have dataframe.shape. So cars.shape gave me the output as 32 and 13, which means I have 32 rows and 13 columns in our dataset. Now if I want to concise the summary of the column of my data frame, for that I have dataframe.info. And inside info, I'm passing null underscore counts equal true. So what it is exactly giving me, it is giving how many non-null values are up here. So as you can see in QSEC, we have 29 null values. So from here, you can say that we have 3 null values in our column QSEC. Okay. This is the data type of each column. The first serial number is of integer data type, next is object, MPG is object, cylinder is integer, and so on. So in total, we have 4 columns which consist of floating data type, 7 columns which consist of integer data, and 2 columns which consist of data of object data type. Okay. And the total memory usage is 3.3 plus KB. Fine. Let's move ahead. Now if I want to calculate the mean of my data frame, I can just write dataframe.mean, which in our case is cars.mean. So as a part of output, it gave me the mean of each column. Okay. Next, if I want to calculate the median, similarly dataframe.median, cars.median, it gave me the median of each individual column. Okay. Next is standard deviation. Well, for standard deviation, we have dataframe.std. So if you see the output over here, you are getting the standard deviation of each column. Fine. Next, similarly, you can calculate the maximum value of each attribute by using dataframe.max. So we have cars.max, for which we are getting maximum of each attribute. So in serial number, we have 35 unnamed maximum value. This MPG, it's 33.9 and so on. Okay. Similarly, you can calculate the minimum value for each attributes using dataframe.min, and you'll get minimum value for all these different attributes. Fine. Next is dataframe.count. So if you want to count the total number of non-null record in each column, then you can use dataframe.count. So which in our case is cars.count. So here as output, we are getting how many non-null values are in each column. So here in QSEC, you can see that we have 29, which suggests that we have only 29 non-null records and there are 3 null values in it. Okay. Next is the dataframe.describe function. Well, it is used to print the descriptive statistic summary. If you don't want to calculate each of the feature individually, you can just write dataframe.describe, and this will give you the output of count, mean, standard deviation, minimum, maximum, 25 percentile, 50 percentile, and 75 percentile values of all the different columns. Okay. So these were the various attributes you can use it for analyzing your dataset. Okay. Cleaning the dataset. So in this session, you learn about what is meant by data cleaning and what are the various methods that you can use to clean your data. So I hope the agenda is clear to you guys. So without delaying any further, let's see what exactly is data cleaning. So data cleaning or data cleansing is a process of detecting, correcting, or removing corrupt or inaccurate records from a dataset, table, or any database. It also refers to identifying complete, incorrect, inaccurate, or irrelevant parts of our data and then replacing it or modifying it. This is what a data cleaning is. So let's see how we can clean our data. So the first thing that we can do to clean our data is we can rename the column. Okay, so in our data set, we had a column as unnamed, right? So instead of using the column name as unnamed, we can replace it by name of the model, which represents the exact name of the column, as the column contained different model of the car, right? So here what we are doing, we are renaming the column unnamed to model. So as you can see here, as an output, we got model up here. Okay. So this is the very first thing that you can do while cleaning your data. You can rename the attributes. Next is, what if you have some null values in your data? So for treating null values, what you can do, you can fill the null values with the mean of the column. And this is how we do it. So cards.qsec. So as we have analyzed in our previous session that qsec had 29 non-null records, right? So which it meant that it had 3 null values in it. So we replaced all those null values with the mean of the qsec column. So what we did, we took the mean of the entire 29 and whatever value we got for the mean, we replaced all the null values with that particular value. Okay. So replacing the missing data with the mean value will help analyzing the data in a better way. Okay. So this is how we can replace the null values with the mean of the column. Next is drop the unwanted column. So here we can drop all those unwanted columns which do not add any value in analyzing the data. For example, we had serial number previously, right? But the serial number was not adding any value to our analysis part. So for the further processing of the data, we can avoid or we can drop the column of serial number. Okay. So how we can drop any column? So for dropping any column, what we have to do is data frame.drop, and inside that we have to mention the name of our column, just like this. Cars equal cars.drop, and inside this columns equal, we are mentioning the name of the column as serial number, and it got dropped. So as you can see here in the output, we don't have the column as we used to have it previously. So here a serial number column is dropped. Well, next is finding correlation matrix. Well, this correlation matrix will help you to find how a variable is correlated to other variable. So if the value of correlation is high, so that means the two variables are highly correlated to each other. That is, changing one variable by a factor of x changes other variable by a factor of y. Okay. So here as an output, we got a correlation matrix, right? So from here you can see that cylinder to cylinder, it's highly correlated. That is one, obviously. Cylinder to displacement, it is 0.9. So it means that cylinder equals 0.9 times of displacement. So it's like if you increase cylinder by 1 unit, your displacement would increase by 0.9 unit. Okay. So similarly for DRAT, you can see that cylinder equal minus of 0.69 times of DRAT, which means if cylinder increases by 1 unit, it means the value of DRAT would decrease by 0.69 units. Okay. So if while finding a correlation matrix, you get a very small value of the correlation, for example, let's consider this. So here correlation between carburetor and DRAT is minus of 0.09. So it means they are very weakly related to each other. So it's like if the carburetor is increased by 1 unit, so it means that if the carburetor is increased by 1 unit, then DRAT would decrease by 0.9 unit, which is almost very less, right? So by finding correlation matrix, you can define the correlation between the variable, and from here you can decide which attribute to choose and what not to choose while working on the problem. Okay, fine. Let's move ahead. Next is changing the data type. Well, initially MPG was of data type string, right? Well, MPG had some float or numerical values into it, right? But with the string, we cannot manipulate it, or we cannot perform any calculation on the string data, right? So MPG has to be converted to float in order to perform some data manipulation on it. So here we are converting MPG from string to float. So how we can do that? So it's dataframe.mpg equal dataframe.mpg as type, and inside that we are mentioning the data type which we want to convert to, and here in this case is float. Well, now if you want to see the change, you have to see cars.info null underscore counts equal true. So from here you can see that my MPG has been changed to floating data type, right? And even for the qsec attribute, we have replaced all the null values from its mean, right? So here it's giving me 32 null values. That is, now it is not having any null values in it. Okay, let's move ahead. So again we are finding the correlation. This time the MPG part is included as it has become of a floating type. Remember, while calculating the correlation between two attributes, both the attributes should be numerical in nature. No correlation can be found between attributes of string data type. Okay. If you compare it with our previous correlation, you can see that there was no MPG value, right? As initially the data type of MPG was string, right? Now since we have changed the data type of MPG to float over here, so next while finding the correlation, we are getting MPG value. Okay. Now Python is treating it as a numerical attribute and it is using it to find the correlation. Okay. So this was all about how you can clean your data set. Okay.
The next couple of hours, I think we're going to talk a little about how to ace a data science interview. In general, the data science interviews are slightly different from other interviews. They're essentially um, I mean, if I may say, they're slightly trickier than regular interviews. Not that they're very different, to be honest. There are a couple of rounds are slightly different. The questions are slightly different. The approach to the interview is slightly different. So I think it's worth talking about what are the nuances of a data science interview and how would you typically um, attend an interview and prepare yourself for that particular interview. With that, let's get started with the first one: types of data science roles. Yeah, so there are three major types of or there are three types of data science roles, if I may say. Like or four, let's three. The reason I mention it three is because two of these are more or less similar, and I'll talk about those. So the first is um, the kind of work that you're going to do in a data science company depends on what the company does in the first place. As a data scientist, you could be a part of a consulting team or a services team, let's say. Yeah, consulting your services is essentially there is a company that does technical consulting or technology consulting or let's say strategy consulting to another company, and you are a data scientist who is helping your client to solve a particular problem, right? Let's say your typical services companies in India, or let's say abroad, any of your typical services companies, your IT giants, like let's say your TCS, Infosys, and so on, Accenture, CTS, Cognizant, they're all IT consulting services. While you have strategy consulting services, like let's say strategy consulting companies like your Bain, McKinsey, Deloitte, and so on. So there are other companies that do strategy consulting for clients as well. So you could be a part of any of these companies. Like for example, you could be a part of a TCS, or let's say my role for that matter at Microsoft. I'm a part of the services division of Microsoft. So you are essentially a part of a technology team, or you're essentially a part of this particular company that provides technology services, and you would be solving the problems of another client of yours. Now, the work that you do here would require you to have certain skill set, and we'll drill down on what kind of skill set is required for a data scientist in a consulting company, as opposed to the skill set that is required for other roles. Before that, we'll just walk through the four types of roles. The second role is specifically around your um, a captive or in-house data science teams. Like for example, let's say you're a telecom company yourself, and you would want to hire a data science team, and you're going to be a part of the telecom company itself, and the data science team, let's say, helps solve problems for this particular data science team. Data science team helps solve problems of that particular company itself. Let's take the example of AT&T or Verizon or any of these telecom giants in the US, or let's say any company for that matter. Take the example of Amazon, take the example of Facebook, or any of these companies. You're an in-house data science team, you're a captive data science team. There are no fixed responsibilities you have. You would essentially be helping different divisions in your organization to solve problems. So you would more or less be acting like a center of excellence within your organization. So various teams reach out to you and say, look, we have this particular problem, can you solve it for us? Look, we have an issue with with, let's say, the kind of feedback that we're receiving from customers. Can you help us mine this particular piece of text? So that's the second kind of problem, a second kind of roles that you would generally be a part of. The third is product development companies. Product dev is your typical company, typical teams where, let's say, for example, companies like Amazon or Microsoft, or let's say Google for that matter, they build small products. Let's say Google is building Google Maps. You are a data scientist that belongs to the Google Maps team, which means that um, which essentially means that you are somebody who's a part of the maps team alone. Your work is curtailed to the maps division only, the Google Maps division only, and then your work is very, very specific to that particular team. So all the problems that you would be solving will be specific to that particular product, and you're responsible for deploying that particular piece of work that you do, and monitor it, and fine tune it, and so on and so forth. So the life cycle is very much like any product. You know, and the life cycle is more or less like your like your typical um, uh,
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
the life cycle of a product is the role of a data scientist is, kind of aligns with the life cycle of a particular product in the case of product development teams. Um, Last but not the least, I think the most important thing is research teams, and these are essentially the stalwarts in any domain, right? These are research teams. All your major IT companies, all your major digital companies would have a research team. And the responsibility of these research teams, of course, is that they are ultra technical, they're super strong, they work on bleeding edge, cutting edge technologies, they are and they work at their own pace, right? So that's essentially what the research teams essentially are all about. Now, let's talk about each of these in more depths. Let's talk about the first one, and we'll try to draw some differences between one role to another role. Let's take the example of the data science consulting teams. Consulting or services teams are expected to have, of course, across these four teams, the primary skill set is machine learning, and machine learning data science will remain to be the primary skill set. That's the core to which everybody hangs on to. But each of these roles differentiates itself from the type of work that you're going to do and the ancillary skill set that you will have to build around it. So, for example, for a data science consulting team, one of the most important skill sets that they need to have is communication skills. Every data science consultant should be very, very well conversant. They should have the ability to converse with the customer, b empathize with your client, because you should be able to understand the problem of your customer and then translate that problem into a data science problem, translate a business problem into a data science problem. I'll give you an example. So the role of a data science consultant essentially is that the data scientist, the business, have a conversation with the customer, and let's say with the customer of yours could be, let's say, a diamond mining company in let's say somewhere in Africa. The reason why I quote that is because that's one of the problems that I'm currently solving. So let's say you are talking to a diamond mining customer in Africa. They have no idea about what data science is. So you just cannot go there and start talking about regression and classification and machine learning and so on, because they honestly don't care, right, how you solve the problem. So your responsibility is listen to them, and their problem could be, well, you know what, one of the biggest problems that we have in our businesses is that our heavy equipment in our mine tends to break down very often. So one of the challenges for our business is if we can reduce those downtimes reduce the number of failures that occur to our components, then we should be able to improve the efficiency of our plant. This is their business problem. The business problem, quote unquote, is that there are a lot of downtimes, a lot of failures that are happening to a particular equipment in a plant in somewhere in Africa, and they've reached out to let's say you, who's a machine learning expert, who is, let's say, a consulting company, and they would want you to solve that problem. Now, there are numerous ways of solving this particular problem. One of the approaches of solving this particular problem is, okay, as a data scientist, if you were there, or let's say as a technology consultant, if you are there, you are expected to ask a few questions. What kind of data is being captured? Okay, we see that sensor data of the equipment is being captured. Great. Do you also capture the failures of the equipment? Let's say they say, yes, we capture the failures of the equipment as well. So using the sensor data and the failures information, we may be able to build a classification algorithm which would essentially help us predict, based on the sensor readings, it would help us predict, will there be a downtime or not? Will there be a component failure, yes or no? So we essentially solving a classification problem here. So this transition of a business problem into a data science problem is what a data science consultant is supposed to do. That's exactly where his or her role is super critical, right? So that's the first and the most important thing, as opposed to, let's say, a captive data science team, or a data science team which is inside inside a particular organization, solving problems for that particular organization alone. The thing about that person is that, let's say you are a part of a telecom company or an insurance company, and let's say you are a part of let's say an election campaign for, let's say, one of the presidential candidates. You are as a data scientist, you are expected to understand your domain in and out very well. In the earlier case, you don't really have to be a master of the field, right? Master of the domain. You don't have to be a master of the mining domain. And if you know the mining industry, that's great. But if you are, let's say, a data scientist who's sitting inside that mining company, or he's sitting inside a particular who is working for a mining company and is hired for that particular mining company, then you are expected to be a master of the mining industry. You have to essentially learn the industry very, very well, understand the intricacies very well, and then based on that particular based on that particular value of that particular understanding of yours, you're expected to solve data science problems. So because now you're an insider, understanding the business issues and understanding the problems that people face in the field is much easier. So hence the responsibility of a data scientist in a captive data science team is slightly different from that of a consultant data science. Both of them solve data science problems, of course, but while a consultant data science is essentially looking at solving data science problems as a point solution, as a captive data science team, you are expected to solve data science problems in a much more holistic manner, because you are in that organization, you are aligning yourself to the aims and objectives of that particular organization. So you do slightly more than what a data science consultant does. Data science consultant, on the other hand, gets the opportunity to work on different kinds of problems, different clients, different problems, small engagements. So the variety is much larger, but the data science consultant doesn't have the ability to stick to a problem and work for a longer duration on that particular problem, as opposed to a data scientist in a captive data science team, or an in-house data science team, who will have much larger time and much larger amounts of time in his hand to solve a particular problem. But the problem is, you might not have a lot of variety in the work that you do. So that's the captive data science team. Both are great. Both are amazing. One where you have fast-paced, lot of work, different kinds of work. Second, where you get to see a problem getting solved end to end. Right from ideation all the way until actually deploying it and monitoring it and seeing how well it works and things like that. So yeah, so those are the first two roles. let me tell you this: product research teams will come to product development in a minute. Research teams are essentially out of our league. If I mean, I think I'll go to the extent of saying that. The reason I say that is because research getting into research teams requires us to have a lot of academic background. So if you're someone who's doing a PhD in AI, then probably you're someone who can walk into the field of walk into a research team. And the reason I say that is not because you're supposed to have a degree to get that particular role. No, that's not why I say that. The reason I say that is because you should have the ability to sit and work on one problem for a few years to get to the solution. So it requires a patience. It requires some method to the madness. Research, it is very, very research oriented, very, very slow paced work. But you will be working on cutting edge stuff that probably nobody is currently working on. So it requires a lot of skill set in terms of a lot of depth in the skill set. Um, but you might not see you might not be able to churn out solutions as fast as, let's say, how the data science consulting teams or, let's say, in-house data science teams do as much. So the work could be slightly far more slow paced in a research team, and the requirements are much larger. The third and a slightly interesting role is being a part of the product development teams. Let's say, for example, I'll tell you the kind of work that you will be encountering. Let's say, I don't know if you're familiar with this particular feature, and I'm going to show it to you right now. So in PowerPoint, right? So if you click on design, and if you click on right side design ideas, if you see this, it automatically pops up various designs that I could possibly set up for this particular various layouts that I could use to present this particular content. Right? How do they do this? And who's doing this? For all you know, who do you think is actually solving this particular problem? Right? In general, the kind of people who solve this particular problem are data scientists. Of course, this is a data science problem because I will have to automatically identify which layout to match to the content that I see here. So it's definitely a data scientist. Also, to the extent of what images should I put, right? What images should we put here? Product development and data science and things like that. So if you see, you generally have relevant images also that come up here. So this is definitely data science work.
Just a quick info, guys. Intellipaat provides online data science master program in partnership with IBM. The course link of which is given in the description below. Now, let's continue the session.
Right, for sure. But who's doing this? So this is essentially done by a data scientist who is a part of the Microsoft PowerPoint team. So there are a lot of data scientists that are available outside. One of the data scientists who's working on this particular feature could be a data scientist who's aligned to the PowerPoint team at Microsoft. Similarly, you would also have a lot of other products. We're using, let's say, this particular tool called GoToWebinar, and there could be a lot of AI implementations that is happening in the background. Like, for example, there could be a team which is working specifically on monitoring the logs of this particular tool. Who would be doing it? It could be someone who is a part of it could be someone who's a part of the GoToWebinar, let's say, product team, who's going to sit down and evaluate, analyze, and things like that. So Pradeep says it is more of design and programming rather than data science. Well, not really. There is definitely data science, because you, of course, will have to build the solution that could map this particular slide to a new design. So there is definitely a lot of data science that is associated with it. But the thing is, you are aligned to a particular feature. You're trying to hone that feature. You're trying to make that feature more smarter by the day. We're essentially trying to ensure that a particular product is built really very well, and I'm embedding intelligence into one particular product. That's what that is what you're working towards. Say for example, a lot of us, let's say, are using Zoom over Zoom or Teams to communicate. So suddenly you see this background thing that's coming up, right? So you could automatically change the background of where you're sitting when you're casting your video. You could change the background. So who's doing that work? Automatically removing the background. It's essentially a part of a computer vision exercise. It's called as background deletion. Or background differencing. So you can automatically identify the background, and you can blur the background, or you can add some background to your video and things like that. All of that can be done. Who would be doing it? It is essentially again done by a data scientist who is a part of, let's say, Zoom's team. What is the best part about being in a product team? You can see the features that you build go out very well. I mean, you could definitely experience the product that you build. So you are building AI product, quote unquote, right? But what's the drawback of it? One of the drawbacks, I wouldn't say a drawback. The thing is, your work can get a little mundane. Your work can get a little repetitive beyond a certain point, because you're solving the same thing continuously. You're trying to improve the same product continuously. So a lot of things that I get to hear from a few people is that the work there could get a little repetitive. So yeah, those are the different types of those are the different kinds of roles that are available. Sumil Ahmed, data science consulting services role would be more of a business analyst. I have a particular slide where I talk about different roles, and so there are different terminologies and different roles. I will get to that when we talk about it, but no, these are not the same. If you're a data scientist, you're a data scientist. The term data scientist, data analyst, and business analyst are not one and the same. So let's not confuse them to each other. So when you're in data science consulting or data science services, you're still a data scientist. You still do data science work. The term business analyst is a very loosely used term across the industry, and we'll talk more about that particular term when we get there. But no, you're still doing data science work here. Cool. Okay, so I hope we all understand the different varieties of roles that are available. Okay, so let's talk a little about the various interview stages that are there, right? As far as the interview stages are concerned, I think in general there are three major, or rather, when I say there are three stages, I don't mean you will have 3 rounds. 3 stages are 3 types of rounds. Think of it that way. 3 phases of your interview. The first phase is, of course, you're going to have a 0th phase, which is your resume filtering. Your resume will get filtered even before you called for an interview or anything, right? So the 0th phase is where your resume filtering happens, and simple way of filtering a resume is dependent on the skill sets that I mentioned early on. You're expected to have Python experience. You're expected to have Python or R experience. You're expected to know SQL. You're expected to know have some knowledge on big data, and you're expected to have some knowledge on deep learning frameworks, like let's say your TensorFlow or what's the other one, PyTorch or Keras or any of these. So if you've been able to tick boxes of the 4, that means you have at least qualified from a tool stack standpoint. You have qualified. So at least those are a few areas which help us filter out a particular which help us filter out a particular piece of information, of a particular piece of profile. And many profiles help me filter down the profiles based on those skill sets. That's the first one. Secondly, most of the data science roles are often done by referrals. So find people who are working in a particular organization, and because it's very hard to evaluate a data scientist simply by looking at the paper. So if you know someone personally, it's much easier. So try to find someone who's working in a particular organization. They can vouch for you and they can bring you along. So that's the other thing. So once, let's say, your profile is shortlisted, and shortlisting of a profile would not just depend on putting random tool stack in your profile, but also on the work that you've done. So to evaluate what kind of work that you've done, you would have a hands-on session, right? A hands-on session essentially is a session that is generally conducted to ensure that you are, or you have those skills that you claim that you have, right? For example, if you claim that you're very good with Python, then you better prove it. So platforms like Codility, Hacker Earth, and there are many tools, right, that are available, Codebase and things like that. So there are so many tools that are available, so many online platforms that are available that help us conduct online that give you online challenges, and you're expected to solve those problems, right? These problems can be of two types again, right? These challenges could be generally of two types. These hands-on sessions could be of two types. So one is, let's say, an on-site challenge. That means you're given, let's say, 3 to 8 hours, and you're expected to sit down there and solve the problem then and there, right in front of them. That's one way of solving it. The other is a take-home, or a particular, uh, what do you call it, or a particular project that is given to you for, let's say, a week or a few days, and then you're expected to solve that particular assignment, and then you're expected to come back and display or showcase your results. um, yeah. Am I audible now, Ajay? Yeah. Okay. So both these tools are quite important. I mean, both these approaches are quite useful in displaying your Python skills. um, for example, I'll tell you one of the interviews that I recently attended, and one of the things that they had set up was, it was an interview that essentially lasted for 8 rounds. And of course, it was for a senior role, so for a senior data scientist role. um, there are generally two kinds of, as I said, the two types of assignments that are generally given. One is a take home, and the other is an on-site challenge. I was given a take home assignment in this particular interview that I recently attended. I was given, so that particular assignment lasted for 2 hours. Even in this particular assignment, I was given, and this is a general framework of how interviews are conducted. So we were generally given either a data science problem, which basically means is a data set is given to you, a problem statement is given, just like Kaggle, right? If you remember Kaggle, if you're familiar with Kaggle as a framework, just like Kaggle, you're given a data set, you're given a piece of data and a problem statement. You're expected to go ahead and build a model and showcase your results in your and you're expected to showcase your results in, let's say, um, a Jupyter notebook, or you're expected to present these results in that particular Jupyter notebook, right? Um, that's one kind of a test. So this test could last around, let's say, 2 hours to 8 hours, depending upon, again, problem to problem. A certain assignments, for example, in one of the very early experiences of mine, I was given an assignment which expected me to, let's say, go ahead and code a decision tree algorithm from ground up. That means I was not allowed to use any code whatsoever, any library whatsoever. I was expected to write a decision tree algorithm in pure code, in pure Python code, uh, and uh, and yeah, I mean, I was given 1 week time, and I was expected to go ahead and solve this and come back. So there are different kinds of problem statements that are generally given. At times, these hands-on sessions could also go to the extent of giving you a coding challenge. Like, for example, you're given a small algorithm, and you're expected to write that algorithm. Right? Let's say top coder, or let's say code chef. These are tools that generally test you on your algorithmic and data structure skills. These tests could also go in that direction. So expect a hands-on session that's generally the name of the game these days. Most companies have a hands-on session these days. Without a hands-on session, irrespective of the experience you have, people are not hiring without a hands-on session. For it will definitely apply to freshers. Yes, freshers. The one thing that people expect from freshers is coding skills. So if you are, and one of the reasons why people hire freshers is because you are good with your is because you're good with your coding skills. So definitely a hands-on session is conducted for freshers, not only for experienced people, even for freshers the hands-on sessions are conducted. So get ready for it. Get ready to experience that. That's the first thing. um, it is a very good place to showcase your skills, right? So go the extra mile, do whatever you can to do whatever, I mean, make sure that you display as much variety as possible in your skill set to solve your solve problems during this particular thing. Also at times expect SQL based questions as well, right? SQL based questions, meaning you will be given a virtual platform where you're expected to write some SQL from some SQL queries. They'll give you some two tables and you're expected to solve that particular problem using those SQL queries. Write some SQL queries to either, let's say, merge data or do things like that, join data, or perform some kind of transformations on top of data and things like that, right? So that's as far as the hands-on session is concerned, hands-on round is concerned, and this is evaluated. Remember, this is not evaluated by the HR. This is evaluated by a data scientist. So a data scientist is going to sit there and he's going to look at these results and he's going to come back and tell you if you're selected or not based on this particular hands-on session. So understand that. Try to give your best in your hands-on session because this is a make or a break. If you don't clear the hands-on session, then there's no way you're going through. So make sure you write comments very well. You have to add as many comments as you can, and give enough explanation about why you've done a particular step. Don't just randomly put code in the Jupyter notebook. Make sure you add enough comments or enough doc strings that you leave within the functions that you write and things like that. Okay, that's as far as the hands-on session is concerned. Once you clear the hands-on session, right? If you've cleared the hands-on session, then pat yourself on the back. That means you've done a good job, right? So
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
but before you even enjoy you clearing the hands-on session, you will have a lineup of technical interviews. Now, the technical interviews could be done generally. Now, in my organization, we have two to three technical interviews. Depends from company to company again. So, for example, Amazon would have 3 to 4 technical rounds of interviews. Microsoft has 2 to 3 different interviews. So we have 2 to 3 technical interviews depending upon the candidate again. So the first interview could be a simpler round where one of the team members or senior team members could be interviewing you. And it is going to be a data scientist who will interview. So they're going to be hardcore technical questions. And I'll talk about how and what kind of questions are going to be asked to you in the next section. When I talk about the questions, I'll ask you about them there. I'll tell you about the kind of questions that you're likely to be asked as we move forward. The next round is also generally by a technical person. It could be a data science team manager. I was interviewed by data science team managers from various different locations. So I was interviewing for a particular location. I had different data science managers coming in from different locations to interview me. I was, let's say you also, let's say you clear these rounds as well, then the next round is generally by the org lead, the head of that particular organization, vice president. The interviews that are generally conducted by the product owners, or let's say principals, partners, or delivery heads or vice presidents, they are very business oriented. right? These are not technical rounds. These are non-technical rounds, but based on data science, where they are going to test you on um, they're going to test you on your business acumen. How well do you understand businesses? How well can you translate a business problem into a data science problem? Again, these rounds will depend on the role that you're applying for. So let's say, for example, you're applying for a consulting role, then you would be then you would be interviewed by, let's say, a partner or a principal, or let's say a practice lead for that matter. If you're interviewing for, let's say, a product division, product company, then you would be interviewed by a technical manager and, let's say, a product sponsor or a product owner, because they want to make sure that you have enough capability to solve that particular problem. Again, the depth of interviews may depend from one company to another company, but essentially get ready for at least 4 to 5 rounds of interviews on an average. I'm talking about on average in a fairly reputed industry, MNC, gear up for 4 to 5 different rounds of interviews. At this particular point, what we are seeing is, of course, more or less all the companies do have a ban on hiring given the COVID situation. But in general, what we generally see is we prefer conducting these sessions face to face as much as we can. If not possible, of course, we do some preliminary rounds in telephonic, and then so R1 can be conducted. The first technical round may be conducted as a telephonic round, but eventually the person is called upon because you'd want to have a face-to-face interview. So face-to-face is generally preferred, at least for the later parts of interviews. Face-to-face interviews are generally preferred. So that's generally the layout of how your interviews would be conducted. Expect a hands-on session, expect a couple of, expect at least 2 or 3 technical rounds, and expect one hiring manager or a lead, a vertical head or a vertical lead delivery head, sort of a person who will ask, who will be taking your interview. So yeah, I mean, for example, Amazon by default has around 8 rounds of interview, with respect to the role that you're attending. But in general data science, yeah, you're looking at around 4 to 5 different rounds. I was, yeah, I applied for a strategy consulting company a few years ago, and I had 8 rounds of interview there as well. So there was different people who were being called upon, different people who were asking me questions. But I think it's good in a way because it gets you the flavor of what they want from you and things like that. So yeah, that's essentially the layout of how your interview generally looks like. But I think the more important question is, what kind of questions do these guys ask, right? In a technical round, what kind of questions are generally being thrown at you, would be thrown at you. So in a technical round, the type of questions that are generally asked is, again, I could probably break this down into 3 different categories. I don't know, 3 seems to be the number of the day, but 3 broad categories. The first one, of course, is questions based on any previous experience that you have. See, as a data scientist, because all of you are fresh in the industry, it's unlikely that you would have, because all of you are moving into the industry for the first time. As a data scientist, as an interviewer, I would be searching for some common grounds to ask a question at you, right? If you simply come and put your past experience and tell me that I've done a course in data science and I like to move into the field of data science, it's unlikely you will get hired. I mean, it's unlikely that you will find people who will be interested in you. So you have to find some common grounds between yourself and the interviewer. And the way you could do that is by putting some kind of data science experience in place. What kind of experience do you put in? Let's say you've solved a Kaggle problem. That's also some kind of data science work experience. Of course, it's not quote unquote official work experience, but it is definitely some work that you've done in the field of data science. So it gives the opportunity for your interviewer to ask you questions on. That's the first thing. Secondly, if let's say you've done any project in your course, you've done a course, let's say you've done some capstone projects, so let's say you've done any kind of projects in your course, or you've done a side project, that could come in handy as well. So Kaggle projects, or let's say some capstone projects that you've done in your class, within your course, or let's say any kind of data science solutions that you, let's say, were a part of in your previous organization, but you of course were not actually doing the data science, but let's say you're a part of a data science team, and if you could quote some data science work that you could have possibly done in your previous organization in the data science team, then that could come in very handy, because that could prove very useful to that could prove very useful in terms of at least establishing some common ground between yourself and the interviewer. You don't want to randomly put something. So let's say you solved a Kaggle problem, right? That gives some scope for the interviewer to ask questions on. Okay, so if they see that, okay, you solved a couple of Kaggle problems, mind you, people um, you know like Kaggle problems, right? Trust me. Most people prefer people having some kind of experience. It's not that you would randomly um, it's not that it, you'd want to have some experience before you actually attend an interview, and Kaggle problems, people do recognize that as valid experience. um, so let's say you solve a particular Kaggle problem. What kind of questions can you expect from those? You will be asked about what kind of steps did you perform, what kind of let's say, what was the problem statement about, why are you solving that particular problem, what is the business impact of solving that particular problem. And you will have questions about what kind of pre-processing did you do, what kind of model did you build, how did you evaluate your model, why did you only evaluate your model in that particular fashion, why could you not have used another kind of evaluation technique, and things like that. So there could be other questions, there could be a laundry list of questions that could be shot at you, but all of them could more or less be based on the work that you have previously done. So that's the first category of questions that you could be asked. The second category is pure play technical questions. Out of the blue, they might throw some question at you saying, how do you build a decision tree algorithm? Explain a decision tree algorithm ground up, right? Don't expect these questions to be completely vague. They will still be relevant to the work that you would have more or less done, but pure play technical questions, right? The third is scenario based questions, meaning the interviewer might give you a particular scenario or a case study, and he would then ask you to go ahead and give you design a data science solution or data science problem around this particular problem statement, and tell me how you will solve this particular problem. So you'll be given a scenario, and you're expected to sit down then and there, solve this particular problem, solution it right at that particular point in time. These would be real-time scenarios. Absolutely, yes. These could be real-time. It could be hypothetical as well. But in general, most of the questions that are generally asked are real-world scenarios. Yeah. Then that'll be tough to. Absolutely, yes. I mean, that's the whole point of an interview. The questions, it doesn't matter if you don't answer it. What we're looking for is, do you have the ability um, to at least approach the problem in that particular direction. We don't expect you to, as an interviewer, you're not expected to be spot on with a candidate, you're not expected to be spot on with your answer. You expect some guidance by the interviewer as well. They'll guide you through your solution, because even in a real world scenario, it is not one person who sits and designs a solution. It will be multiple people who will sit down and design a particular solution. So you are essentially starting the problem in a particular direction. You're expected to solve it, or rather design it in a certain way, and then we can talk about it. I'll give you an example. When in the next slide, I'll give you an example of what kind of problems are generally asked, what kind of case studies are generally asked. I can give you a couple of examples from the interviews that I've attended previously, or I've taken, with the kind of interviews that I have asked, the kind of case studies that I have asked in my previous interviews. I'll give you those as well. Yes. So these are the three types of questions that you could expect. One is questions based on your previous expertise or experience, case study based questions, and pure technical questions, pure play technical questions that could be asked. Let's talk about what kind of questions do they ask, right? So here's some tricks of the trade. So I'm as an insider, I'm giving you some inside dope about what kind of questions are generally asked. Okay, as an interviewer, these are the questions that I generally ask. always remember this one thing, that data science as a field is a vast field, is a large field. It's and all data scientists understand it, right? Data scientist as a field is so large that there are so many sub fields inside the field of inside the subject of data science. Somebody becomes a computer vision analyst, or computer vision specialist, or computer vision scientist. Somebody becomes a natural language processing scientist. Somebody is a machine learning specialist who strictly works on machine learning. So they're different pieces of work that people specialize in as they move forward in their careers. So you are not expected to be a master of all. So hence, as a result, what happens is most of the data science interviews are based on the work that you have previously done, right? Most of the data science interviews are based on two things: the work that you have previously done and the kind of role that you're interviewing for. What that means is, because the field of data science is so large, if I were to ask you a question, it will be unfair if I ask you a question on something that you have not worked on previously. Because if you ask the interviewer a question that he has not worked on, he will not be able to answer himself, because the field is so new, the field is so evolving, uh, the field is rapidly changing in active research. Hence, that's one of the reasons why people prefer asking questions from your previous experience. The second is, and it's a general um, and it's a general sentiment. The first line that first two lines that I've mentioned is a general sentiment of any interviewer. Trust me on it. I've interviewed so many candidates, and I have seen so many people interviewing candidates. I have attended interviews myself, so I understand that the first two lines are absolutely true. In most cases, in 90% of the cases, there are always that 10% of category uh, who who find some kind of happiness in interviewing someone and making their life difficult. So I'm not talking about those 5-10%. I'm talking about the generic crowd. For the second type of questions will be based on the role that you're interviewing for. So let's say you're interviewing for a strategy consulting company, or let's say you're interviewing for a technical consulting company, technology consulting company, like let's say Accenture. You're interviewing for Accenture. So your questions will be primary. The questions that you will be asked will be based on, okay, you will be working with a client. So how will you explain a linear regression model to a client, right? How will you explain the output of a logistic regression model to an end customer? Let's say you will be presenting to a vice president of a particular organization. You're working with a particular client. You'll be presenting your results to the vice president of a particular organization, to that particular client of yours. How will you explain? You've built a logistic regression model. How will you explain the coefficients of a logistic regression model to your end customer, right? So the coefficients of a logistic regression model, how will you explain it to to the end client? How will you explain the coefficients of a linear regression model? How will you explain a decision tree? If you were to explain, this was a question that was asked to me. If you were to explain a decision tree in layman terms to to someone who does not understand data science at all, how will you explain data science to a complete layman, to a complete layperson who doesn't know anything about data science? How will you explain it to him or her, right? Because you will be talking data science to such people. Because you're in a consulting company, you will be talking to people who don't understand data science. So you will be in situations where you will be you will be asked to explain these complex algorithms in a very, very simple form to someone who doesn't understand data science. Or how do you explain a confusion matrix to a complete layperson, right? So communication skills are super important, and these specific questions these specific questions will be asked to you whenever you're talking about questions based on roles. So two categories of questions. Of course, these are uh, different types of queries that could be asked, but I think all these queries will be filtered by your previous experience, and technical questions or non-technical questions based on the role. I think it's better I mention it that way. Technical questions based on the role you've applied for. So that's how your questions can be primarily categorized into. So those 2 points that I mentioned over there are really, really important. So keep that in your mind. So don't worry if you don't know something. Say a no. You don't have to dump your profile with all the possible keywords in the world. You don't need to do that. I understand most of us do it for to make sure that our profile gets shortlisted. But I think you have to understand that it's not. People, interviewers do understand that it's not possible for one guy to have an experience on every possible thing on the planet. So it's okay if you do not know. If you have not worked on NLP, you have not worked on NLP. It's okay. If you've not worked on computer vision, you've not worked on computer vision. That's okay. But at least you should know the basics of natural language processing or text processing. You should know the basics of computer vision, basics of how a simple deep learning model works on images and things like that. So you should be able to explain the basics of it. So when you talk about your previous project, let's say you've done some project, or let's say you've done some previous work, what kind of questions can you expect? Let's take an example. Let's say you have solved a particular classification algorithm to predict will a particular person churn out from a telecom company or not. A very, very classic problem that any telecom company would be ideally solving, right? Predicting churn, right? That's what we call it. So let's take this example. Okay, so when you predict churn prediction, when you predict churn, let's say you've done this as one of your previous problems, or let's say you've solved this as one of your one of your Kaggle problems, right? Kaggle also has a lot of such problems. So you can go back to Kaggle and then solve any of these problems. Let's say you're trying to predict churn. What is churn? Anyone who understands what churn is? Churn is basically the probability, or churn is that particular behavior of a customer when he or she quits a particular service provider and moves on to another service provider. So for example, you've quit AT&T and you move to Verizon, or you quit Jio and you move to Airtel. Such kind of an exercise is typically referred to as churn. It's not only in telecom, it is applicable to any competing platform, right? So for example, you are a customer of let's say a particular insurance provider. You quit that insurance provider and you're moving into another insurance provider. So that is churning of a customer. What you're trying to predict is, you're trying to predict based on the behavior of a particular customer, you're trying to predict will the customer churn out or not. A nice classification problem, right? So the questions that you can expect here are, first things first, why are you solving this problem? Why are you predicting churn? Why is predicting churn important for the business? Why is predicting churn important for the business? The reason why predicting churn is important for the business is because it helps me identify what are the possible, it helps me identify which customers are likely to quit. Hence, even before they actually quit, I can reach out to them and I can do some kind of intervention. I can provide some kind of intervention and stop them from quitting. So for example, if a person chooses to quit, let's say Jio and join Airtel, or quit AT&T and join Verizon, then I can, as AT&T, what I can do is I can intervene in between, and I can tell that, okay, sir, looks like you've decided to quit. Is it okay if we'd like to provide you an offer, and we'd like to retain you as a customer, and because you're one of our loyal customers, we'd like to give you an offer, and the offer is, let's say I give you a $20 discount over the next X number of months, or let's say I give you free free voicemail services for the next X number of months, or let's say I give you free 1 GB internet per day for the next X number of months. So I give him some offer, right, to retain him. So predicting churn is really important because it helps me. I predict which customers are likely to quit and stop them from leaving, or try to at least stop them from leaving. Right, intervene, provide some kind of intervention strategy. The second reason why I'd like to predict churn is because currently, for a company like AT&T, the churn rate is at around 6%. 6% churn rate is very, very high, and one of the primary objectives of the organization is to increase the customer base, which means we have to make sure that the number of customers quitting should reduce. So how do we do that? By making sure we stop people from leaving, or predicting even before they could possibly leave, right? These are two possible reasons why I might want to predict churn. Okay, one, I know that it's a big business problem, high impact business problem. Second, I know that the reason why I'd want to predict churn is because it is a part of my business charter. It's that's how my business wants to operate. So, okay, business explanation provided, and you can drill deep into it. I mean, if you know more about that particular problem, you can dig deeper into that particular problem. Great. Okay, that's the reason why you'd want to predict churn. So the next question is, how did you go ahead and prepare your data, and what kind of data was available with you? Great. So I am in a telecom company, right? So let's say I'm in a part of the telecom company. This is telecom customer, let's say. The kind of data that we had brainstormed to identify what factors could influence churn are as follows. The first one is billing reasons. The most important reason why customers quit in telecom company is because of billing. High bills, greater chances of quitting generally, right? Sudden spike, billing information was available. I know previous history about the customer, customer care information, meaning how many times has the person reached out to the customer care and things like that. Some kind of demography involves age, location, and things like that. So for example, people who are 60 years old, 55 years old, the likelihood that they would quit will be very, very low, right? Because by now they're like, oh, take care. I mean, it doesn't matter. If I'm spending 500 rupees a month on my telecom, it's okay. They probably reached that particular stage where they don't worry too much. But a 20-year-old or a 16-year-old who is having a mobile phone, 500 rupees a month is very, very expensive for him or her, because they are not earning as yet. So the likelihood of somebody quitting is much higher in a lower age group than in a higher age group, obviously, right? So demography is really critical. In addition to this, we have also taken into account, let's say, his current plan information, what kind of plan is available, some kind of competitor information, and things like that. So on and so forth. This is the kind of data that we've taken into account, right? So at this particular point, you could be asked questions saying, okay, don't you think the order information about or value added services that are being used by these customers are important in predicting churn? Meaning value added services are like, let's say, voicemail. Value added services could be, let's say, missed call alerts and things like that. So don't you think those are important in predicting churn? Or maybe they are. If somebody does not use a lot of value added services, they are not making the most out of the company. So they probably do not have enough loyalty towards that particular company, right? And hence they might want to quit, right? So you might also want to use information about what kind of tickets were raised in the customer care. Don't you think tickets information is important? So you could have questions like these. What kind of data was used? This is the kind of data that was used. Okay. The next question could be, how did you prepare your data? What was the data preparation that you had to do? Great. So the way we prepared our data is, we had to do some data pre-processing. For example, our demographic data had some missing values. We had some erratic data points, like for example, there were data points which had age which is greater than 100, 101, 120. So some outlier removal was done, some missing value imputation was done, some scaling was performed to a few features, some additional features, some feature engineering was performed. Feature engineering meaning some new features were extracted from my data and things like that. So that's how we prepared our data. Our data set had a few, eventually I created my data which had X and Y, where X had all my independent features and Y was my dependent features. Now the question could be, what was the size of the data, and why did you, and how did you go about solving this particular data? this particular problem. So currently your question is, okay, let's say at this particular point I had 1 million records. My x's were 1 million, and my size of my data set was 1 million, and my x and y put together had a size of 1 million. I split this data into two parts, which was train and test, 60 and let's say 60% and 40%, or 70% and 30%. However, I used my train set to build my model and evaluated it on my test set. Great. At this point, you might have asked another question: why could have you also performed cross validation? Why did you not perform cross validation? Well, cross validation could have also been performed. Yeah, I mean, I probably missed out on that. Maybe we should have performed cross validation here. So at that moment, you might be asked questions about what is cross validation, right? How is cross validation different from train test split? What is the benefit of using cross validation, right? You'll be asked questions like that. You could also be asked questions on uh, you've performed outlier removal. Explain what an outlier is. What is an outlier, anyone? An outlier is a point that behaves erratically from the rest of the data points, right? So you would want to identify, okay, how do you identify outlier? How do you identify a particular outlier? Boxplot is not the only way of identifying outlier. Of course, Boxplot is one way of doing it. You could also do it via, let's say, you could simply use a simple terminology of your histogram. You can plot a histogram, and you could also visualize on either side. Or let's say you can look at mean plus or minus 3 standard deviations from the mean. Mean plus or minus 3 standard deviations. Any point which is less than 3 standard deviations from the mean and greater than 3 standard deviations from the mean are considered as outliers. Mean plus or minus 3 sigma, or z-score. Exactly, you could use z-score to identify it. So things like that. So these are different ways of evaluating a particular removing outliers. How do you fill missing values? Why did you fill missing values? Should you fill missing values or not? I mean, if let's say your data set has 20% of missing data, what do you do? Or if your particular column has 30% missing values, what do you do? Do you fill missing values? Let's say there's a column and the 30% of the data is missing. What do you do? Fill it with mean. Okay. If 30% of the data is missing, would you still go ahead and fill it with mean? Think of it. Yes. Okay. Interesting. Okay. Yeah. So generally, when you have more than 30% of the data missing, I would do two. I would think of two things. One, do I have enough data points? Do I have enough data points or enough records, enough observations in my data, enough rows in my data to remove those 30% of the rows? Right. So if I remove 30% of data, let's say I have 1 million observations. If I remove 30%, it's okay. I still have 70,000 records, or let's say 700,000 records available with me. So I might, in that case, remove rows. Right? But if my data itself is very small, let's say just 20,000 observations, if I remove 30% of it, then I'm losing a significant chunk of my data. I'm losing around 6,000 records out of 20,000, which is a huge dent to my data size. So in that case, I might want to decide and say, okay, let me drop the column. Worst case, I might go ahead and fill missing values. Filling it with mean, median, mode. I might only do it in worst case scenario. I might not do it always, right? So that's probably the last approach that you'd want to follow to fill missing values, because filling missing values essentially means you are speculating on the data. That means you are filling with values that are actually not a part of the data. So you don't want to speculate too much about a given data set. So that's the reason you wouldn't want to fill too many missing values. The point that I'm trying to drive here is every statement you make, you will be double clicked at that. Meaning, if you say that I have filled missing values, you'll be asked, you could be asked what kind of imputation techniques do you know of, right? How do you why should you fill it with mean? Why not with median? When do you fill with mean? When do you fill with median? The questions like these will be asked. So when you build a train test, when you build a model, then the question could be, what kind of model did you build? Did you do even before did you directly jump to model building, or did you do any kind of data visualization? Did you do any kind of exploratory analysis? So you could be asked questions like these. Let's say if you say that, okay, yes, I've done the exploratory analysis. The questions could be, what kind of exploratory analysis have you done? Okay, the kind of exploratory analysis that I've done can be categorized into two parts. One is univariate and multivariate analysis. Univariate analysis is analyzing single variable at a particular time. Analyzing multivariate analysis and analyzing multiple variables at a given time, meaning histograms are univariate charts. Your correlation is a multivariate analysis. Your scatter plots are multivariate analysis, and so on and so forth. So you would want to mention that I've done univariate and multivariate charts. So the question could be, what findings did you see from your univariate and bivariate chart? From my bivariate charts, that I've understood that age and churn rate are negatively dependent on each other. That means higher the age, lower the chances of somebody churning. That's something which we have recognized. Secondly, what we've also identified is higher the age and bill amount seem to be negatively correlated with each other. That's another thing that we've identified as well. And what we've also identified is churn is heavily dependent on the location. That means certain specific areas, they seem to have a high churn rate as opposed to other localities. Okay, so you essentially mentioned the insights that you've generated from your exploratory analysis step. Once you've done your exploratory analysis, the next step is, okay, now you've done your exploratory analysis, so what have you done next? We went ahead and we performed model building. So when you build, what kind of model did you build? Let's say you mentioned that I have built a random forest model. The question straight away would be, why did you not try logistic regression? Why did you go for a random forest model? So you have to be careful when you mention these. Always clearly explain the experimentation that you have done, that you have performed. So you can simply say that, okay, first I've built a logistic regression model. My model was not doing great, hence I tried a random forest model. Immediately the next question would be, how do you know that your model is not performing well? Okay, to know that, so because this is a classification problem, I had to evaluate my model based on confusion matrix. Straight, the next question is, what is confusion matrix?
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Right, so almost every step you will be asked a question. So rehearse this story very well, right? If you're putting a particular problem statement within your analysis, within your profile, if you're saying that I've solved so and so particular problem previously, then make sure that you have a that you've done this analysis really very well. That means at every step you should be able to explain what you have done, right? At least to some level of clarity, you should be able to explain what kind of pre-processing have you done, what kind of exploratory analysis have you done, what kind of model building did you do, how did you evaluate your model, was precision important or was recall important, right? Between precision and recall, how do you differentiate between precision and recall? When is F1 score needed, right?
Just a quick info, guys. Intellipaat provides online data science master program in partnership with IBM. The course link of which is given in the description below. Now, let's continue the session.
See, for us interviewers, right, one of a simple litmus test to evaluate if a candidate is fit or not is based on your understanding around confusion matrix. If you understand confusion matrix well, then that's an indication that, okay, looks like you've been able to get a hang of things. If you haven't understood confusion matrix and if you're still claiming that you have learned data science, then I'm sorry, you probably not. Then that's a very clear indication that you could be sent back home. So if you're getting grilled on confusion matrix and if you're unable to answer questions in confusion matrix, my friends, trust me, go back and do good research on and spend some time on how confusion matrix works and understand how precision recall F1 scores are really work. right? So that's a nice way of identifying. It's a nice hack that we interviewers apply whenever we want to identify if a candidate is really good or not, right? So we question quite a bit about evaluation of models. So how do you, if confusion matrix is for if you use precision and recall for classification problems, then what do you use for regression models? What metrics do you use for regression models? So the answers could be, what kind of approaches do you use for regression models? What kind of measures do you use for regression model? MAE, exactly. MAE, MSE, RMSE. Spot on. Perfect. MAPE, the different metrics that you can use over here. Yeah, spot on. So that's how your interview conversation is going to go on. Especially here at this particular point, I've just mentioned a few questions here. I think it's worth for you all to go back, have a look at the slide, and prepare your problem or your project, or prepare yourself for answering these questions around the projects that you've done previously. So if you are claiming that you've done your project well, then make sure that you have answers to at least 80% of the questions here that you see on the screen. Okay. Especially, what is the most important thing? I mean, all the sections are really important, but one of the things that people often fail to understand. So, for example, if it's a Kaggle problem, for a Kaggle problem, you might only know the business problem. You might not know the business impact, so to say. That means if you solve a Kaggle problem, the Kaggle on a Kaggle platform, the problem statement would simply be mentioned, but you might not know what would be the impact of solving this particular solution. That means you solved a churn prediction problem, but you wouldn't know what is the business impact of that particular problem, right? So that's one of the things that you have to keep in your mind. So it's okay if you don't know a lot about it, but at least what you should definitely be able to talk about is what else you have done as a part of your as a part of your solution. The other thing is, if this is an open source problem, I mean, it's a problem that you've done on Kaggle or something like that, then put it up on your GitHub profile online. Use your online GitHub profile and put content there. Put a notebook or put your code that you've done and put it up there for everybody to consume. Let everybody use it. I think it's a nice. I mean, you can put a GitHub profile in your resume as well. That way, you can draw a little more eyes. You can add more credibility to the work that you have done. So while some interview is being taking place, somebody might just go to your GitHub profile and actually view what you've done in your GitHub profile. It helps. Um, it helps identify how well have you solved, yeah, or how well have you written your code. Yeah, the most frequent kind of problems that are solved are supervised learning problems. Reinforcement learning sounds cool, but it's not an easy technique to use. So not a lot of problems that we solve in the modern day and at this particular point are belong to the reinforcement learning bucket. I would say 80% or rather 60%, 60 to 70% of the problems that we solve are primarily supervised learning problems. There could be a few that are, I mean, there are of course that 30%, 35% of the problems which are unsupervised learning. The rest 2 to 3% problems are your reinforcement learning problems. So I think if you were to, I think if you were to prepare yourself for a data science interview, it's worth spending your time on supervised and unsupervised learning than reinforcement learning. You spend majority of your time on supervised and unsupervised learning. Yeah. Apart from the hands-on round, all are basically from project we have done, more or less. Yeah. Apart from the hands-on round, most of the questions that you would be asked will be on the projects that you've done previously. Majority of the grilling will happen in that direction only. You could also be asked questions based on scenarios. That means you would be given a particular problem statement on the fly. You're expected to solve it. I mean, solve it in the sense you're expected to answer questions on it. But apart from that case study or scenario based questions, majority of the questions will be based on will be based on your project based questions only, and I'll talk about scenario based questions in a few minutes. Okay, how to explain a person who does not know data science concepts? Yes. Okay, so let's take the example of linear regression, right? And I'll give you an example of one model, and I'd like you to look at every other model in the same fashion. Let's take the example of linear regression. A linear regression model, let's say you've built a model which has information like this, right, which says sales is equal to a linear regression equation. Let's say your problem statement is a ballpoint pen manufacturing company would like to predict the sales of that particular company in a given region, right? Predict sales of a ballpoint pen manufacturing company in a particular region. So there are many regions, and I'd like to predict what the sales of that particular what the sales will be based on that particular region. So let's say you've collected your data and then you solve your problem, and your equation looks like this. So sales is equal to 40 plus. You found your linear regression equation like this. I hope you all understand how to create this particular equation. In Python you can use your linear regression model, or in R you could use the LM function. So there are different functions that will help us build this particular equation based on historical data. So you have 40 plus, let's say 10 times money spent on ads minus, let's say 5 times number of competitors in that particular region plus I don't know what else could, so plus 6 times number of stores where we sell our pens. So my sales at this particular point is dependent in this particular, using this particular equation. Now the question is, how do I explain this to someone who does not understand linear regression? It's very simple actually. So what we're saying is, for a unit increase in ad revenue, so if my ad revenue increases, or ad budget increases by $1, right? The money spent on ads increases by $1. My sales, would it be positively impacted or negatively impacted? The way I would interpret it is, because this is 10 and this is positive 10, it would be positively impacted. Hence, if my ad budget goes up by $1, then my sales would also go up by $10. 10 units, whatever, $10 or 10 units, whatever, positively dependent. So if my ads go up by $1, my sales goes up by $10. Why did I say 10? Because the 10 is mentioned here, correct? So you don't have to mention to the business about this particular equation. You don't have to talk about this equation. That's okay. I mean, if they want to look at, if they want to talk about the equation, if they were interested in the equation, that's a different story. I think the way you'd want to tell it to someone who doesn't understand data science is, historically we have analyzed data related to money spent on ads, the number of competitors in a given region, and the number of stores in a given region, and we were able to mathematically model how the sales are associated, or how the sales are dependent on these three features. A few key insights are, first one, as the ads increase, or rather as the number of ads increase by, if the ads revenue or ads budget increases by $1, that means the money spent on ads, if it goes up by $1, then my sales go up by $10. If the number of stores increases by one unit, then my sales increases by $6, or 6 units, whatever those units are. And if the number of competitor increase, if one additional competitor is added in that particular group, then in that particular region, then our sales drops by 5 units. So this is essentially the kind of explanation that you'd like to give to someone who doesn't understand data science. You don't have to explain him that equation. You just have to explain how sales is related to ads, or how sales is related to competitors, and how sales is related to your number of stores. So that's how you explain it to someone who doesn't understand data science. So this is just an example of how you can explain it to data science. You can also do the same for, let's say, a decision tree algorithm, or let's say any other algorithm also, for that matter. Cool. So let's move on. Let's move on to the next part. So tricks of the trade. So this is what I was talking about. So there are numerous questions that you might want to be that you would be asked specifically based on the work that you're doing. The next type of questions, right, that you could generally be asked, as I mentioned, is your case study based questions. The case study based questions could basically be like these. Case study questions could be like, the interviewer would give you a particular scenario and you're expected to solve this particular problem. I don't want you all to answer the question. I'm going to give you a scenario and just think about it. I'll give you all a few minutes, just think about it, and then I will give you one possible way of solving this problem, and then you can evaluate if that is a good approach or not. Because if everybody is going to dump in approaches, then we might not be able to progress in the class. So think about a possible way to solve this particular problem. So the question goes this way. So imagine you are let's say you are Facebook, right? Let's say you're working for Facebook and as a team lead, and in your team you have a few openings. Okay, there are a few openings in your particular team, and you'd like to hire a few people, right? And because you're Facebook, one of the most popular companies outside, obviously you would receive a lot of applications, right? Let's say you've received 10,000 applications for the two roles that are open as data science. Let's say there's a data science roles only, just for the simplicity sake. So you have a team, and within your team you have two openings, or let's say one opening for that matter, and you'd want to fill that particular role. You have received a lot of applications for that particular role. Now, the thing about this particular role is that you would want to make sure that this particular role, or the person who is going to be hired in that role, is similar to the ones that are already there in the team. Let's say your team already has 20 people. You would want to make sure that the new person who will get hired is very, very similar to the existing 20 people in your team. Okay. Question is, how do you identify? Of course, you cannot interview 10,000 people. I mean, if you interview 10,000 people, you're going to die. I mean, there's no way you want to do it. So you are expected to build an algorithm, because again, you're a data science team lead. You're expected to build an algorithm that can automatically identify the best person, or the most eligible people out of the 10,000, or the 5 most eligible people out of the 10,000 people, so that you can go ahead and interview them. Okay, that's the question. I'll repeat myself again. There are 10,000 people who have applied for a particular role in your company. You'd want to fill that particular role if and only in such a way that that person who's going to get hired out of the 10,000 is very similar to the ones who are there in your group already, who are available in your group of in your company already, in your team already, let's say. So the question is, how do you hire this person? There's no way you can interview, because if you're interviewing, then you'll have to interview 10,000 people. So if you're going to interview each of the 10,000, then you'll never be able to hire that person. So your responsibility is to devise an algorithm to automatically shrink the size of people you'd want to interview. I'd want to identify 5 most frequent, 5 similar people. Imagine I have my data like this, right? Let's say there are a lot of data. So this is my team, and I have 20 people in this team, and I have opening for 1 person, right? I have one opening. For this particular team, I have a lot of information about my existing team. So I have information about location, where they come from, skill set. I have information about their experience, right? Their likes, their dislikes, and things like that. Because the reason why I want to hire a similar person is because I want him to be a perfect fit in the team. I don't want this fellow to be an alien in the team. So that's the reason I want to make sure this fellow is a perfect cultural fit within the team. Okay, so I've captured all of this information: location of the person, the skill of the person, previous experience of that particular person, his likes, his dislikes, and so on and so forth. Similarly, for the 10,000 applicants that I have the same exact information with me, right? The same exact information I've captured. So location, skill set, experience, likes and dislikes, right? Location, skill, experience, likes and dislikes. The same information is available on both sides. Question is, how do you identify out of the 10K those 5 people who are going to be interviewed for this particular role? Think about it. I'm not in a hurry, uh, unless you are, but I'll give you like a couple of minutes. Think about it. Think about how you're going to solve it. Yeah, and of course this is the data science interview, so think of data science approaches to solve this problem. Right. So use data science techniques. Think of what kind of data science techniques can you use to solve this particular problem. Filter on experience required and skill sets. Yeah, I mean, I have 20 people within my team, so I want to find someone who's similar. I just don't want to filter someone on skill set and experience. I have likes, I have dislikes, I have location, I have, let's say, a lot of other information as well. It's not just on list on this. Since it's categorical data, we go for classification problems since we have historical data to compare. What is categorical data? Where is my target variable here? Think of, okay, here are a few questions. Where is my target variable? Do I have a target variable? Regression model. What is my target variable here? Why is years of experience a target variable? Okay. Think about it. I mean, you're not in a hurry. Think about it. So firstly, think of, do I have a target variable? Is this a classification problem, or is this a supervised or unsupervised learning problem? If it is supervised, then is it classification or regression? Take all the liberty that you want and devise a possible solution. Grouping and narrowing down to the data set. Okay. Appropriate person. Let's answer this question. Okay. So firstly, and by the way, this was a question that was asked to me in one of my earlier interviews. Trust me. So this is a real world problem that was, or a real interview question, so to say. This was asked, actually a similar problem was asked in 2 interviews of me. A similar problem, not the exact problem, a similar problem. Okay, let's answer this question. The first question is, first things first, the most obvious question is this a supervised learning problem or an unsupervised learning problem? This is a unsupervised learning problem. The reason is, I do not have any historical information about who was previously interviewed and if they got hired or rejected. I only have historical information on who got hired, because I know that those 20 people are there in my team. I know information about who got hired. That's all. I have no information whatsoever about who previously got interviewed and who have been rejected and who have been hired. Out of that, I only have partial information, which is I know the existing people in my team. So do I have a target variable here? Do I know what I'm chasing here? Unfortunately, no. I know that I want 2 people. I know that I want 5 people, let's say. But I don't have a target variable in my historical data that I can solve a problem for. I hope that everybody understands what that is. I hope everybody's clear with it. Right? I don't have a clear-cut target variable over here which says yes or no, hired, not hired. Do I have a historical data which says 10,000 applications or 20,000 applications historically? Out of the 20,000, 20 people got selected. The 980 people got rejected. Do I have a data set like that? In this problem statement, I don't. I just have 20 people who have been hired. I just have information about who have been hired. I have information about 10K applications which have come in for the remaining 5 people. So that's all that I have. Okay, so this is, unfortunately, this cannot be solved via a supervised learning problem. I can solve it via a supervised learning problem if I make an assumption, and the assumption is I will assume that if I assume that there is a data set that is available historically, which tells me to hire these 20 people who are there in my team, to hire these 20 people who are there in my team, how many have been hired and how many have been rejected? Right? How many have been interviewed and how many have been rejected? If I have that information, if I assume that that information is there, then I can solve this as a classification problem. Does that make sense? I hope we all understand that. So let's make that assumption. Let's solve this problem in both ways. Why reject one approach? Let's go and solve this as both problems. Okay. So let's make the assumption. The first assumption is, just a second. The first assumption is that there is a data set that is available. A data set is available which basically has information about, right? Let's say people who have been rejected. This is the list of interviewees. This is the list of people who have been interviewed and hired. I have a column which has this, right? Basically hired is these 20 people only, because these 20 people who are there. Hired means those are the 20 people that I have. If I have this kind of a data set, and if I have one column which says rejected or hired, I can build. So I have one column which says rejected or hired. Now tell me, is this a classification problem or a regression problem? If let's say this, and I can build a classification algorithm, I can take this new data that is available of 10K, run it through the classification model. Let's say I can use logistic regression model or decision tree classifier or random forest classifier or any of the classifiers. I can pass this new data set through it, and I can predict who is likely to be hired. Out of this, identify the people who are likely to be hired and interview those people. Make sense? Yeah, that's essentially one way of solving this problem. You can solve this as a supervised learning problem. That is if I assume that that is if I assume that a data set is available for me which looks like this, which gives me information about who has been hired and who have been rejected. On the other hand, we can also solve this problem in a slightly different way. We can solve this problem in as an unsupervised learning problem. How do you solve it as an unsupervised learning problem? The way you can solve this as an unsupervised learning problem is if assuming that you do not have this data. Let's assume that you don't have this data available with you. All that you have is you have the information of these 20 people and you have the 10,000 people with you, 10,000 applications that you have, and both are similar data sets. So what you do is, for the 20 people data set, this is 20 people, 20 people data set, right? Keep this data as is, right? For the remaining whatever, remaining 10,000, right? For the remaining 10,000, for the 20K, you compute a mean observation, or let's forget about that for a second. Let's not worry too much about the mean. So I have the 2020 records data, which is my current data set. For the 10,000 data set, you perform clustering on this. When you perform clustering, you're going to create groups. You'll create small groups. Now identify which of these groups is closest to the existing data points by using a nearest neighbor model, compute distance. You can compute the nearest neighbor distance, the Euclidean distance, or whatever distance, and you can measure which of these groups is closest to my existing 20 data points. Out of these, select whichever one you're interested in. Let's say group 5 is the closest to these 20 data points. And if group 5 is closest to the 20 data point, then use group 5 and interview everybody in group 5. If group 1 is the closest, then use group 1 and interview people on group 1, and so on and so forth. So that's another way of solving the same problem in an unsupervised approach. This is supervised and this is unsupervised. Two different approaches to solving the same problem. Okay, these are the kind of questions that you would be asked. There would be a scenario thrown at you and you're expected to answer that particular scenario. However, what is referred to as designing a particular experiment, designing a particular solution, a data science solution. So you could be asked questions like these. I'll just repeat the unsupervised learning approach just for the benefit of everyone. So you have 20 people. So for the 20 people, I'll simplify it. So for the 20 people, you compute a mean observation.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Can you can convert this whole thing into numeric data set? You compute mean experience, right? Mean skill set in Python, mean skill set in mean years of experience or mean years of skill set in, let's say, Python or whatever. You compute a mean observation, an average observation of this particular data set, a centroid. Think of it as a centroid. You compute the centroid of those of your 20 data points. Similarly, perform clustering here on the right hand side. Out of these, when you perform k-means clustering, you're going to get, let's say you've identified k clusters, you will find k centroids. Out of the k centroids, find which of these k centroids is closest to the centroid on the left hand side. The closest centroid or the closest cluster is what you will use to perform further interview process, or you will take that up for the further interview, because the closest cluster is what is similar to that of your 20 existing data points. Yeah. That's another way of solving the same problem. Hope that answers your question, Manohar. Okay. Cool. Moving on. So these are the kind of problems that are generally asked in the case study section of your interview. While these are a few, so I'm going to take the next is about and I think this is an important section as well. While the interviewer has all the right in the world to ask you questions, you also have good amount of questions that you'd want to ask your interviewer about. And I think the questions that you need to ask your interview are, especially on the data science side, are super critical. And I want to talk about that a little. The first is check about the team that you're getting into. Is it a new team or a matured team? Is there enough people? So because all of you are new, so if you are getting hired into a data science team where you're expected to lead, the complete team, or you are the only one in the team, then it might be slightly tricky for you to navigate yourself through it. So just look for enough guidance. So if you have somebody to guide you through the whole process, so if it's a slightly larger team, then there's enough. Then you'll have enough time to prepare yourself before you launch, or you'll have enough time to ramp up before you actually get completely onboarded onto the you where or you'll have enough people who would have solved problems already, so they'll help you guide yourself through and navigate yourself through. Secondly, what it tells is if it's an existing team, then things are slightly more streamlined. You're not going to be given random work for data entry and things like that. So you'll be given proper data science work. A new team means you're basically like a hero for them. So everybody would give you all kinds of problems, and you're expected to solve every possible problem under the roof. Becomes slightly difficult. The third thing is, if it is an existing team, that means the manager already understands what data science is, which makes your life easier, because if the manager understands what data science is, if the lead understands what data science is, then they're not going to give you a weird problem statements where neither you have data, and they're not going to give you they're not going to give you data sets and say build a model by end of the day. So they will understand the difficulties of a data scientist. So it is really important for you to know this, because in a lot of companies, a lot of data science managers are people who are not data scientists. They are people who are probably moved in from a non-technical background, or let's say people who are non-data science background into data science, and the reason that happens is because you got to fill roles, and the way you fill those roles in large organization is by moving people from within the organization. And at times you may have a manager who doesn't understand what data science is and who's expecting you to um, solve data science problems. So there are scenarios where something like this could happen. So be aware, understand, know about the team, right? Know about what your manager has done. Do your due diligence in terms of if your manager knows enough data science or not, right? That's the first thing. Second thing is availability of data, meaning data is like oxygen for us. For a data scientist, if you don't give him data and ask him to build a model, what would you do? It's as simple as tying down two legs of a dancer and asking him to dance. I mean, you can dance with the hand, but you know how it will look like, right? So you cannot do this to a data scientist. You cannot you cannot not provide data to a data scientist and ask him to work on it. So one of the questions that you might want to ask and want to verify is, do you have access to the data? At times the reason why this is important is because certain companies, what they do is they tell you that the data is confidential, especially banking and telecom companies. They tell you the data is really confidential and they cannot give you access to data. They'll give you some sample data and ask you to build models on it. And you know that when you build data on sample data, build models on sample data, models that you build may not be really great. So that could be quite challenging in itself. So availability of data could be at times slightly tricky. The third is, if you're working in a consulting company, you might want to check if you will have the ability to talk to clients, actually have discussions with the clients, meaning that in a consulting company, there's a lot of loss of information, or transmission losses, you can call it, because I don't know if you know of the game called Chinese Whisper, where a word is whispered in somebody's ear, and by the time it reaches the end of the classroom, the word completely changes its meaning. So what I mean to say is, especially when you're in the consulting environment, when you're in services environment, it is really important for a data scientist to be in the field and talk to the business stakeholders directly. It's not something that is, I mean, this opportunity is not something that is provided to freshers that often. I understand that. Freshers may not get the opportunity to directly talk to customers straight away, but being in an environment which directly operates with the customer is very, very useful. So you would want to be as close as possible to the environment, you'd want to be as close as possible to the business. You'd want to be as close as possible to um, um, not only the business, I mean, to the client themselves. If you are not given the opportunity, that's okay. At least if the team has the opportunity in general to interact with the client frequently, then that means there is a healthy conversation that is happening. That's something which is really important. So it's good to have that particular clarity for you. Third is check if your skills align. Check if the work aligns with your skills. That means, again, as I said, data scientists can have many subfields, right? Many subsections, meaning data scientists, data science in, let's say, a specific domain, data science in healthcare, data science in blah blah, and so on and so forth. So data scientists whose expertise is primarily into natural language processing, data scientists whose primary expertise is into image mining, data scientists whose primary expertise into statistics and things like that. So you have specifics at times, or at times work might demand a specific skill set from you. Like, for example, you're expected to work on only unstructured data. At times you might be expected to work on small volumes of data because you're probably working on clinical trials data and things like that. So see if your interest and if it aligns with the work, or if your skills align with the work or not. It is really important you check that, because there is a chance that people might misalign themselves to this, and you might not like the work that you do after you get into the org. But trust me, I would not suggest you to be so picky at the early stages of your career. At this point, I know half of you are like, any data science job is good job at this time. Absolutely agreed with you. I think at this point, any data science job is a good job. But in general, I think it's important that you know what kind of a data science role you'd want to get into, rather than cursing yourself for getting into that particular role. Know your stuff before you jump into it. The most important thing again is around designations, right? So this was somebody was asking me this point earlier. You would often find different designations on job portals. You would find data analyst, business analyst, data engineer, data platform engineer, big data engineer, data architect, big data architect, and so on and so forth. All these roles have little or have very little or almost nothing to do with data science. A few, of course, do. For example, data analyst is data analyst, and business analyst, and data consultant, and data engineer. They are all people who specialize with, especially let's say data analyst. You can consider data analyst as someone who's who does, in certain companies, the name data analyst is generally used to people who do data entry, right? Who basically look at data and fill data entry. In certain companies, the word data analyst is also about someone who does some kind of dashboarding, who looks at dashboards, and who performs some SQL querying, and does some kind of data dashboarding and builds reports and things like that. So that person is also called as a data analyst at times. Data analyst as a terminology is generally also used to someone who performs some kind of very preliminary root cause analysis, meaning looking at logs and then trying to understand what is happening inside logs, automatically trying to monitor logs continuously and seeing what the error is and things like that. So the work that a data analyst generally does is like slightly more manual in nature. Business analyst, on the other hand, again, the term business analyst is also very similar. A lot of companies have the term business analyst. Business analyst, program manager, business analyst is also similar to data analyst. They also do similar stuff. They do some basic dashboarding, charts, presentations to customers about products and things like that. So that's what business analysts also do. Data engineers, data platform engineers, big data engineers, these are all people who are responsible for, or big data architects, data architects are people who are all responsible for moving data from one place to another place. So they are responsible for ETL, extraction, transformation, and loading, right, of data. They don't generate insights. They are the ones who bring data to you. They bring the data and they store it somewhere. They do data pipelining, moving data from one place to another place, moving data from, let's say, application systems to, let's say, enterprise data warehouse. That's what they specialize in. Big data engineers or big data architects are people who work on large volumes of data and let's say build Hadoop clusters and move data continuously into Hadoop clusters and things like that. That's essentially what a big data engineer is all about. What you and I do is called as data science, and if you're looking out for profiles, look for the term data science in the role. In most cases, it is referred to as data scientist or machine learning scientist or machine learning engineer or AI specialist and things like that. So the roles that you might want to look for is data scientist, ML engineer is not our role. I mean, is not a pure play data science role. Not a pure data science role. Data scientist is a pure data science role, or let's say AI specialist or data science specialist. Or a ML machine learning specialist and things like that. So again, different companies have different names. I think we are 90% of the cases we're looking at data scientist as the name of the profile. Right? Data scientist, junior data scientist, senior data scientist, principal data scientist, and things like that, and data science lead, data science team manager, and things like that. So for freshers, you're looking at data scientist, junior data science roles, and for people who are slightly experienced, you're looking at data science or senior data science roles. I would not suggest you to get into a senior data science role, because senior data science role expects you to have prior experience in the field of data science. So senior data science role is a very tricky role. I mean, I know most of you might already have had experience in other IT sectors, but it's not probably directly possible to move into a senior data science role or a team lead data science. It's the general movement is moving into an individual contributor role, and then moving into data as a lead, or as a data science lead, or a data science manager. So irrespective of the amount of experience you have, I think personally it is suggested to move as a individual contributor, because you need to learn how data science works. If you move in as a manager, I don't think we will be able to gain enough respect from our team. I think you have to be hands-on as a data scientist to appreciate the work that your team does. So that's how I would suggest, and that's the general thing as well. Even in my org, I don't see people directly moving in as a manager from a completely random role. No, that's not that never happens. People who are actually eligible data scientists with good amount of experience become data science managers, or data science leads for that matter. Okay. So yeah, that's more or less it. I have a few resources for a couple of more questions that I've put down here. So feel free to look into those.
Now we have our second question over here. So on the same diamonds dataset, we are supposed to make a scatter plot between the price and the caret. And we are supposed to do that using the ggplot2 package. So over here, the price needs to be on the y-axis and the caret needs to be on the x-axis. So this column, it needs to be on the x-axis, and then we have price. This needs to be on the y-axis. And the color of the points need to be determined by the cut value. So again, let's head back to R and let's implement this. So again, to implement the scatter plot using ggplot, we are supposed to load the ggplot2 package. Alright, and this would be a command to make that particular scatter plot.
Just a quick info, guys. Intellipaat provides online data science master program in partnership with IBM. The course link of which is given in the description below. Now, let's continue the session.
So ggplot2 is something which is based on grammar of data visualization. So ggplot helps us to stack multiple layers on top of each other. So first off, we'll start with the data layer. On top of the data layer, we'll stack the aesthetics layer. And on top of the aesthetics layer, we'll stack the geometry layer. So first, we have the data layer, where we'll give the name of the data frame to this data attribute. And we are working with the diamonds data frame. So the first layer is diamonds. After that, we will map these columns onto the aesthetics. So using this aesthetics attribute inside this ggplot function, I will map this caret column to the x aesthetic, and similarly I will map this price column onto the y aesthetic. And as the question stated, the color of these points need to be determined by the cut column. So again, I'm reiterating it. Caret is mapped onto the x aesthetic, price is mapped onto the y aesthetic, and cut is mapped onto the color aesthetic. And once these two layers are done, we are supposed to build the final layer, which is basically the geometry. And since we are supposed to make a scatter plot, we'll be using the geom point geometry. And this gives us the required scatter plot. Let me zoom this. So as we see over here, price is mapped onto the y-axis, caret is mapped onto the x-axis. And these colors which you see, these basically denote the different cut values. So yellow, it denotes the ideal cut, and this purple which you see, that denotes the fair cut. So you see that if the cut is fair, then mostly the price of the diamond is higher and also the caret value is higher. And when it comes to the ideal cut, we see that the caret range of the ideal cut, it starts from 0 and it's mostly till 3 or 4. So this is the sort of interpretation which we can make from the scatter plot. And then we have our next question. So this time we are supposed to introduce 25% missing values in the iris data set and impute the sepal length column with the mean, and similarly impute the petal length column with the median. So this is the iris data set. So again, let's head back to our studio and perform these tasks. Let me have a glance at the iris dataset first. View of iris. So this is our iris dataset, which comprises of these 5 columns. So we have sepal length, sepal width, petal width, and species. And our first task is to introduce 25% missing values in this entire dataset, and that'll be totally random. And to introduce missing values, we'll be using the Miss Forest package. So let me load the Miss Forest package using the library function. Now, this Miss Forest package comprises of this prod any function. And using this prod any function, I'll be introducing 25% missing values. So, this basically takes in 2 parameters. First is the data frame or the object into which we are supposed to introduce missing values. The second parameter is the percentage of missing values that we'd want to introduce. So, in this iris data frame, we are supposed to introduce 25% missing values. So I'll give the value of 0.25 and I'll store this in a new object and name that object to be iris.mis. Now let me have a glance at this modified dataset. View of iris.mis. So this is a new data frame which comprises of 25% missing values. Now I'm supposed to impute this sepal length column with the mean and similarly this petal length column with the median. And to impute those 2 columns separately, I would require the HMISC package. So I'll load this package now. Library of HMISC. And this package comprises of the impute function, with the help of which I'll be imputing different columns. So first I'll use the width function, and this takes in 2 parameters. First is the data frame, which consists of missing values. So in this data frame, we are supposed to impute the missing values. So this is the iris.mis data frame, and this is the first parameter. Next, we'll use the impute function, and inside the impute function, again, it takes in 2 parameters. First is the column which we want to impute. Next is the function by which we want to impute this column. So I want to impute the missing values in the column with the mean of this column. So wherever you see any values in this column, all of those values would be replaced with the mean of this column. And I'll store the result back to this column, which is iris.mis $sepal length. I'll hit enter. Now let me have a glance at this imputed dataset. So view of iris.mis. So you see that wherever we had the any values, all of those values have been imputed with the mean. So this 5.85562 which you see, this is nothing but the mean. So initially there was an any value over here and that has been imputed with the mean. Similarly, there was an any value over here and that has been imputed with the mean of this column. Next, similarly, we are supposed to impute this column with the median of this column. So let us do that. So again, I'll use the width function and then pass in this data frame with the missing values. After that, I'll use the impute function and I am supposed to impute this petal length column, and the imputation would be done with the help of the median function. So wherever there are any values, all of those any values would be replaced with the median of this column, and the final result, I'll store it back to the same column. I'll hit enter. Now again, let me have a glance at the modified data frame. So view of iris.mis. So this is a modified data frame. So this 4.2 which you see, this is nothing but the median of this column, right? So wherever there were any values, those any values have been replaced with the median of the petal length. Now let's head on to the next question. So what do you understand by linear regression? Well, linear regression is a supervised learning algorithm which helps us in finding the linear relationship between 2 variables. So one is the predictor or the independent variable, and the other is the response or the dependent variable. So we try to understand how does the dependent variable change with the independent variable. So linear regression is a supervised learning algorithm which helps us in finding the linear relationship between 2 variables. So one is the predictor or the independent variable, and the other is the response or the dependent variable. and we try to understand how does the dependent variable change with the independent variable. So let's say there's this telecom company called as Neo, and now the data scientist at this company wants to understand if there's a linear relationship between the monthly charges incurred by the customer and the tenure of the customer. So he collects all of the data and builds a linear model between the monthly charges and the tenure. So here, monthly charges would be the dependent variable and tenure would be the independent variable. And in linear regression, there could be more than one independent variable. So if there's just one independent variable, it is known as simple linear regression. And if there's more than one independent variable, it is known as multiple linear regression. So guys, this is the underlying concept of linear regression, where we have one dependent variable and multiple or a single independent variable, and we try to understand the linear relationship between the dependent variable and the independent variables. So next, we're supposed to implement this simple linear regression in R on this empty cars dataset, where the dependent variable is this MPG column and the independent variable is this displacement column. So again, let's head back to RStudio and implement this simple linear regression. So this is our empty cars data frame, which comprises of all these columns. So we have MPG, the number of cylinders, displacement, horsepower, DRAT, weight, CUSEC, VS, AM, gear, and carb. So as the question stated, MPG is our dependent variable and displacement is our independent variable. And we want to try to understand how does MPG vary with respect to the displacement of this column. So now, before we go ahead and implement the model on top of this data frame, we are supposed to divide this data frame into training and testing set so that the model does not overfit the data. So what happens when we don't divide the data set into training and testing sets is it overfits this data set. And when we give it new data, it'll fail miserably on that new data. So that is why it is always necessary to divide a data set into train and test sets. So let's go ahead and do that. And to divide a data set, we would require this caret package. So let me load up this caret package, library of caret. And this caret package comprises of the create data partition function. Now, this create data partition function would give me true or false labels. And this create data partition function comprises of these parameters over here. First is the column which determines the split. So that is obviously the MPG column. And then we are supposed to give in the split ratio. So I am giving the split ratio would be 0.65. That is 65% of the labels of this column would have the true label and the rest 35% of the records would have the false label. And I am storing this into the split tag object. So again, I'm reiterating it. So I am taking this empty $MPG column data set and 65% of the records would have the true tag associated with it and the rest 35% of the records would have the false tag associated with it. And I'm storing this result in split tag object. Now, once I have the split tag object ready, what I'll do is from this entire empty cars data frame, I'll select all of those records where the split tag value is true and I will store those records in the training set. Similarly, from the empty cars data frame, wherever the split tag value is equal to false. So if I just give in split tag, it'll have all of the true values in it. And when I put in the minus symbol in front of the split tag object, it'll contain all of the false labels. And I will select all of these records and store them in the test set. So now we have our training and testing sets ready. Now let's have a look at the number of rows in training and testing set. So I'll type in n row of train. So see that there are 23 rows in the training set. Similarly, I'll type in n row of test. And now we see that there are 9 rows in the testing set. Now we'll go ahead and build a model on top of the training set. And to build the simple linear model, we would require the lm function. This lm function again takes in 2 parameters. First is the formula. So over here, the formula is MPG tilde symbol displacement. So whatever column we give on the left side of the tilde symbol, that is taken as the dependent variable, and whatever columns we give on the right side of the tilde symbol, all of them are taken as the independent variables. So this time MPG is our dependent variable and displacement is our independent variable, and we are building this model on top of the train set. and we'll store this result in mod underscore empty cars. So now that we've built the model on top of the train set, it's time to predict the values on top of the test set. So for that purpose, we'll be using this predict function, which again takes in two parameters. First parameter is the model which we've built, and the second parameter is the data frame on which we want to predict values. So we want to predict values for the test set, and I will store this in predict empty cars. Now let me have a glance at the predicted values. So head of pred empty cars. So these are the predicted values of MPG for all of these cars. So Mazda RX-4 WAG, the mileage predicted for this car is 22.55. The mileage predicted for Valiant is 20.04. The mileage predicted for Mercedes is 18.08, and so on. So this is how we can build a simple linear model on top of this empty cars dataset. So now we'd have to calculate the RMSE value for the model built. Now when we actually build a regression model, it predicts certain Y values associated with a given X value. But there always is an error associated with this prediction. So to get an estimate of average error during prediction, RMSE or root mean square error is used. So again, let's go ahead and calculate the RMSE value for the model which we've just built. So now that we have the actual values and the predicted values, let's bind both of them into a single data frame. So for that purpose, I will use the cbind function, and our actual values are basically present in this MPG column from the test set. And our predicted values are stored in this pred empty cars object, which we had created in the previous question. So I will create this new column and name that column to be actual. And again, similarly, I'll create another column and I'll name it as predicted, which would have the predicted values. And I will store this in a new object and name that to be final data. Let me have a glance at it. View of final data. So these are the actual values of all of the mileage, and these are the predicted values of the mileage for these cars. Now we see that there is an error present in the prediction. Now what we have is actually a matrix. So we are supposed to convert this matrix into a data frame. So I will use the as.dataframe function and convert this object into a data frame. So as.dataframe, I'll pass in this object, which is final data, and I'll store the result in final data again. Now I'll have a glance at the same thing. View of final data. So these are the actual values, these are the predicted values, and we see that there is an error present in the prediction. Now the error is basically difference between the actual values and the predicted values. So let's go ahead and calculate the error. All I have to do is subtract the predicted values from the actual value. So it'll be final data $actual minus final data $predicted. And I will store this result in a new object and name that object to be error. So now that we've done this, I will also go ahead and bind this error calculated to the same final data frame. So cbind, I'll bind the error object to this final data and I'll store the result in final data again. So it'll be view of final data. So this time we have the actual values, we have the predicted values, and we also have the error in prediction for each of these records. Now to get the average error which is present throughout all of the predictions, we would have to calculate the root mean square error. So the root mean square error, as the name states, first we'd have to calculate the error, then we'd have to take the square of it, then we'd have to take the mean of it, and then finally we'll take the square root. So this is how we can calculate the root mean square error. So final data $error, and we'll square this error first. After that, we'll take the mean of this squared error, and then finally we'll take the square root of the mean squared error.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So this is what we have. So the RMSE value for this model which we built is 4.33. Now you guys need to keep in mind that the lower the value of RMSE is, the better the model. So let's say if we had some other model and the RMSE value for that model was 5, then this model would be better than that model. Similarly, let's say if another model's RMSE value was 2, then the second model would be better than the model which you built. Now, similarly, we are supposed to implement simple linear regression in Python on this Boston dataset, where the dependent variable is this MEDV column and the independent variable is the LSTAT column. So now in the data science interview questions, it's not necessary that you'll be asked questions only with respect to one programming language. So you might be asked questions with respect to R and Python, both of them. So that's why it's necessary to be good with both of these languages. Right, so I'll head on to Jupyter Notebook and implement simple linear regression on top of this Boston dataset. So I'll start off by loading the pandas package. So I'll type in import pandas as PD, and then I'll load this Boston dataset, and to load the dataset I'll be using the read_csv function. So pd.read_csv and the name of the file, which is boston.csv, and I'll store this in the data object. So now that we've loaded the data, let me have a glance at the head of this data. So these are all the columns and the first 5 records present in the data frame. So we have CRIM, ZN, Indus, CAS, NOX, age, and so on. And for the task of simple linear regression, MEDV is our dependent variable and LSTAT is our independent variable. So this MEDV is basically the median value of price of the houses. And we are trying to understand what is the median value of the price of the houses with respect to this LSTAT column over here. Now, before we go ahead and implement the model, let's understand the dataset a bit more. So I'll use this data.shape, which would give me the number of rows and columns present in this data frame. So we see that there are 506 rows in total and 14 columns in total. Now I'll go ahead and separate the independent and dependent variable from this entire data frame. So for that purpose, I'll use this data.loc, and since I want all of the records, I'll take all of the records, and the only columns which I want from this entire data frame are LSTAT and MEDV. And I'll store this result in data1, and I'll also have a glance at the first 5 records of this data frame. So these are the first 5 records of this new data frame where I have only LSTAT and MEDV columns. Now I'll also go ahead and do a bit of visualization with respect to these 2 columns. And for that purpose, I would require the matplotlib package. So I'll go ahead and import this matplotlib package as well. So here what I'm doing is, I am mapping the LSTAT column onto the x-axis and the MEDV column onto the y-axis. And I will give the label of the x-axis as LSTAT and the label of the y-axis as MEDV. And finally, I'll show this graph which I've built. So what I've built is basically a scatter plot where MEDV is on the y-axis and LSTAT is on the x-axis. So you see that as LSTAT increases, MEDV decreases. So there is an inverse relationship between MEDV and LSTAT. So again, I'm reiterating it. As LSTAT increases, MEDV decreases. So this tells us that there is an inverse relationship between MEDV and LSTAT columns. Now, to build the model, we are supposed to separate the independent variable and dependent variable into 2 separate objects. So I'll take this LSTAT column from data1 and store it into X object. Similarly, I'll take this MEDV column from data1 object and store it in Y object over here. So X consists of my independent variable and Y consists of my dependent variable. Now it's time to divide the data set into training and test sets. So we have this train test split function from sklearn.model_selection. I'll go ahead and load that function, and this function over here takes these 3 parameters. So X and Y are basically the dependent variable and the independent variable, and then we have test size is equal to 0.2. So this states that 80% of the records would be in the training set and 20% of the records would be in the testing set. So it's a 80-20 split. And this random state which you see, so this is basically a seed value, so that if I want to get the same values again, I can set the same random state to get the same values. And I am storing these values in xtrain, xtest, ytrain, and ytest. So xtrain contains all of the train values for that independent variable. Xtest contains all of the test values for the independent variable. Similarly, Y train contains all of the train values for the dependent variable and Y test contains all of the test values for the dependent variable. So now that we have X train, X test, Y train and Y test, it's finally time to build the model. So I'll go ahead and load the linear regression model from sklearn.linear model and then I'll fit the model. So first I'll create an instance of this. So linear regression, and I'll create an instance and I'll name that instance to be regressor. And with the help of this instance, I'll fit the model on top of the training set. So regressor dot fit, and I will pass in X train and Y train. So to sum it up, what I'm basically doing is building the linear regression model on top of the training set, which basically comprises of the independent variable and the dependent variable. I'll click on run. Now let me have a glance at the intercept and the m value of it. So linear regression is nothing but y equals mx plus c. And that c is nothing but the intercept. So you see that the intercept is 34.12. And m, which you see, this is the coefficient. This coefficient is nothing but the slope. And you see that the coefficient is minus 0.91. So there is a negative value associated with the coefficient because there is an inverse relationship between the dependent variable and the independent variable, as we saw over here. So as LSTAT increases, MEDV decreases. And that is the reason this coefficient is associated with a negative value. So now that we've built the model, it's time to predict the values on top of the test set. So again, I'll use this instance and I will use the predict function with the help of this instance. So regressor dot predict, and I will pass in this X test object inside this function, and I'll store this in the ypred object. So we've built the model and we've also predicted the values. Now let me have a glance at the number of rows and columns of the actual values and the predicted values. So we see that both the predicted values and the actual values comprises of 102 records in total. So now that we predicted the values, we'll go ahead and calculate some metrics. So we'll find out the mean absolute error, the mean squared error, and the root mean squared error. I'll click on run. So see that the mean absolute error for this model is 4.69, the mean squared error is 43, and the root mean squared error is 6.62. So again, the lower the values of these three, it means the better the model is. So let's say if we are comparing these values with some other model, and if these values are less than that second model, then the first model would be better than the second model. So that was implementing simple linear regression in Python. Now we have our next question over here. So the question is, what do you understand by logistic regression? Well, logistic regression is actually a classification algorithm which can be used when the dependent variable is binary. So let's take this example. So here we are trying to determine whether it will rain or not on the basis of temperature and humidity. That is, temperature and humidity are the independent variables and rain would be our dependent variable. That is, we're trying to understand whether it will rain or not on the basis of the temperature and the humidity. And again, logistic regression algorithm, it actually produces an S-curve. So let's say x-axis over here, it represents the number of runs scored by Virat Kohli, and the y-axis represents the probability of Team India winning the match. So let's say this point over here, it denotes 50 runs. So what we can see from this graph is, so if Virat Kohli scores more than 50 runs, then there is a greater probability for Team India to win the match. And similarly, if Virat Kohli scores less than 50 runs, then the probability of Team India winning the match is less than 50%. So let's take this value over here. So let's say the number of runs scored by Virat Kohli is around 60. So if the number of runs scored by Virat Kohli is around 60, then the probability of Team India winning the match would be, let's say, around 65% or so. Again, let's take this value over here. So let's say this is around 97 runs or 95 runs. And if Virat Kohli scores 95 or 97 runs, then the probability of Team India winning the match is 1, which is 100%, isn't it? So similarly, this value over here. So let's say this is around 5 runs or 10 runs. So if Virat Kohli scores 5 or 10 runs, then the probability of Team India winning the match is 0. So basically in logistic regression, the y value lies within 0 and 1 range. And this is how logistic regression works. So now we are supposed to implement logistic regression on this hard data set where the dependent variable is this target column and the independent variable is the age column. So let's go ahead and implement logistic regression. So let me start off by loading this data set first. I'll use the read.csv function. Now let me have a glance at this data set, view of heart. So this is our entire data frame, and this target which you see, this is our dependent variable, and we have the age column over here, and this is the independent variable. So we are actually supposed to rename this. So we see that the column name is incorrect over here. So our first task could be to rename this column. Let me go ahead and do that. So I'll use the column names function and I'll pass in this data frame which is heart, and I am supposed to rename the first column. So I'll give in 1 inside the parenthesis and I will rename this to be age. So now again, let me have a glance at this modified data frame. So it'll be view of heart. So see that we have successfully renamed this column from IH to age. Now let me have a structure of this data frame. So structure of heart. So you see that most of these are integers. But then again, since we are building a logistic regression model on top of this data set, this final target column is supposed to be categorical. It cannot be an integer. So we'll go ahead and convert this into a factor. So I'll use the as.factor function and convert this integer value into a categorical value. So as.factor, and I'll pass in this column over here, which is hard $target, and I'll store the result back to hard $target. Now again, let me have a glance at the structure. So that will be structure of heart $target. So initially it was integer. Now we have converted that integer column into a categorical value, which has two levels, which are 0 and 1. So now I'll actually build a simple logistic regression model, and I'll not divide this data set into training and testing sets. So we'll do this and we'll see what are the different probability values for the person to have heart disease on the basis of the different age values. And to build the logistic regression model, we'll be using the GLM function. So again, this takes in 3 parameters over here. First parameter is the formula. So here target $age is the formula, which basically indicates that target is our dependent variable and age is our independent variable. And we are building this model on top of the entire data frame, and family is equal to binomial. So when we state family is equal to binomial, we are basically telling R that this is a logistic regression model, and I'll store the result in log mod 1. So now let me have a glance at the summary of the model which we've just built. So summary of log mod 1. So we have this p value over here, and we see that there are 3 stars associated with this p value. So this basically means that we can reject the null hypothesis. That is, the null hypothesis states that there is no relationship between the age and the target columns. But since we have 3 stars over here, this states that the null hypothesis can be rejected and there is a strong relationship between the age column and the target column. Now again, we have other parameters over here. So we have something known as null deviance and residual deviance. So simply put, the lower the deviance value, the better the model. So this null deviance basically tells us the deviance of the model when we don't have any independent variables. That is, when we are trying to predict the value of the target column with only the intercept. So if that's the case, then null deviance is 417.64. And residual deviance is that deviance when we include the independent variables and try to predict the target column. So when we include the independent variable, which is age, we see that the residual deviance drops. So initially when there were no independent variables, the null deviance was 417. After we included the age column, we see that the null deviance has reduced to 401. So this basically means that there is a strong relationship between the age column and the target column, and that is why the deviance has reduced. So now that we've built the model, we will go ahead and predict some values. So now I want to know the probability of the person not having heart disease when his age is equal to 30. So now let me actually head back to this data frame over here. So the values in this target column, it is 0 and 1. So when we predict the values, we get the prediction for 0. That is the person not having heart disease. So when the person's age is 30, we see that the probability of the person not having heart disease is 81.2%. Now similarly, I'll predict the probability of the person not having heart disease when the age is 50. So when the age is 50, we see that the person not having heart disease, the probability it comes down to 60%. Now what I'll do is, I'll predict the values for a set of age values. So this time the age value, it starts at 29 and it goes on till 77. So I'll get a set of predictions starting from 29 to 77. So you see that when the age is 29, the probability of the person not having heart disease is 82%. Similarly, when the age of the person is 30, the probability of the person not having heart disease is 81%. So as the age increases from 29 to 77, the probability of the person not having heart disease decreases. So this is the final case over here when the age of the person is 77. So when the age of the person is 77, the probability that the person does not have a heart disease is 26%. So this is quite an interesting relationship, isn't it? So we see that as the age of the person increases, there is more likelihood that the person would have heart disease. So this model we built on top of the entire data set. Now what we'll do is, we'll divide this data set into train and test sets and build the model on top of the train set and predict the values on top of the test set. So again, for that purpose, I would require this caret package. So library of caret. Again, this caret package comprises of the create data partition function. So this takes in these parameters over here. So this is the split criteria, which is hard dollar target. That is, I want to split this data frame with respect to this target column. And the split ratio, which I'm stating over here, is 0.7. That is, 70% of the records would have the true label associated with them, and the rest 30% record the false label associated with them. And the final result, I am storing it in split tag. Now, what I'll do is, from the entire hard data frame, whichever records have the true label associated with them in the split tag, I'll take all of those records and I'll store them in the training set. Similarly, from the entire hard data frame, wherever the split tag value is equal to false, I'll take all of them and I will store them in the test set. So I have my training and my testing sets ready. Now let me have a glance at the number of rows of the training and testing set. So n row of train, there are 213 rows, and n row of test, there are 90 rows. So now that we have the training and testing sets ready, let me go ahead and build the model on top of the training set. So again, we'll use this GLM function and build the model. So this time the formula is the same, which is basically target tilde symbol age. So target is the dependent variable, age is the independent variable, and we're trying to determine the probability of the patient having heart disease with respect to his age. And we are building this model on top of the train set. And since this is a logistic regression model, the family would be equal to binomial, and I'll store this result in log mod 2. Now that we've built the model, it's time to predict the values. So I'll use the predict function, and this again takes in these three parameters. First is the model which you've just built, and then second parameter is the object on which you want to predict the values. So we want to predict the values on top of the test set. And finally, we'll set the type to be equal to response, which will basically give us probabilities for these predictions, and I'll store the result in pred hard. So let me have a look at the range of the predicted values. So we see that the range of the predicted values of the heart disease, it varies from 0.21 to 0.86. That is, the probability of the patient having heart disease, it varies from 21% to 86%. And this is how we can build a simple logistic regression model on top of this heart disease dataset. Now let's head on to next question. Metrics. So confusion matrix is actually a table which is used to estimate the performance of a model. It tabulates actual values and the predicted values in a 2x2 matrix. So these are the actual values and these are the predicted values. So this what you see, true positives. So this denotes all of those records where the actual values were true and the predicted values were also true. So these denote all of the true positives. After that, we have the false negatives. So false negatives denotes all of those records where the actual values were true, but the predicted value was false. So where the actual value is true, but the predicted value is false, that is known as a false negative. Then we have false positives. So in false positive, the actual value is false, but the predicted value is true. And such values are known as false positives. And finally, we have the true negatives where the actual values are false and the predicted values are also false. So if we want to get the correct values, then correct values would basically represent all of the true positives and the true negatives. And this is how confusion matrix actually works. So now we are supposed to build a confusion matrix for the model which we built, where the threshold value for the probability of predicted values is 0.6, and then we have to find the accuracy of the model. So as I've already stated, accuracy is basically true positives plus true negatives upon all of the values. So this left diagonal represents all of those values which have been correctly classified, and this right diagonal represents all of those values which have been incorrectly classified. So when we divide the left diagonal with all of the values, that is when we'll get the accuracy of the model. So let's go to RStudio and find out the accuracy of the model which we built. So to build a confusion matrix in R, we'll be using the table function, and inside the table function, first we'll give in the actual values and then we'll give the predicted values. So the actual values are stored in this target column of the test set, and the predicted values are stored in the pred heart object which we had created. And then we saw that the range of the probabilities, it was from 0.2 to 0.8. So from that range of 0.2 to 0.8, I am setting a probability threshold of 0.6. That is, wherever the probability is greater than 0.6, it will be classified as 0. Or in other words, it will be classified that the person does not have heart disease. And similarly, wherever the probability is less than 0.6, it will be classified as 1. Or in other words, that the patient has heart disease. So I'm reiterating it again. So wherever the probability of pred heart is greater than 0.6, it will be classified as 0. And wherever the probability of pred heart is less than 0.6, it will be classified as 1. So let's go ahead and build a confusion matrix. So see that this is our confusion matrix, and this left diagonal represents all of those values which have been correctly classified, and this right diagonal represents all of those values which have been incorrectly classified. And if you want to find the accuracy, all we have to do is divide this left diagonal with all of the values. So that'll be 31 plus 17 divided by 31 plus 17 plus 10 plus 32. So you see that we get an overall accuracy of 53% for this model which we built. Now let's head on to the next question. So what do you understand by true positive rate and false positive rate? So let's start with true positive rate. So in machine learning, true positive rate, which is also referred to as sensitivity or recall, is used to measure the percentage of actual positives which are correctly identified. So the formula for true positive rate is true positives divided by all the positives. So I am stating it again. True positive rate is basically the measure of the percentage of actual positives which have been correctly identified. Now let's look at false positive rate. So false positive rate is basically the probability of falsely rejecting the null hypothesis for a particular test. So the false positive rate is calculated as the ratio between the number of negative events wrongly categorized as positive, that is all of the false positives, upon the total number of actual events. So this is how we can calculate true positive rate and false positive rate. Now we have the next question, and we're supposed to explain what is ROC curve. So ROC curve, which actually stands for receiver operating characteristic, is basically a plot between the true positive rate and the false positive rate. And it helps us to find out the right trade-off between the true positive rate and the false positive rate for different probability thresholds of the predicted values. So the closer the curve is to the upper left corner, the better the model is. Or in other words, whichever curve has greater area under it, that would be the better model. So let's say we have this curve over here, and let's say there is another curve which goes like this, which is nearer to this upper left corner. Then in that case, since the second curve covers greater area under it, that would be a better model than the first model. So this ROC curve helps us to find out the area under the curve as well as the right trade-off between the true positive rate and the false positive rate. Now we are supposed to build the ROC curve on top of the logistic regression model which we've built. So let's head back to our studio and do that. So to build the ROC curve, we would have to load the ROCR package. So I'll use the library function and load up the ROCR package. Now, this ROCR package comprises of the prediction function, which would give me a prediction object. So this takes in two parameters. First parameter is all of the predicted values. So this spread hat comprises of all of the predicted probabilities for the target column. And the second parameter is the labels of the dependent variable. So test $target has all of the labels of the dependent variable, and I will store this result of the prediction object in ROC spread hat.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So, now that we've created the prediction object, we can go ahead and build the ROC curve. And to build the ROC curve, we'll use the performance function, which is again a part of the ROCR package. So this over here takes in three parameters. First is the prediction object, which we've built. So the name of the object was ROC spread hat. After that, we will just give in TPR and FPR. So TPR and FPR stands for true positive rate and false positive rate. So for this prediction object which we built, we are basically trying to find out the right trade-off between the true positive rate and the false positive rate, and I'm storing the result in ROC curve. Now let me go ahead and plot this ROC curve which I've just built. So this is our ROC curve over here. Let me zoom this. So we have this curve for different probability values over here. So this what you see are the different probability values. And our ideal curve should be something like this, where we have more of true positives and less of false positives. And this green color which you see, so this green color actually represents the ideal threshold value. So the ideal threshold value over here would be somewhere between 0.48 and 0.62. So this is where we would have the ideal threshold value of the probability, and this is somewhere where we can get the right trade-off between the true positive rate and the false positive rate. So maybe it could be this over here. So this point which we see, so the probability would be somewhere around 0.5 or somewhere around 0.55. So this is where we could get the right trade-off between the true positive rate and the false positive rate. So now that we've built a logistic regression model in R, again we need to know how to build a logistic regression model in Python. So this time we are supposed to build this logistic regression model on top of this customer churn data frame, where the dependent variable is this churn column and the independent variable is this monthly charges column. And after that, we are supposed to find out the log loss of the model. So we are basically trying to determine whether the customer would churn or not on the basis of this monthly charges column. So again, I'll start off by loading the pandas data frame and also load the customer churn.csv file. And for that purpose, I'll be using the pd.readcsv function. Right, so we have successfully loaded the file. Now it's time to have a glance at the head of this data set. So these are the different columns which we have. So we have this customer ID, then we have the gender of the customer, we have the senior citizen column, which tells us whether the customer is a senior citizen or not. This column tells us whether the customer has a partner or not. This column tells us if the customer has any dependents or not, the tenure of the customer, whether the customer has phone service or not, and so on. Sort of all of these columns, the columns which are of our concern would be the monthly charges column and churn column. So this monthly charges column basically tells us the monthly charges incurred by the customer in dollars, And this churn column tells us whether the customer would churn or not. So now since we have our data set, the data set with us, let me go ahead and separate the dependent variable and the independent variable into two separate objects. So I'll store this monthly charges column from this customer churn data frame in the X object. Similarly, I'll store this churn column from the customer churn data frame in the Y object. So we have our dependent variable and independent variable to be separate. Now I'll go ahead and divide this model into training and testing set. And for that purpose, I would require this train test split function, which is part of the sklearn.model selection package. Now I'll use this train test split function, and this takes in these parameters. First are basically the independent variable and the dependent variable. So the independent variable is stored in X and the dependent variable is stored in Y. After that, I'll set the test size to be equal to 0.3. So this basically states that 70% of the records would be in the training set and the rest 30% of the records would be in the test set. And again, I'll set a random state value so that I can use these same values again if I want to. And I am storing all of these values into xtrain, xtest, ytrain and ytest. So xtrain comprises of the training set of the independent variable. Similarly, xtest comprises of the test set for the independent variables. After that, we have ytrain, which comprises of training set for the dependent variable. And then we have ytest, which is the test set for the dependent variable. So now we have xtrain, xtest, ytrain and ytest. It's time to build the model, predict the values and get the log loss value. So first I will import this logistic regression function from this sklearn.linear model package, and I'll create an instance of logistic regression. I'll store it in L and then I'll fit the model on top of the training set. So L.fit, and I'm fitting the model on top of xtrain and ytrain. After that, I'll predict the probabilities on top of the test set. So L.predict_proba, and I'll pass in x_test, and I'll store the predicted probabilities in y_pred. So now that we've fit the model and also predicted the probabilities, it's time to look at the metrics. So the question stated that we were supposed to find out the log loss. So I'll just import the log loss from sklearn.metrics, and inside this log loss function, I will pass in the actual values and the predicted values. So actual values are stored in y, predicted values are stored in ypred. So we get a log loss value of 0.55. Now again, similar to RMSE, the lower the value of log loss, the better the model is. So again, let's say if there is another model and the log loss value of that second model is less than this, then that second model would be better than this model. Now we'll head on to the next question. So what do you understand by decision tree? So decision tree is a supervised learning algorithm which is used for both classification and regression. Right. So decision tree can be used for both classification purpose as well as regression purpose. So in this case, the dependent variable can be both a numerical value as well as a categorical value. So there is a flowchart like structure where the topmost node is known as the root node, the internal nodes with children are known as the branch nodes, and the final nodes without children are known as the leaf nodes. So here, each node actually denotes a test on an attribute, and each edge represents an outcome of the test, and each leaf node holds a class label. So let's say this first node over here, we are trying to determine the age of the patient. So let's say if the age of the patient is greater than 50. If the condition is true, we'll come here. If the condition is false, then we'll come here. After that, over here, we'll check if the person smokes or not. And if that person smokes, we'll come here. If that person doesn't smoke, we'll come here. Similarly, over here, the test condition could be whether the patient has any children or not. If the condition is true, we'll come here. If the condition is false, we'll come here. So this is how the decision tree works. And finally, we'll have class labels over here. So these would represent individual class labels. So let's say this represents that the person has cancer. This represents that the person does not have cancer. Similarly, this would represent that the person has cancer. And again, this would represent that the person does not have cancer. So in decision tree, we basically have a series of test conditions which would give us the final class labels. Right. So now we have to build a decision tree model on top of this iris dataset where the dependent variable is the species column and all other columns are independent variables. And after we build the model, we are supposed to find out the accuracy of the model. So let's go ahead and do this. So I'll start off by having a glance at the iris dataset. View of iris. So this is our data frame which comprises of all of these columns over here. And to build a decision tree model, we'll be loading the party package. So library of party. So again, before I go ahead and build the model, our task is to first divide this data frame into training and testing sets. So again, I will load up this caret package, library of caret. I'll use this create data partition function. And this create data partition function takes in the species column as the split column, and I'll give the split criteria to be 0.65. That is 65% of the records would be having the true label and the rest 35% of the records would be having the false label, and I'll store that in split tag. Now from the iris dataset, wherever the value of split tag is equal to true, I'll store that in the train set. Similarly, from the entire iris dataset, wherever the value of split tag is equal to false, I'll store that in the test set. Now again, let me have a glance at the number of rows of the training and testing set. So you see that there are 99 rows in the training set and there are 51 rows in the testing set. So now again that the train test split is done, we can go ahead and build a model. And to build the model, we'll be using the ctree function, which is a part of the party package. So this again takes in two parameters. First parameter is the formula. Next parameter is the data set on which we are supposed to build the model. So here the formula is species tilde dot. So this tells us that species column is the dependent variable, and when you put a dot on the right side of the tilde symbol, that basically means that all other columns except the dependent variable are the independent variables. So sepal length, sepal width, petal length and petal width, all of them would be the independent variables and species would be the dependent variable. And again, we are building this model on top of the train set, and I'll store this result in my tree object. So now that we've built the model, let me plot it. So plot, and I'll pass in this object, which is my tree. Now let me zoom this. So this is our root node, and the root node, the split criteria is on the basis of the petal length column. So we see that if the petal length is less than or great, so see that if the petal length is less than or equal to 1.9, then we come over here and this tells us that the species of the flower is setosa. On the other hand, if that is not the case, that is, if petal length is greater than 1.9, then we have another test condition over here. So here we check if petal width is less than or equal to 1.7. And if it is true, again we have two scenarios. So here we are checking if petal length is equal to or less than 4.7. So if petal length is equal to or less than 4.7, then there is a 100% probability that the species of the flower is versicolor. Similarly, if the petal length is greater than 4.7, then there is around a 60% probability that the species is versicolor, and there is around a 40% probability that the species is virginica. On the other hand, from over here, if we directly come over here and if we check that petal width is greater than 1.7, then in that case, there is almost a 100% probability that the species of the flower is virginica, right? So these are the test conditions on the basis of which we are trying to determine to which class does the species belong to. So now that we've built the model, let's go ahead and predict the values. So I'll use the predict function again. This takes in these parameters. First is the model which we built. So the name of the model is my tree. And then this is the data set on top of which you want to predict the values. So we want to predict the values on top of the test set. And then finally we want the response. And that response I'm storing in my pred object. Now after this, let me go ahead and build the confusion matrix. And to build the confusion matrix in R, we'll be using the table function. And the first parameter includes all of the actual values and the second parameter includes all of the predicted values. And this is what we have over here. So this denotes all of those records where the actual value is setosa And all of those actual values have been correctly predicted as setosa. So there are 17 such instances. So this denotes all of those records where the actual value is versicolor and all of them have been predicted as versicolor. So there are 16 such instances. And this one denotes those records where the actual was versicolor but it has been incorrectly classified as virginica. Similarly, this one over here, this states that there is one record where the actual value is virginica, but it has been incorrectly classified as versicolor. Similarly, this 16 which we see. So out of the 16 records which were actually virginica, all of those 16 records have been correctly classified as virginica. Now again, to find out the accuracy, we are supposed to divide this left diagonal with all of the values. So that'll be 17 plus 16 plus 16 divided by 17 plus 16 plus 16 plus 1 and 1. So you see that we get an accuracy of 96% for the model which we've built. Now let's head on to the next question. So what do you understand by random forest model, and also explain the working mechanism of random forest? So random forest is an ensemble model. That is, it combines multiple models together to get the final output. And to be precise, it combines multiple decision trees together. Now let's understand the working mechanism of random forest model. So let's say we have this dataset A and we have n records in it. Now what I'm going to do is draw samples from this dataset. So this actually will be sampling with replacement. That is, I'll take one record from dataset A, take note of it, and enter the same sample in dataset A1, and then put the record back to where it came from. And I'll repeat this process n times so that there are n records in dataset A1 as well. So what you need to keep in mind is, out of these n records in A1, some of them might have come twice, thrice, or even several times over, while some records from A might not have made it at all to A1. So I've created A1 like this. Now I'll go ahead and create multiple datasets the same way, and each of these have the same number of records as A. And the X over here, it could be anything. Let's say 100, 500 or 1000. So from just one dataset A, we were able to create multiple datasets for our advantage. So just for our sake, let's say the dataset A has 1000 rows and the value of X is also 1000. So it would be 1000 cross 1000, which would give us 1 million rows. That is, from just 1000 rows of data, we were able to create 1 million rows. Now for each of these X data sets, we'll fit X decision trees. Now let's say this A1 dataset over here has 10 independent variables. So what happens in a random forest is, each time a node is being split in a decision tree, not all 10 columns will be provided to the algorithm. This is important, so I am reiterating it, guys. So each time a node is being split in a decision tree, not all 10 columns will be provided to the random forest algorithm. So now the question arises, what would be made available to the algorithm? So only a random subset of these 10 columns will be available to the algorithm. So let's say I want to split this root node now. So instead of providing it all the 10 columns, only a subset of the columns will be provided. So let's say 3 columns. And it could be any 3 out of the 10. And with those 3, the algorithm goes on to split the node. And similarly, from the left node over here, it is again going to be provided with a random set of 3 variables. And it is not necessary that the left node should get the same 3 variables. It can be a different set of 3 columns altogether. So whenever we are splitting a node, it is given a random set of m predictors from the entire predictor space. And the reason this is done is to make each of these X trees very, very different from each other. Now let's say a new record Ri comes our way. Then we are going to pass this record to each of these X trees, and we are going to get each tree's prediction on what class this new record is going to represent. And since we have X trees, we'll get X predictions in total.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And to get the final prediction, all we have to do is select that class which would have the majority of the votes across all the predictions of the individual trees. So guys, this is the working mechanism of random forest. So now we'd have to go and build a random forest model on top of this CTG dataset where NSP is the dependent variable and all other columns are independent variables. So let's head on to RStudio and implement the random forest model. Right, so let me start off by loading the CTG dataset. So I'll use the read.csv function and load this file. Now let me have a glance at this data. So view of data. So this is our dataset which has all of these rows and columns. And this is our dependent variable where we have these three values 1, 2 and 3. So this 1 basically means that the person does not have cancer, 2 means that the person is suspected to have cancer, and 3 means that the person has cancer, right? So these are the three different levels associated with this NSP column. Now, let me have a glance at the structure of this dataset. So structure of data. So we see that this NSP column is actually an integer. So we'd have to go ahead and convert this integer type into a factor. So I'll use the as.factor function and convert that NSP column from an integer to a factor, and I'll store that back to same column, data $NSP. Now let me have a glance at the structure of it again. So structure of data. So see that initially this column was an integer. So using the as.factor function, we have converted this into a factor with 3 levels. Now let me have a glance at the frequency of the values of this NSP column. So see that there are 1655 patients who don't have cancer, 295 patients who are suspected to have cancer, and 176 patients who do have cancer. So now, before we go ahead and build the model, we are supposed to divide the data set into train and test sets. So first we'll set a seed value. So that seed value would be 1, 2 and 3. Now I'll go ahead and create the data partition, and the split column is basically this NSP column, and the split ratio which I'm giving over here is 0.65. That is 35% of the records would be in the test set and the rest 65% of the records would be in the training set. And I'll store this in split tag again. Now from this entire data object, wherever the value of split tag is equal to true, I'll store all of those records in the train set. Similarly, from the entire data object, wherever the value of split tag is equal to false, I'll take them and I'll store them in the test set. So we have our training and testing sets ready. Now again, let me have a glance at the training and testing sets. So n row of train, there are 1383 records in the training set. Similarly, n row of test, there are 743 records in the test set. So now that we've divided the data into training and testing sets, I can go ahead and build the random forest model. So for that purpose, I'd have to load the random forest package. So I'll use library of random forest and I'll load up the random forest function. Now again, I'll set a seed value and the seed value would be 222 and I'll build the model. And I am building the model on top of the train set. So I'm using the random forest function. And this random forest function again takes in two parameters. First parameter is the formula. Second parameter is the object or the data set on which we are supposed to build the model. So the formula is nsp tilde dot. That is, this nsp column is our dependent variable and all other columns would be our independent variables. And we're trying to determine whether the person does not have cancer, is suspected to have cancer, or has cancer with respect to all of the other columns. And we are building this model on top of the train set, and I am storing this result in the RF object. Now that we've built the model, let me go ahead and predict the values on top of the test set. So again, I'll be using the predict function. This again takes in two parameters. First is the model which we've just built. So the model which we've built, the name of that model was RF, and we are supposed to predict the values for the test set. So I'll give in test over here and I will store the result in the P1 object. Now let me build a confusion matrix for this. So table, and this table function will take in the actual values and the predicted values. So the actual values are stored in the NSP column of the test set and the predicted values are stored in the P1 object. So this is what we have. So this left diagonal represents all of those values which have been correctly classified. So this 567 which you see, so this represents all of those records where the patient actually did not have cancer and it was correctly classified by the model that those patients did not have cancer. So this 8 which you see, this tells you that there were 8 patients or 8 records where the patient did not have cancer, but then again it has been predicted that the patient is suspected to have cancer. Similarly, this 4 over here, it represents those records where in actuality the person did not have cancer, but it has been predicted that the person has cancer. Similarly, if we take this row over here, this 20 represents all of those records where that person in actuality is suspected to have cancer, but it has been incorrectly classified that the person does not have cancer. And this 81 represents all of those records where the person is in actuality suspected to have cancer and it has been correctly classified, and that is how it goes for the rest of the records. So if you have to calculate the accuracy, we are supposed to divide this left diagonal with all of the values. So that will be 567 plus 81 plus 51 divided by all of the values. So 567 plus 81 plus 51 plus we have 2 plus 3 plus 8 plus 4 plus again 2 plus 5 plus 5. And this gives us an accuracy of 96%. So what I've done is I have divided this left diagonal with all of the values, and for the model build I got an accuracy of 96%. So guys, these are some of the questions which you frequently come across when you appear for data science interviews.
Just a quick info, guys. Intellipaat provides online data science master program in partnership with IBM. The course link of which is given in the description below.